Welcome to React Basics. In this course, you'll be introduced to the basics of working with React. During this module, you'll learn how to develop a working familiarity with the basic structure and use of the react.js library, explore the concept and practical use of state and state management, and discover how to set up navigation and make use of assets in your React apps. You'll begin by learning how to work with React to build modern user interfaces, or UIs, on website front ends. This involves the concept of standalone parts of the user interface, or UI. These standalone bits of UI are commonly referred to as components. You'll explore components in more detail later in this module. For now, it's enough for you to know that every website's UI is built on a foundation of components and composability. Simple components combine into more complex ones, which eventually merge to form a website. So, a website can essentially be viewed as a highly complex component. Components in website UIs are not limited to React, but a part of the reason why React is so popular is because it streamlines the process of building and composing components. React does this efficiently and without a significant impact on your browser's resources. Another major topic that will be discussed in this course is working with state in React apps. You'll learn a lot more about state as you go through the course, but for now, here's a simple definition of state. State is simply all the values of all the variables your app is working with at any given point in time. As you progress through this course, you'll also learn about how to style your React apps, which includes the reuse of common styles, setting up your apps to respond to events such as clicks and user-submitted data, creating navigation routes and using assets, and you'll finish off the course with a portfolio project where you'll apply your new knowledge. I hope you're as excited as I am to begin this course on React Basics. Let's get started.
My team uses React, and we use a lot of new and experimental features that the React team is building. Facebook.com is like a demonstration of all the new and cool features that React engineers are working on. So when we rewrote the website, we were actually using a lot of unreleased features and kind of experimenting with a lot of new things that the React team was building, which was really cool to kind of use it first. My name is Katie, and I'm a software engineer on the React apps team at Meta, and we work on building a variety of new features for Facebook.com. There are plenty of React-based apps that you've probably used before. Facebook and Instagram are two examples, but Netflix, Airbnb, New York Times, and a variety of other companies also use React for their websites as well, so you've likely encountered it before. These websites that tend to have really interactive UIs are more likely to be using something like React. So Facebook.com had become really not performant and not modern looking after the 10 or so years that we had been using it. We had squeezed all of the performance wins that we could out of Facebook.com. So really the only option at that point was to rewrite it on a different stack that was going to be a lot faster and a lot easier to build on. Basically, there was a need for having a really fast and responsive UI, and React fills all of those needs. So this was kind of a shift in thinking differently about how we build on web. We actually rewrote our website a couple years ago to be completely React. And so every engineer who's writing for Facebook.com at Meta is pretty much using React. I was there for the middle of it to finally launching it. So it was cool that a little bit of it was already written and we were getting prepared to show it to real users. I think 40 engineers on our team were all working on building out this MVP of the redesigned Facebook.com. And we would work with a variety of product teams to get them to also rewrite their product on our new stack as well. It was a really big effort, and it was also a really big risk. Not all the teams that we talked to thought that we could ship this new version of Facebook.com. So we really had to prove that it was faster. It obviously looked more modern, but we had to prove that it would really help these product teams deliver the best version of their product that they could on web. So React is open source, meaning that anyone can contribute to it. And those engineers are working full-time on React. But we also have developers who aren't at Meta who are also contributing to React. And that means that there's a really strong community around React. And a lot of people are really excited to build on it and make improvements to it. So if you ever have any questions or you have an idea about a certain feature or optimization or improvement, there's really like a great opportunity to actually contribute to the React library itself. So there's a React team at Meta, and this team is comprised of engineers who are working on React full-time, but there's also a group of developers outside of Meta who are contributing to React as well. I think the open source part of it is really cool just because there's such a community around React. It's constantly being updated and maintained, and there's always going to be someone available to like answer questions or to update documentation. It's very current. If you're using React for the first time, definitely take a look at our documentation. There are a lot of conversations being had about React online, and we actually have a React conference every year where we talk about new features with React, and you can just connect with a lot of React developers. So there are plenty of opportunities to get involved in the React community, and I think it makes building with React even more rewarding if you kind of connect with the community as well. React is used everywhere in the tech world, and you'll have the chance to use it throughout your career, so it's a very valuable skill set to have. Yeah. My name is Katie, and I'm a software engineer on the React apps team at Meta, and we work on building new features using React for Facebook.com. My first encounter with React was actually in a senior design project back at college. We were looking for a great client-side library to use for an app that we were building, and React seemed like the easiest to use and the fastest to build on. I had already gotten my job at Meta, but I didn't know what I was going to be working on at Meta, so it was cool to kind of get this experience with React, realized I really enjoy working with it, and then get to do it in my day-to-day work. So I feel like in school you tend to do a lot of object-oriented programming, which uses inheritance. React doesn't use any of that. It uses something called composition. So that was a little bit difficult to think about, but there's so much documentation around React and such a strong community that it's easy to pick up, and you have support coming from so many different places. You can just go onto YouTube and watch a video, read through the documentation, or look at other open source projects that use React. So there's so many resources to pull from. I think developers outside of Meta choose to use React for the same reasons that we do at Meta. It's super easy to learn and pick up. You're able to create really custom UIs with React. We're building so many different features on Facebook.com every day that require a lot of custom components and UIs, so it's nice to have the flexibility that React provides. I would say React is the best choice for an app if your UI is really custom and you're looking for a lot of flexibility with what other libraries you can integrate for your app or website. React is just a front-end library. You're going to need to interact with other third-party libraries too. And if you want the flexibility of integrating with Redux or other third-party libraries, React is the perfect choice for you. React is also great if you have complex UIs where you want to reuse code across many different pages. So I think it's a great choice if you're building a complex website with a ton of features across a ton of different pages. I think React solves the problem of code reusability really well. Here at Meta, we have a core set of UI components that we're actually able to reuse across the site. And this means that we're able to build a lot of functionality into these core UI components, like accessibility. I think we're able to have a high quality bar across the site just because we're reusing components everywhere, and we're able to kind of share code even across Facebook and Instagram and Messenger. So I think that's a really unique part of React. It's really interesting because if I find a bug in a core UI component and I fix it, I'm not only fixing it for my one use case, I'm fixing it for use cases across the site. So I think it's a really smart way to use engineering effort. You're fixing a bug once and you're solving one problem everywhere. So I would say the biggest competitor of React is Angular. Angular is a bit different from React in that it's a full-fledged solution for an app or website. You don't really need to integrate with third-party libraries when using Angular, whereas with React, it's just a client-side library. So you do need to figure out how you're going to do routing and server-client communication. I would say React provides more flexibility with creating these complex custom UIs, whereas Angular makes it easier to create a single page web application with an out-of-the-box solution. Learn by doing. Try to make an example app. Don't go and try to create the most complex app you've ever heard of. I would say start simple. Make sure you're using best practices. Continuously reference documentation to see if you're using hooks the way you're supposed to and that sort of thing. And it should come pretty easily. I think one of the great benefits of React is how easy it is to pick up and learn. There are a lot of different pieces of React and a lot of different concepts to learn, but it's really well worth it in the end because you're going to encounter React in your day-to-day work, hopefully for the rest of your career. And there's a huge community behind you ready to help and answer questions about React too.
Recall the concept of the single page application, or SPA for short. This is a one-page website where some of the page's content changes based on user interaction. SPAs differ from traditional websites where each web page needs to be loaded as the user navigates around the site. This frequent reload can be considered inefficient as some of the same content such as logos, navigation and footers need to be loaded again. And one of the most popular ways to build an SPA is with the React library from Meta. React is used to run many of the world's most popular websites. Often on these sites, you'll type a search term into the site's input box. The site then returns the relevant content or results. But you might notice that even though the content has updated, the site's URL doesn't change. As SPAs only load the content as required, they can be ideal for businesses and enterprises who need a web app that offers rich user interfaces, speed, scalability, and flexibility. As an aspiring developer, you may feel like there are a lot of new concepts and processes to understand when working with React, but you can be sure that you will have an opportunity to get familiar with and use them. In this video, you will learn about the basics of React by exploring the concepts of the component-based architecture, components, and the virtual DOM. Let's begin with components, one of the core building blocks of React. When Meta released the React library, it included the concept of something called component-based architecture. This is essentially a design philosophy for building software based on reusable components of code. Each component consists of well-defined functionality that can be inserted into an application without requiring modification of other components. Because components are reusable, they can be used multiple times and easily inserted anywhere where needed. This results in components that can exist within the same space, yet interact independently from each other. One of the advantages of developing using components is that many developers can work on the same project without interfering with the code of other developers' components. As you may recall, modern front-end web development revolves around the concept of creating standalone parts of the user interface, or UI for short. Well, in React, these standalone parts are created using components, which form the foundation of all UI design. It's important to know that all UI is composed of simple components that can be combined into more complex components. In fact, you can think of an entire website as just a collection of components. For example, consider the product checkout page of an e-commerce web application. The page consists of three sections: a header, a payment section, and a sidebar. The header section contains the company logo with a navigation menu and a button to view the shopping cart. The payment section area contains a form where the user inputs their payment information. Finally, there's a sidebar with the order summary information. As the components are self-contained, they have their own HTML, CSS, and JavaScript logic for functionality. For example, the payment section component has a JavaScript function that submits a payment when a button is clicked. It's important to know that the use of components in website UI design is not limited to just React. Many websites' front-end or UI are built on the foundations of components and composability. But React is a powerful tool for streamlining the process of building components and composing them. It performs these actions efficiently as components are rendered to the DOM without significantly impacting the browser's resources. This is called component rendering, and you'll learn more about this and its associated render method later. You may recall that the DOM is a logical tree-like structure representing the HTML document, and it uses nodes to describe the various parts of the document. Before React, you could still build component-style layouts. However, it involved much more complicated DOM manipulation and code, making the layouts more complex and harder to work with. This resulted in something known as spaghetti code, a term developers use in web development to describe code that is complex, convoluted, and difficult to understand, like spaghetti. React prevents this spaghetti code by avoiding any manipulation of the DOM. Instead, React provides something known as the virtual DOM. You may recall that this is an in-memory representation or clone of the real DOM, which minimizes updates to the DOM itself. React uses the virtual DOM to update the browser DOM only when needed. This ensures that the update is as minimal as possible, increasing the application's speed and performance. In this video, you learned about the basics of React by exploring the concepts of the component-based architecture, components, and the virtual DOM. Recall how you learned about functions in JavaScript? They are reusable blocks of code that can take an input, perform some procedure or calculation, and then return an output. Well, a React component acts much like a traditional JavaScript function. In this video, you'll continue your exploration of the structure of the React architecture by learning about functional components, component types, JSX, and transpiling. React provides two types of components: functional components and class components. They behave very similar in React to traditional functions and classes in JavaScript. Don't worry about class components for now, you'll learn more about them later. Instead, let's just focus on functional components which act like a JavaScript function. In the default React application, only one component is rendered, and it's the app component located inside the index.js file that's located inside the source folder. It's important to know that every React app must contain at least one component, and it's called the root component. This component is loaded using the import statement. You'll learn more about the import statement in React later. For now, just know that it's used to import code needed for React to work, such as the import React and import React DOM statements. The syntax to render a component is very similar to a self-closing tag in HTML. You just place the component name inside the left and right angle brackets, and don't forget the /. The root component can contain other components that developers create to represent the various UI parts of the application, like in the e-commerce example that you learned about earlier. And recall that this component is ultimately converted to a DOM fragment and placed into the existing DOM as a child of the HTML div element with an ID of root. This div element is then rendered to the browser. If you analyze the app component, you'll notice that it looks very similar to a JavaScript function with some HTML code inside. You may also notice an export default statement. You'll learn more about this soon. For now, just know that you need it to make your components available. Okay, so now that you're familiar with the concept of functional components, let's explore how web developers create them in React. React is scripted using a special kind of syntax called JavaScript XML, or JSX. For many React developers, this is known as a syntax extension to JavaScript. So, what is JSX syntax like? Let's find out by going back to our React default app component. Recall that in the return statement of the app function, it seemed that some HTML content is returned. Well, this content is not exactly HTML, it's JSX. JSX syntax looks very similar to HTML, and one of its advantages is that it allows you to write JavaScript code inside what looks like HTML elements. In fact, you can think of JSX as a combination of custom HTML and JavaScript. This allows you to make your website dynamic. You'll learn more about the differences between HTML and JSX later. For now, just know that you can place this syntax inside the return statement of a functional component. It's also important to know that a React component won't render until it's used as a JSX element, just like a JavaScript function declaration won't run until it's called or invoked. Okay, so now you know what JSX is. Let's explore the steps involved to create a React component, which will contain some JSX code inside a heading 1 HTML element to display some text on a web page. First, you create the component, which is basically just a JavaScript file. Since its purpose is to return some heading text, you name the file heading.js. Notice that the first letter of the component name is capitalized. This is because there's a difference in how React treats capitalized and non-capitalized component names. So it's important to remember that all component names in React must be capitalized. Why is this? Well, because React treats lowercase components as regular HTML elements. Capitalizing a component name helps React to distinguish JSX elements from HTML elements. Now let's continue with our component. Next, inside the app.js file, create a function named heading. The function name must also be declared using a capital letter for the first letter of the function. Then, inside the function body, you create a variable named title and assign it the string value of "this is some heading text." Now you're ready to create the return statement of the function. Inside the parentheses of the return, insert a heading1 tag and inside it, place the variable named title. To make React evaluate the title variable, you need to place it inside curly brackets. If you didn't use curly brackets, you'd get the word title instead of "this is some heading text." At this point, it's worth remembering that while you are creating HTML-like syntax, you are actually coding inside a JavaScript file. And because of this, you can output a variable inside your JSX code, something you cannot do when writing static HTML. The overall syntax instructs React to render the heading HTML element with whatever text value that is stored within the variable named title. This rendering happens behind the scenes because of something called transpiling. You can think of transpiling as a process of converting JSX to HTML, and you'll learn more about this later. In this video, you learned about functional components and how to create them in React. You also learned about JSX, which acts like a combination of HTML, CSS, and JavaScript that you can use to generate dynamic content inside your functional components. Finally, you explored the concepts of rendering and transpiling. If you would like to learn about these concepts in more detail, there's a link to an additional reading at the end of this lesson.
In this video, you will further explore the concepts of components in React and learn how to create a component from scratch. You'll be introduced to the concept of the export statement and how components can be used to create reusable blocks of code. I've launched VS Code here and I have the creating component folder open in the built-in terminal. Now I'll execute the command npm init react app dot. The dot character instructs VS Code to run this command in the current folder. In other words, I'm using create react app to build a new app for me inside this folder. I execute this command by pressing the enter key. I wait for the app to build, and once it's ready, I can start the app by typing npm, then a space, followed by start. The process of building the React app could take a couple minutes, so just sit tight while it builds. Great, my React app has started and loaded in the browser at localhost 3000, which is the local server. Notice that I have all these files and folders in the left pane of VS Code now, such as node modules, public, src, and files like package.json. You'll learn more about these later. For now, the only folder I need to work in is the src folder, so don't worry about all these other files and folders. Instead, I want you to focus on how to build a component in React, and to do that, let's have a clean start. The easiest way to do this is to remove all the code inside the function inside the app.js file. I guess you might say this is the simplest possible component. I'm declaring an app function and I'm exporting it as a default module. I save my file and notice that my app is just a blank page. Now let me create another component that'll contain some text that I want to display in the browser. To do this, I create another function called header, and in the function body, I'll just return some greeting text inside an h1 JSX element. Inside the h1, I type hello world. My code looks good now, but my screen is still white. This is because I'm not yet rendering anything from my app function. To do this, I need to return to my app function and call the header function from it. I use the JSX element syntax to render a component, which is the name of my function. So inside the body of the app function, I create the return statement and type the function name of header inside left and right angle brackets, not forgetting to add the / before the right angle bracket. Notice that the syntax to render a component is very similar to a self-closing tag in HTML. Press Ctrl S or Command S if you're on Mac to save everything again. Great, my code is working now, and I notice an HTML heading with the text "Hello World" displayed in the browser. Congratulations! In this video, you learned how to create a functional component. This component named app calls another component named header, which displays an HTML heading with some text. At the moment, the header component code exists in the same file as the app component. To make the header component isolated and reusable, I need to place it in its own file. Then I can reuse it multiple times in the application anytime I want to display a heading element with some text. And you'll learn how to do this very soon. In this video, you learn how to create a functional component in React and render it to the root component named app.js.
As you might already be aware, it's important to organize or structure your React components so that they're easy to access. But what does a structure look like? What files and folders are found within a typical React application? The React project structure is the focus of this video. By the time you reach the end of this video, you'll have learned how to explain the default folder structure of a React project, outline the benefits of the folder structure, customize the folder structure to hold components and assets, and explain the benefits of planning folder use for app development. Let's begin by examining how the default files and folders are laid out in a React app project. When you build a React app using the command npm init react app, your project is comprised of a specific file and folder structure. Notice that there are three folders named Node Modules, Public, and SRC or Source. Let's explore each of these folders briefly now. First, let's begin with the Node Modules folder. You can think of this folder as a repository for all the modules in your React app. The Node Modules folder is automatically added when you install a specific npm package. You might recall that packages are groupings of files and/or node.js modules. Developers use packages when they want to add a piece of functionality that someone else coded and made available to other developers via the npm ecosystem. Don't worry too much about the Node Modules folder. For now, just be aware of it and that it's needed for your React app to work. Next is the Public folder, and it contains the assets that will be displayed to the user in your app. For example, image files for logos, the favicon which displays an icon in the Browser tab, and the robot.txt file which is used for search engine optimization. Also, there is a manifest.json file which is used to provide some metadata to a device when your React-powered web app is installed on it. While all these files are necessary, the most important one to know about for now is index.html. A React app gets injected into the specific element inside the body of the index.html file. Based on changes happening inside a React app, it injects those updates in that same div of index.html. You'll find out more about how this works later on in the course. Finally, let's explore the contents of the SRC or source folder. This folder contains all the essential component files required to ensure that a React app functions. And notice that there are some files already in this folder. These were automatically created when I used the npm command create react app to build a starter React app. As a React developer, you'll probably spend most of your time within this folder, so let's get a little more familiar with some of these files now. You may be familiar with some of them already, such as index.js and app.js, which are used to render the root component of the app. Let's briefly explore the others. App.css contains the styles for the app.js component, and the index.css file contains the styles that are used in the entire app. App.test.js, setuptests.js, and the report web vitals.js are files related to the app's performance and testing. The logo.svg file is displayed on the start page of the default app when the app is displayed in the browser on the local host. While these can be useful and their functionality is important, I can still safely delete them without affecting React's abilities to create a very basic application. I just need to also remove the code that references them. This is because React doesn't have opinions on how you organize your files and folders in the source folder. However, there are a few common approaches popular in the ecosystem, and you'll learn about them soon. It's at this point it's also worth remembering that the most important file in the entire source folder is the index.js file. This file imports everything that this React app needs to render a working React app. Okay, so now you have explored the main folders. Let's explore the files in the root of the default app. Root files are additional files that are found in the root of the project folder itself and include a gitignore file, 2 JSON files, and a README file. The .gitignore file is used in version control, and it's used to specify what files and folders must be excluded from a project. It's important to know that this file is not specific to React. This means that other systems use this file too. The readme.md file is a markdown file that gives some basic information on this project. Developers use this when they want to share the project's code on a site like GitHub. The package.json file lists information pertaining to my app, which allows npm to run several scripts and perform various tasks in the app itself. Finally, the package.lock.json file holds the list of all dependencies with their specific versions. The package.json file helps npm rebuild the app on another machine, or if we delete the node modules folder with all the files that our project needs to run, the package.lock.json file has all the information for npm to be able to rebuild those files reliably. This file is there to ensure that npm tracks all the modules installations properly. As a general rule, it's better to leave these files where they are for the moment, as they are required for the app to function. You should now be able to explain the default folder structure of a React project and outline the benefits of the folder structure. In addition, you should know how to customize the folder structure to hold components and assets, and be able to explain the benefits of planning folder use for app development. Good job. One of the advantages of component-based architecture is that your app is split up into individual self-contained components. And as you have already learned, these components can be used to build powerful UIs based on reusable components of code. In order to create a fully functioning React app, you need to create a collection of components. But with the app broken into several different components, you might be wondering, how do you locate and integrate them all into your app? In this video, you'll learn about the concept of modules and how to manage your React components by placing them in a components folder. Finally, you'll explore the structure of the import and export statement. As a developer, you often need a way to use and reuse components that may have been defined elsewhere or created by someone else. For example, do you recall the concept of modules in JavaScript? Modules are standalone units of code that you can reuse again and again. Being standalone means that you can add them to your programs, remove them, and replace them with other modules, and everything will still work. Well, in React, you can make use of this JavaScript feature to separate your components by placing them in their own file. Then you can use the import and export statements to make the files communicate with each other. The export statement is used to make a module available to another module. It helps to think of every JavaScript file as a module. Then in order to make the functions and variables available to other files, you need to export them, which makes them available via the import statement. In JavaScript, there are two types of exports: default exports and named exports. The default export is used when the function name is the same as the file name, and named exports are used when you want the function name to be different from the file name. At this point, you may be wondering, what is the difference between modules and components, since they are both essentially just JavaScript files? And you're right. While they have similarities, it can help to think of a component as a single part or small piece of functionality, like a button. Then you can think of a module as something that's larger than just one component, like a series of components. This technique of splitting your code into several modules is known as modular programming, and it complements the component-based architecture of React. To help you understand this better, let's explore the following scenario. Suppose you're a developer currently in the process of building an application with React, and there are several components that need to be included in the app. Some of the required components have already been created by your fellow developers, so you need a way to import them into your app. To do this, you need to use the operation known as importing. And in React, you import components into your application using the import statement. You may have already noticed the import statement in the default index.js file where the app component is rendered. In React, to import a component, you use the keyword import followed by the component name you want to import. Then you use the keyword from to specify the location of where the component is located. You need to use a file name sequence such as a dot, / before the file name, but the file name extension is not required. Okay, so now you know about the syntax of the import and export statement. Let's explore how you can structure your component in React. Remember that a component is essentially just a JavaScript file. React doesn't have strict rules on how you put files into folders. However, there are a few common approaches you may want to consider. One approach is to place all components in a folder named components. This allows you to structure your projects by grouping similar files together. For example, suppose you are building a payment page for an e-commerce app. The page contains 3 sections that will each be represented by a component in React. First, a header section using a component called header, then a payment section using a component called main, and finally a sidebar using a component called sidebar. Each component will be called and have its contents returned to the root component of our application, which is app.js. In this video, you explored the concept of modules and the structure of the import and export statement. You also learned how to manage your React components by placing them in a components folder. By now, you should be familiar with the concept of functional components in React. They are reusable blocks of code that act much like a JavaScript function. Recall that in JavaScript, you can make your functions more flexible by declaring them with parameters that allow you to pass in values as arguments when you call the function. Well, in React, you can perform a similar action using something called properties, which are represented as props. In this video, you'll learn about the props object and how developers use it to pass data from one component to another. Then, you'll explore component hierarchy and learn why components are said to have a parent-child structure. Before you begin your journey with props, let's revisit another piece of JavaScript functionality that will help you understand how props work. It's called the JavaScript object. Recall that in JavaScript, an object is a special type of variable that can contain many values. You use objects when you need to store groups of related data of different types, and each data type is known as an object property. For example, suppose you create an object called fruit that contains properties for type, quantity, and color. Remember that these properties consist of name-value pairs, and you can access the object's properties using dot notation. In React, you can use a similar technique to pass data from one component to another using the properties object, or simply props. Props allow you to pass data from one component to another. It's helpful to think of props as arguments that components can accept and are passed using JSX syntax, much like HTML attributes. Inside a function, you use the keyword props. Okay, now that you're familiar with the concept of props, let's explore an example to send some props to a component and print them out in a React app. Suppose you have the default code for the React app open. In the index.js file, you call the app component. Inside the app component, you return an h1 heading with some static title text. While this code works, you can make this heading dynamic by using props. Let's now explore the syntax involved to create this. In the root component index.js, you send the value you want to pass to the app component as an argument in the form of an HTML attribute. Next, in the app component, you accept this argument using the props object. To do this, you add the keyword props to the function declaration inside of the parentheses. Finally, to access this object's properties, you use dot notation to reference the name of the object's property that was passed as an argument by the HTML attribute. Once again, remember to enclose your code inside curly brackets so React knows that you want to work with a props object and not static text. Because props is essentially a JavaScript object, it can accept many data types ranging from simple types such as strings and integers to more complex types such as functions, arrays, and objects. As a result, props allow developers to have greater flexibility when creating and working with components, especially when you want the flow of data in your app to be dynamic. While you just explored a basic example to dynamically print a heading, you'll get a chance to practice with more complex data structures using props later. Okay, so now you're familiar with how props work by sending data between components. Let's explore this data flow in a little more detail. When two components communicate with each other, the component sending the props data is known as the parent, and the component receiving the props data is known as the child. And as you've just learned with the example earlier, this parent-child relationship allows parent components to pass data down to child components using props. It's also possible for parent components to send the same data to multiple child components. However, it's important to know that this communication is a one-directional data flow. It's not possible to communicate from the child component back to the parent component using props. Instead, developers use other approaches. Don't worry about that for now. You'll learn more about them later. Although props are a very powerful tool in React, they do have some limitations. For example, you just learned about how it's not possible to send data from the child component back to the parent component using props. Another important limitation has to do with something called pure functions. In programming, a pure function is a function that will always return the same output for the same argument values that are passed in. Don't worry too much about pure functions for now. Just keep in mind that in React, when you declare a component using props, it must never modify its own props. In this video, you learned about how props are used to pass data to components. You discovered that a prop is a special React object that works in a similar way to a JavaScript object, and that its properties can be accessed by dot notation. You also learned why developers use props in order to make their apps more dynamic and flexible. Finally, you examined some of the limitations about using props in that you cannot use them to send data back to a parent component, and that functions using props must never modify its own props. By now, you should be familiar with the concept of props, and that they allow you to pass data from one component to another. Developers use props when they want the flow of data in the app to be dynamic. This makes the app more versatile, helping it consume data easier. In this video, you'll learn the syntax involved to use props in components. You'll also explore the passing of props to and within a component using functions. During this course, you were introduced to an example of how to build a simple blog layout in React using components. Now you'll be introduced to a new component called the nav component. Developers commonly build navigation menus using HTML unordered lists. A navigation menu is basically just a list which can be styled easily with CSS. Such a snippet of code is well suited to be placed in its own React component, making use of the HTML nav element to act as the block of code to return the JSX from inside the function. For example, the return statement can contain several HTML-like elements such as UL and LI tags. And this same nav component can also be rendered as a JSX element to which we can pass dynamic value with props. In order to do this successfully, you need to be comfortable with the concept of attributes. The best way to develop an understanding of attributes is with a live example of building a component using props. Here's a practical way to work with props. I'm in my app with the header, main, and sidebar components, and all of them are rendered from the app component. The app component is in this case referred to as the parent component, and the header, main, and sidebar components are referred to as the children of the app component. I'll now pass data from the app component to each of its children components. First, the header component receives a name prop with a value of Anna, and a color prop with a value of purple. I'm sending those props from the header JSX element inside the app component's return statement. Press Ctrl S or Command S on a Mac to save these changes. However, My recompiled app is not showing any changes because I send this data through the props object to the header component. I'm not using this data in the header component. So let me open the header component and I'll first pass in the props object. For now, I'll just console log the props object. Again, press Ctrl S or Command S to save the update and wait for it to compile. If I now inspect this object in the console, I find the console logged props object and it comes with two properties, the name Anna and the color purple. I can now access the values of the two properties inside the header component using props.name and props.color. To make sure that the expressions are evaluated inside the JSX syntax, I must surround them with an opening and a closing curly brace. I press Ctrl S or Command S on the Mac again and wait for it to compile. Now my header shows the props data it received from the parent component. I'll now update the main and sidebar too. Back in the app component's render statement, I add the greet prop with the value of howdy in the main JSX element and the value of hi in the sidebar JSX element. I open the main component's file and receive the props object, then output the value of opening curly brace, props.greet closing curly brace. I can now delete the hello string. Similarly, in the sidebar components file, I'll also receive the props object and replace the hello with an opening curly brace, props.greet closing curly brace. I click File, Save All and wait for the app to compile. All my components are now using the data they received from their parent component using their respective props objects. You should now be able to effectively demonstrate the passing of props to and within a component using classes and functions. Great work! At this point in the course, you've been introduced to the concept of JSX and how it's used to interact with components. In this video, you'll explore JSX in more detail in the context of component and styling. You'll also learn how to mix JavaScript, HTML, and CSS within a component. So, what is it that makes JSX so special? In one word, expressiveness. Developers can express what they want React to render using a very expressive syntax, almost identical to HTML or XML. In other words, JSX allows developers to write HTML directly inside JavaScript code. For example, you can add a navigation function to a website by creating a nav component, then place the HTML semantic nav element and an unordered list inside. And because this is React, the list values can be made dynamic by passing values as props. It's important to know that a regular JavaScript function is used to define how React should render the component, wherever it's referenced using the nav JSX element. And this is what makes JSX so powerful, like the fact that you can insert specific JSX expressions such as variables and props. The reason why this is so great to work with is because anything that's placed inside the curly braces of your code is essentially regular JavaScript code. For example, you could calculate a series of simple expressions using the li or list item tag. This means that you can think of the curly braces as being special areas where you can write any kind of JavaScript code you like, and you can write the rest of the code inside the return statement. Okay, so now that you've learned a little more about JSX expressions, let's focus on some JSX rules inside the return statement of the function. The return statement can be thought of as the area of expressive syntax that allows you to write regular HTML code as you'd like to have it in your rendered app. But if you need to return HTML code over multiple lines, it must be placed inside parentheses. This allows developers to alternate between regular HTML tags and dynamic values represented as JSX expressions inside curly braces. It's also important to remember that the HTML code must be wrapped in a top-level element such as a div tag. If you do not want to add extra div elements to the DOM, you can use something called a fragment instead. This is like an HTML open and close tag without the tag name. While you can think of the code inside the return statement as regular HTML, it's worth remembering you are in a JavaScript file, and as a result, there are some differences. For example, you cannot use the keyword class to work with CSS classes in your HTML elements. This is because class is a reserved keyword in JavaScript. You must use a slightly different keyword called class name instead. Also notice that class name is written in camel case, which depicts the separation of words by using a single capitalized letter. You can use class name to list any number of CSS classes to style a specific JSX element inside a component. This is just like how you use the class attributes in regular HTML, and it's only one of the many ways you can style React apps. You'll learn more about how to do this later. For now, just know that this is the closest to what you would do, like if you were working with HTML and CSS website layouts. There are some other differences, and you'll learn about them later. But in practical terms, you can consider the code to be pretty much just like regular HTML. In this lesson, you explored further the concept of JSX styling and how it's used in React. You have now furthered your understanding of how to use JSX to mix JavaScript, HTML, and CSS within a component. Great work!
Recall that there are 3 techniques to include CSS in HTML documents. The first is inline by utilizing the style attribute inside the HTML element. Next is internal by using the style element in the head section. And finally, external by linking to an external CSS file using the link element. In this video, you'll learn how to take CSS style rules from an external file named index.css and add it inside a component as an internal style. These style rules can then be referenced by your code inside the return statement of the component. Notice that the components are styled by the external style sheet index.css. For this video, I'll continue working on an app which consists of the components header, main, and sidebar. This time, the focus will be on using internal styling inside the sidebar component. To demonstrate this, I don't need to move all the code from the index.css file. Instead, I'll just focus on the styles related to the sidebar component. For example, I select the CSS code for a side and cut it by pressing Ctrl X or Command X on Mac. After saving, notice that this removes the styling from the sidebar component displayed in the browser. Now let's go to the sidebar.js file where I'll paste the code before the return statement. This will not affect my component because I'm pasting CSS code into a JavaScript file, so I need to make some changes to turn the CSS rule into a JavaScript object. To do this, I need to declare a side style as a const variable and then replace the semicolons in the code with commas. I also need to replace the hyphenated names with camel case. It's important to know that because CSS declarations like background are now an object property, I need to make their respective values a string by wrapping them inside double quotes. And I also need to repeat this for the other new style elements as well. Finally, inside the aside tag in the return statement of the component, I need to add a style attribute by typing style equals aside style as a JSX expression. I then choose Save All in the File menu to save my changes. Notice that the sidebar component appears in the browser as before I edited the index.css file. So that's an example of using inline CSS styling directly inside a component. In this video, you learned how to take CSS style rules from an external file named index.css and add it inside a component as an internal style.
Recall that JSX is a syntax extension to JavaScript that is used with React. It allows developers to write HTML as part of their component code, and is frequently used in React as it offers greater flexibility. In this video, you'll learn how JSX is used and how to use its key feature, embedded expressions. First, let's examine a JSX example that will output some text on a web page. The code consists of a paragraph HTML element containing the phrase "Hello World." It is assigned to the constant variable named result. Note that when this JSX code executes, the result variable will contain a React element that can then be inserted into the web page. This is one of the key features of JSX, building React elements from HTML code automatically. Let's explore another important feature of JSX, which is embedded expressions. Embedded expressions allow developers to insert the values of JavaScript variables into the HTML of the resulting React element. Embedded expressions can also embed the output of functions. Let's say you need to output the person's name in a specific format. To do this, you can first create a function named formatName that will return the first name and surname with a space character between them. In your JSX, you can then call this function inside the curly brackets. As with the previous example, the value that the function generates for the JavaScript variable will be output in HTML. Expressions can also be used for HTML attributes. This is useful if you need to insert the address of a person's profile picture. To do this, first you would store the profile picture address in a variable named URL. The image will be displayed using the img element, so you should embed the URL variable into the src attribute. Note that the double quotes are not needed for the attribute value, as JSX will automatically add these. This is just one example of how JSX is an efficient way of outputting HTML elements that contain JavaScript variable content, and you'll encounter more as you progress. In this video, you explored several JSX examples, including one that uses embedded expressions to insert the values of JavaScript variables into HTML within a React element.
I'm building an application using React, and I now need to add a new feature to the app that renders images. I can do this by embedding a JS expression in an attribute, specifically the src attribute of the HTML image tag. Over the next few minutes, I'll guide you through the process as I complete the steps, and by the end of this video, you'll be able to demonstrate how to embed a JS expression in an attribute, including adding additional styling and importing additional assets, and utilize additional assets within an app by importing components. Now I'm in the app.js file of a new project and start with an app component that returns the h1 header text Hello World. I've previously copied the avatar profile image from the Coursera GitHub account, which is publicly available through the GitHub API. I've pasted the images into the root of the src folder and named it avatar.png. In order to use the image, I need to import it into the app component. I then add a new function in the app.js file named logo. The logo function is essentially a separate component, but to keep things clean for this example, I'll save the code in the app component instead of a separate file. The logo function accepts the props object, and inside of the logo function, I declare a user pic const and assign it a JSX element. This is an image element, and I'm passing the imported avatar PNG image as the value of the src attribute inside this image element. Finally, I'm returning the user pic const from the logo function. Back inside the app component, I'll now render the logo component by adding the logo element inside the app component's return statement. Let me now preview my app in the browser. Great, so it displays the header text along with the image. Keep in mind that if I were to continue building this app with more components, it would be best to extract the logo component to its own file and then import and render it as needed. And that's a demonstration on how you can embed a JSX expression in an attribute, in this case, the src attribute of an HTML image tag.
Well done! You've reached the end of this module on React components. Module 1 gave you an overview of the basic structure and use of react.js. The purpose was to enable you to produce single-page applications with React. Let's take a tour of the lessons to determine how it did just that. First, you learned about how React is used in the real world from Meta software engineer Katie. Then, to lay the foundation for the hand-on labs, you had a quick summary of the fundamentals of HTML, CSS, and JavaScript. And then you learned how to set up a project in VS Code and how to work with JavaScript modules. The second lesson was all about React components and where they're stored within your applications. In this lesson, you were introduced to component-based architecture, a design philosophy for building software based on reusable components of code, like the React library. You learned about component types and component style layouts that use the virtual DOM. And you learned how to create components that form the foundation of UI design. In this lesson, you also learned more about JSX, a special kind of syntax that acts like an extension of JavaScript. You learned how to transpile it, in other words, convert JSX to HTML, which helped you to understand how a component is built. And in the ungraded labs, you learned how to build a new component inside the app component and have it rendered on screen, as well as how to save a component to its own file and importing it into its parent component so that it can be rendered on screen. The third lesson was about component use and styling. You learned how to pass data from one component to another using properties, and your ability to do so was tested in the ungraded lab. And in the other ungraded lab, you learned how to render one component multiple times using different props. You also learned more about how to use JSX and its embedded expressions, and how to style JSX elements in a way that is functional and looks good. As part of this lesson, you learned how to use and manipulate props and components, define components using function expressions and arrow functions, invoke functions inside of JSX expressions, use expressions as props, declare components that require props, and use expressions and embedded expressions in attributes. After completing this module, you are now able to explain the concepts behind React and component architecture, create a component to serve a specific purpose, create a component folder and demonstrate how to create and import files within that folder, use and manipulate props and components to affect visual results, and describe how to use assets within an app to apply styling and functional components. That's a great start to your React journey. Well done on completing this module, and get ready for the next one. By now, you're probably familiar with events in JavaScript. Recall that events are the process by which JavaScript interacts with HTML and can occur when the user or the browser manipulates a page. They provide enhanced interactive experiences, such as responding to mouse clicks, movements, or keyboard commands. Because events usually rely on some sort of interaction, they need to wait and listen in the background for that interaction to occur before they can be triggered. Every HTML element contains a set of events that developers can access by using HTML attributes commonly referred to as event listeners. For example, it's a common feature of a website or app to have a button that, when clicked, causes something to happen. This action is an example of an event, and is accomplished with either event listener methods or by defining specific JavaScript functions. Developers can use events to execute JavaScript code in response to an action based on user interactivity, like clicking a button. This process by which the HTML button communicates to the JavaScript event handler to execute some code in response to the event action is known as triggering. For example, you might want to listen for a click event on an Add to Cart button. Once you capture such an event, you might want to run some JavaScript code. In this example, add a circle with a number 1 in the shopping cart to indicate one item has been added. If the same event gets triggered or fired again, our event handling code then handles the event by updating the count in the circle next to the shopping cart icon. The circle then displays the number 2 to indicate that there are 2 items in the cart. Events are a powerful tool and make up part of the document object model. As an aspiring React developer, you'll need to know how to work with events as they are handled a bit differently. By the end of this video, you'll be able to identify the broad types of events available in React and describe some of the most commonly used ones. You'll also know how to explain the event handling process in React at a high level. In React code, events are handled using JSX event attributes, which are very similar to HTML event attributes that you may be familiar with. For example, the click handling attribute in HTML is the onClick attribute with all the letters lowercase. The equivalent click handling attribute in React's JSX is the camel-cased onClick attribute. Remember that camel-case means that the first letter is lowercase and the separation of words is indicated with a capital letter rather than a space. There are many events supported in React which can be divided into several groups. Those groups include clipboard events, composition events, keyboard events, and many more. Each group usually holds multiple events. For example, supported mouse events include onClick, onContext menu, onDoubleClick, and several others. You'll also find that the clipboard group has the useful events onCopy, onCut, and onPaste. There are far too many events to cover here, but you can find a complete list in the additional reading. The large number of event types that are accessible in React may seem overwhelming at first, but note that it's actually the browser that comes with these features, as the various devices that we use to access the internet have given rise to many ways for users to interact with websites. This means these events are not specific to React, and it's probably not necessary to learn about all of these events. Also keep in mind that many of these events are related to specific use cases. For example, several of the mouse events are limited to the drag and drop API. In other words, at this point in your learning journey, your focus should be on understanding the overall event handling process and what capabilities events can open up to you. In this video, you learned about the types of events available in React and how they came to be. Next, you'll explore specific examples and build the skills to use events confidently for various situations.
I will now show you how to handle several events in React using components. As a start, I've added a new component to the src folder. I named it btn, and for now it's just an empty function with a default export. Let me simplify the app.js file's return statement. First, I'll delete the logo import statement and import the btn component instead, and then remove the contents of the return statement. Then finally, I'll add the btn JSX element so that it can get rendered. Back in the btn component, I add a button in the return statement. The button reads, "Click me." Press Ctrl S or Command S on a Mac to save, and the button renders on the screen. Now I'd like to handle a click on this button, so I add the onClick synthetic event, then an equal sign, an opening curly brace, click handler with a capital H, and a closing curly brace. In the return statement, I distribute the code on several lines to increase readability. Now I'm setting up the click handling behavior. Whenever a user clicks on the button, that'll evaluate an expression named click handler. I now need to define this click handler, and I'll set it as a function expression, meaning I will use the const variable keyword and name it click handler. Then I'll assign an arrow function to it. That's it. I've just set up a click handler that receives the click event that's fired from this button and handles it by outputting the word clicked in the console. Again, I save my changes, and in the browser, I open the developer tools. Now I locate and activate the console tab in the developer tools. I'll also zoom in on the button. When I click the button, the word clicked appears in the console for every click event. Back inside the btn.js file in VS Code, I select all the code in the btn component, right-click on the selection, and click the copy command in the contextual menu that pops up. Next, I use the keyboard shortcut of holding down the Control key, and while it's pressed down, press and release the K button, then pressing and releasing the C button, and finally releasing the Control key. So, Control K C. That comments out all the highlighted code. Right under this commented code, I now press the Control V keyboard shortcut to paste in the code that I have previously copied. I will now show you how to handle a different event. Let me replace the onClick JSX event handling attribute with another one, and thus handle a different event. For example, I can replace the onClick attribute with the onMouseOver attribute, and update my event handling function accordingly to read mouseover. I save my changes and wait for the app to recompile. This time, when I hover over the button, the words mouse over are showing in the console. In this video, you've learned how to work with event handling JSX attributes in React.
Every time you click or tap a button, scroll down a page, or cancel a boring notification, you're producing events in the browser. And as you learned earlier, in order for these events to have any effect, you need to use event handlers that will then execute an action. For example, suppose you use a button to open a menu. Clicking the button is the event. The event handler is onClick, and the action that follows the event is opening the menu. There are a few approaches to adding event handlers to your React code that have different advantages, so you'll become familiar with each of them. By the end of this video, you will be able to describe the syntax differences for using event handlers in HTML and React. You will also know how to explain HTML function call and React component inclusion, and discuss the advantage of the component level of control. Suppose you're a developer working on a React app and you need to create a button that will trigger an event when a user clicks on it. With that scenario in mind, let's examine some code that accomplishes this in plain HTML. You might open a tag called button with the ID JSBTN. You then assign the onClick event handling attribute and set it equal to the click handler function. Next, you can add clickMe as the button text and finish with a closing tag. The code has an ID HTML attribute with the value JSButton, along with the event handling attribute onClick. While the HTML code in the example seems pretty straightforward, it's recommended to use JavaScript for scenarios like these instead. Why is that? Well, you'll find out later. But for now, you should understand that the equivalent code in JavaScript consists of two primary steps. First, you should use JavaScript to plug into the specific HTML element on which you'd like to listen to for an event. In the previous example, the HTML element is JSButton, which signals that it's a target element for allowing JavaScript to take control of the HTML structure. Second, once you've gotten access to an HTML element with JavaScript, you can then use the built-in add event listener method on the document object to attach a specific event listener. When you apply this method to the previous example, HTML is removed from the equation, but the code, on the other hand, is a bit more complicated. Specifically, you need to first declare a constant called JSButton and assign the value from the DOM. Then you need to add the click listener event and the function to run the code. Going back to React, the biggest difference in syntax involves the use of the add event listener method. In React, the rule is to avoid manipulating the DOM directly as much as possible. You should set everything up declaratively, meaning that you describe updates to React and let it figure out the rest. This is best done using event attributes, and fortunately, one-to-one mapping between HTML event attributes and JSX event attributes means it's easier to learn. Event handling in React is overall quite similar to HTML, but note that there is no function invocation syntax in event handling attributes in React. In other words, while in plain JavaScript you would need to pass an invocation to an event handling function as a value to the onClick events, in React you should not invoke a function. Instead, you just pass a reference to the event handling function without invoking it. To illustrate that point, let's compare the syntax of an HTML click handler event and its React JSX equivalent. In HTML, you provide the event handling attribute starting with on, and you append the name of the event, all lowercase. After the equal sign, you use a pair of double quotes, and inside of the double quote delimiters, you invoke the function that will run. Contrary to HTML, in React, you provide the event handling attribute starting with on, and you append the name of the event with each word's first letter capitalized. After the equal sign, you use the JSX expression delimiters, that is, the opening and closing curly braces, and inside of the curly brace delimiters, you add the name of the function to be run. Make sure not to invoke it. Finally, one more feature only used in React is the passing of function declarations as props. For example, in an app component, let's say you'd like to render a child component named counter. You can pass some data from the app component to the counter component using a prop. In this case, let's use an onClick prop that passes in the data that you want the counter component to receive. And there you have it. So the next time you're clicking buttons on a web page, closing notifications, or simply browsing through, you'll understand that those events are supported by some form of event handling. In this video, you learned how to distinguish the syntax for event handling in HTML and JavaScript. In this video, I'm going to demonstrate how to toggle the value of a Boolean state variable using user-triggered events, and how to handle multiple events on a single JSX element. In the example that you'll explore next, the code consists of another example of a component than what you've been used to so far in the course. The aim is to demonstrate how all the event handling concepts work together with state, styling, and the use of ternary expressions. Let's say that you have a component that uses state to keep a Boolean value of dark mode on. Based on whether the value of this variable is true or false, your component will render an h1 heading with some text in it, either as a dark theme or as a light theme. Additionally, it's possible to switch the theme with a button click. Now let's continue with an in-depth demonstration of event handling. I'm going to demonstrate event handling with an example so that you can gain practical insight into the use of events to provide additional functionality to an app. I'm going to build a component and I'll name it Mode Toggler. So in the Explorer sidebar in VS Code, I right-click the source folder and click the New File command. I named the file Mode Toggler, and for now, it's an empty function declaration with a default export. I press Ctrl S or Command S on a Mac to save my updates. Back in the app component, I update its return statements to render this new Mode Toggler component. I also need to import it on line 1 of the app component and save the changes to app.js. I now return some JSX code from my Mode Toggler component and add a return statement. In this statement, a JSX expression wraps the ternary which checks if the value of dark mode on is true or false. If it's true, it will return whatever is stored in the dark mode value, and if it's false, it will return whatever is stored in the light mode value. However, I don't have the values I'm evaluating yet, so if I save this code now, it throws an error. Instead, I define these values by declaring 3 variables above the return statement. These are dark mode on, which holds a value of true, dark mode, which holds the text dark mode is on in an h1 header, and light mode, which holds the text light mode is on in an h1 header. I save my changes and I get the sentence dark mode is on in the browser. Let me explain what happened here. The dark mode on variable is set to true. Just to do a quick test, I can change the variable name of dark mode on in the ternary to the value of true. Since this value is true, the value that's stored in dark mode will be rendered. If I change the value of true to false, the value that's stored in light mode will be displayed. I have replaced the test word false with our const dark mode on, and now I'll save it and test it again. Now I get the light mode is on displayed on the screen. I add a button with the on-click events to handle this toggle of the value of the dark mode on variable from true to false. So under this ternary statement, I'll add a button with an on-click event handler. I'll also define the handle click function. I start my function by taking the value of dark mode on and change it to the opposite Boolean value using the exclamation mark. That is, the not operator. I then assign this value as the new value of the dark mode on variable. To explain this a bit more, if the value of dark mode on was, for example, true, then the not dark mode on will be evaluated to not true. This not true will be assigned to the dark mode on variable, thus becoming false. I now add the rest of the code for the handle click function, which is an if statement. The logic states that if the dark mode on is set to true, then console log dark mode is on, otherwise console log light mode is on. I could have perhaps written this code a bit differently, but I wrote it in a way that makes it obvious what is happening here. This is always good practice for a developer of any skill level, so that they and others can easily examine the code at a later stage. I save, and once my app recompiles, if I click the Click Me button, I get the appropriate string output in the console. This brings me to an interesting conclusion. Although the console log is updating, there are no changes to the actual heading 1 on the screen. Of course, I can update it manually by changing false to true, then saving the app and waiting for a re-render to confirm that my changes have indeed happened because the previous heading of light mode is on has now become the heading that reads dark mode is on. But as soon as I click the button, the console log changes. However, the heading in the web app doesn't reflect this change. Why is this the case? To understand this, you'll need to go deeper into data flow in React and observe how it moves between components. Fortunately, you'll be learning that soon. Great job! You should now be able to demonstrate how to toggle the value of a Boolean state variable using user-triggered events and how to handle multiple events on a single JSX element. Imagine you are working for an online retailer that discounts prices regularly to keep stock moving. Sales are announced at multiple points on the website, but what's the best way to keep this information up to date? For example, updating items individually would be tedious and time-consuming. Fortunately, it's possible to change information at a single point and have everything else update automatically to match. This idea illustrates a parent-child relationship, and in this video, you'll explore this concept as it applies to React. By the end of this video, you'll be able to describe the parent-child unidirectional flow of data, and you'll gain an understanding of the hierarchy of React. Let's start with an example of two components which will be used in the same app. First is the promo component, which will return the content of the promo heading component that you will create later. To build the promo component, you can declare the function promo and then write a return statement inside of curly braces. This statement has a div, inside of which promo heading is called. This is then followed by the line export default promo to make the component accessible. Next, let's write the promo heading component. You can declare function promo heading and in curly braces type return opening parenthesis h1 tag the text 80% off sale, h1 closing tag and closing parenthesis. Once again, don't forget to export the component to make it available. Success! You've now created the component promo, which calls a function from the component promo heading to return the text 80% off sale. In this example, the promo component is known as a parent component, and the component it renders, promo heading, is referred to as the child component. Now let's say that the discount increases to 99% off, and you need to update the code to reflect this. One approach is to update the text inside of the h1 tags in the promo details component. That's a quick fix because there is only one change to deal with. However, let's explore a more complex situation. This time, your manager asks you to call the promo heading component in the sidebar and footer component of the web app, in addition to the promo component. They also want two messages displayed: 99% of all items and everything must go. These new requirements mean that the approach of updating the child component will not work quite as well. Why is that? Well, it means that you now have to update multiple components with the same data. This is not in line with the general programming principle of dry, or don't repeat yourself, which aims to reduce needless code replication. Also, consider the following possibilities. While entering the same text into several components, it's possible you make a typing error. Also, what if your boss decides to change the discount again? It means you'll have to change the text in all the connected components once more. But instead of writing the same code over and over, you can change your approach. You can establish a single source of truth that contains the two strings that store the values for the texts 99% of all items and everything must go. This will be contained within the parent component so that any data needed can be passed on to the child components using props. Now let's use this approach to update the promo component. First, you create a single source of truth, a JavaScript object named data. Data is an object that will contain two properties named heading and call to action, both represented as strings. Next, you update the promo component to pass the heading and the call to action values of the data object to the promo heading component. This is known as passing data from the parent to the child component. Back inside the promo heading component, you update it to accept data from its parent component. To do this, you'll need to first delete the existing h1 in the return statement, and then add a new h1 for props.heading and an h2 for props.calltoaction. Now, this component accepts a props object. Specifically, its two properties, heading and call to action. The values of the props object are determined in the parent component when you add the specific JSX elements that should be rendered. This was achieved when you rendered the promo heading inside the promo component. Here, you access the properties on the data object using the regular dot notation syntax of plain JavaScript. Knowing this, you can now code the sidebar component and the footer component in a similar way to the promo heading component. Remember that in React, the props data always flows from the parent to the child component. And using props helps you avoid the need to change the data in several places. Instead, you make the change at the data source, the parent, and the updates will be applied to the child automatically. In this video, you learned how the parent-child relationship can be set up so that data flows from parent to child. By storing data in the parent component, you can dynamically pass it to the child component without the need to update children individually. In this video, you're going to learn about data flow in reactjs. In this case, data flow is in one direction only. Immediately, a question springs to mind. Why is one-way flow in React important? Let me tell you. This type of data flow ensures that the data is moving from top to bottom through the component hierarchy. It also ensures that changes are transmitted through the system. You'll cover this in more detail later. For now, in this video, you will also learn how to showcase the use of stateless and stateful examples by focusing on data flow. Imagine that data is money, and that money is controlled by your employer. This money can be considered props. This money props is passed to you and becomes your money state. The money props always flow from your employer to you, never in the opposite direction. In React, data is passed down from a parent component to a child component via props. A child component can't mutate or change its props. It can only read them and re-render. This means that the data comes from the parent and is just consumed in the child component. However, if this was always the case, then all you'd have in a React app is separate pieces of the DOM, acting as component templates to be filled up with the data they receive. While this works great, there'd be almost no interactivity. You've learned about passing data to a child component using props. However, there's another way to work with data in React components, and that data is referred to as state. All the data in React can be divided into props data and state data. Props data is data outside the components that it receives and works with, but cannot mutate. State data is data inside the component that it controls and can mutate. It also helps to think of it like this. The props data belongs to the parent that renders the component. The state data belongs to the component itself. To demonstrate this, let's open up VS Code and work through an example. I've built a new app using create react app. I have two files created, app.js and child.js. The app.js file defines the app component using a class definition instead of a function. When it's created, it initializes its state with a current date. The render function then renders a component called child. The child component has a prop named message defined, and its value is set as the current dates from the component state converted to a string format, which includes the hours, minutes, and seconds of the date. In the child.js file, the component renders the message prop in an h1 element. Now when I run the app, the state of the app component flows its data down to the child component props, and the h1 element will display the current date and time. Well done! You have now learned how children and data flows in reactjs, and you should also be able to showcase the use of stateless and stateful examples by focusing on data flow. By now, you've probably already learned about some important and useful core concepts in React. At this point, you're ready to learn how to add interactivity, maintain state within a React component, and explore hooks. In this video, you'll be introduced to what hooks are, how they can be used, and why they are useful. As you progress as a React developer, you'll likely soon use complex components with stateful logic. Keeping track of state across components can become quite a task, and this is where React hooks can help. One key benefit of hooks is that they solve the problem of unnecessary code reuse across components. Let's find out how they do that. Hooks are functions that were introduced in React version 16.8. They let you hook into React state and lifestyle features from components. Let's observe an example hook. Specifically, you'll examine an instance of the useState hook, as it's the most commonly used one. This hook is used to manage the state within a component and keep track of it, and it's built directly into React. To use it, the first thing you need to do is import the useState from React so that it's available for use. The next step is to declare a state variable within a component. You can provide any name to the state variable and the setState function. For this example, let's call the state variable showMenu and the setState function setShowMenu. If you've learned JavaScript, this syntax may feel somewhat familiar to you. You are probably wondering what exactly this code does. Well, it's actually doing something that you've likely encountered before. Notice that the convention is to name the state variable and the setter function using array destructuring. When you declare a state variable using the useState, it returns a pair which is an array with 2 items. Without array destructuring, the code would be long and cumbersome. Since it's more confusing and tedious to access the array items by index, array destructuring is preferred, and it significantly simplifies the code. You now have a new state variable called showMenu. The useState then sets the initial value of showMenu as false. So to summarize, calling the useState hook does 2 things. It creates a state variable with an initial value that represents the current state, which in this example is showMenu, and it creates a function to set that state's variable value, which in this case is setShowMenu. The function setShowMenu is used to update the value of showMenu by passing the Boolean value to it. It does not matter what names you use for the state variables. You can define them based on your component and use case. The useState hook should be called at the top level of your component. In this example, notice that the useState hook was used to track the Boolean state value. You can use the useState hook to track any type of data. It could be strings, numbers, arrays, Booleans, or objects. For instance, you can even track the number of times a button was pressed. In addition to the hooks that come out of the box with React, you can also build your own hooks which will let you extract custom component logic into reusable functions. This is an excellent feature and benefit of using hooks. The biggest benefit of hooks is the readability and simplicity that they provide to the code. In this video, you learned the basics on React hooks and explored the useState hook. You now understand the benefits of using hooks and how you can use them within your React applications. Consider the different modes in an alarm clock and the situations you would use them in. Typically, you have alarm on for setting a time to wake up, alarm off for when this feature is not needed, and snooze for sneaking in a few extra minutes of sleep. Setting these modes doesn't require adding anything extra to your clock. They are built-in features that can be set with the push of a button. If you create this feature in a React app, you could create a component named clock and then pass in the status values via props. Recall that props is a feature of React that essentially allows you to hold information about the UI in the browser. In React, you also have another way to do this by using a similar concept called state, which also allows you to easily change how the component behaves in order to suit a given need. By the end of this video, you'll be able to describe what state is in React and why developers use it to control what is displayed in the browser from a component. It helps to think of state as a component's internal data that determines the current behavior of a component. And it's often used to store data that affects the behavior of a component. State is important because it allows components to stay in sync with each other and ensure that your app behaves as intended. For example, if one component updates its state, all other components that depend on that state will automatically update too. This means that a component sends its state to its children by using props. If the child components have their own grandchild components, then the child components might have some states that they send as props to those grandchild components. In React, state is kept in a state of variables. The main way to change state is to alter these variables. When a component is created, it gets an initial state. The state is used to initialize the component's properties. Components can be either stateful or stateless. But what exactly does that mean? To gain a better understanding, let's explore an example of each. First is an app component with no state defined. It performs a single action, which is to render the text a stateless component. And then you have a stateful function component. This component also renders some text, but it references a variable to do so. You'll explore how that works a little later. For now, notice the syntax used in the first line of the app's function body. If you're familiar with how array destructuring works in plain JavaScript, this line of code might already make sense to you. But to make things clear, consider an example array called fruits, which contains the three strings apple, pear, and plum. With its ES6 version, JavaScript introduced the concept of array destructuring, which allows you to assign several variables from the array using a single line of code. In other words, you can assign apple, pear, and plum to the fruit 1, fruit 2, and fruit 3 variables quickly instead of one at a time. With this in mind, let's come back to that line in the stateful component. Notice that the syntax used is similar to the array destructuring example you just examined, but with an interesting bit of code. react.useState. Hooks allow developers to hook into some otherwise inaccessible functionality. For example, to access the state object, you would use the useState hook. To better understand what is being destructured in the app component, let's call a console log to the useState hook. The output reveals an array holding two things, the string hello and a function. In this case, hello is the state value assigned to the word state variable. The function is a built-in one that is not declared. The function can be destructured with any name you'd like, but there is a convention to follow. If you set the state's variable name to be greet, then the destructured state function should be setGreet. This is because the second destructured variable is a function that will be used to update the state of the variable. So, let's examine an updated version of the stateful function component. Notice that the setGreet variable is not actually run. That is something that is done elsewhere. Later in this course, you'll learn about how you can extend this code with a clickable button to update the state. In this video, you learned about state in React, specifically the characteristics of stateful and stateless components in an app. Why do we use state in React? Because it's one way to deal with data in our React apps. State is a powerful tool in React that developers use to manage data that is likely to change in an application. Recall that the state data is internal to the component itself. This allows the component to re-render based on the changes in the state data and present the newest updates to the user. With that in mind, let's explore how you can update a component with the useState hook that you encountered earlier. The useState hook allows a component to define and track state. It does this with two arguments, the first of which accesses state and the second of which updates it with a function. For example, you can use the date variable to access the date state, then use the setDate function to update the state. To help you understand how useful the useState hook can be, you're now going to explore an example that demonstrates how to use it to observe and manipulate the state of a component. Let's observe an app that was made for a Mediterranean restaurant called Little Lemon. It has a header child component, which receives the props and the object. It also accesses the message property before it returns it and renders it as an h1 element. In the parent app.js component, I import the heading component and I set the word as a state variable, set to the string of eat. For now, I ignore the comment after the eat string. In the return statement, I wrap the heading component in a single div. I pass the message prop of word plus and then in double quotes, at little lemon, all wrapped in an opening and closing curly brace. You already know that an opening and a closing curly brace signifies a JSX expression, which means that all the code inside of those curly braces will be evaluated as regular JavaScript. The JavaScript engine takes the word eat and concatenates it to the words at little lemon. Thus, in the browser window, I get the words eat at little lemon. If I want to update the value of the word state variable to something else like drink, I could use the setWord function directly to help me achieve this. However, when I save the change and run my code, the app does not work. This is because one can't use the state setting variable from your state directly. Instead of updating it directly, I can update it based on a click event. So I have another element called button, and onClick is equal to handleClick. I now set another function which I'll name handleClick. Inside the handleClick function definition, I run setWord to drink. I click File Save All and wait for the app to compile. Now when I click the Click Here button, I get drink at little lemon. To observe and update state, you can use the state setting functions and state variables using the state hook. But you must make sure that you use event handling attributes in JSX syntax or some other approaches, which you'll learn more about later. In this video, you have learned about state change basics in React, including how to apply the use state syntax to observe and manipulate state in components. Well done. As React applications grow in complexity, so too can the complexity of managing state across components. As a result, developers need a way to manage state in their application. In this video, you'll learn how to describe the concept of managing state and explore some of the solutions to managing state in React applications. To illustrate a scenario in which state needs to be managed, consider a small React app that helps promote a healthier lifestyle by allowing the user to monitor their food intake. This app tracks a daily meal plan, and the user can click on each individual meal as they've consumed it. The app then updates to show how many meals that are still left to be consumed for the day. The app consists of three components: a root component called app.js, and then two child components, meals list and counter. Let's explore each component in a little more detail. First, the app component imports the meals list and counter component and renders them on the screen. Next, the meals list component uses useStateHook to list a day's meals which are stored in an array. The array elements are saved inside the today's meals variable. Then the meals state variable is initialized to hold this value. In other words, the meals state variable holds the array. Finally, the counter component tracks the number of meals that a user is allowed to eat today. While this code and component structure may look good, there is a bit of a problem. The counter component needs to get state information from the meals list component, but both components are rendered by the app component. In other words, the meals list and the counter component are siblings and not in a parent-child relationship. This brings up a question. How can you pass the state information from the meals list component to the counter component, as the counter component is not a child of the meals list component? Let's explore a possible solution. First, you can simplify the meals list component by extracting the returned value into its own component. Then you can work with the separate components to display different meal items. So let's call this new component meals item. To do this, you can use the practice known as lifting state up. This means that you move the state from meals list up to the app component. Then you can pass state through props using the meals list component as a sort of bridge to the meal item component. And then you just have to count the data available in the counter component. The state has now moved up to the app component, and my meals list component becomes a conduit for the state data to be passed to its destination, the meal item component. The question you must now ask is, what is wrong with prop drilling? Prop drilling is a commonly used term to describe having to pass state through props in several layers of components, from the parent to the child to that child's child, and so on. Note that if the source data changes, you will have to transfer those changes across the entire prop drilled structure. This complicates things because state updates go to all the child components and their siblings, which then need to be updated to reflect this state change. Additionally, the problem gets bigger as the app grows, and you'll potentially have a huge amount of state being kept in the app component. Keep in mind that most of that state is not really supposed to be in the app component. That is because that state is about components such as the meal item component. There's another way to phrase this problem through the viewpoint of global state. Whenever I have state that might have to be used in various places in my app, that's a global state issue. An elegant solution for this issue is React's Context API. One way to think about the Context API is that it cuts out the middleman. There's no need for prop drilling and lifting state up. Instead, the component that needs the data simply gets it from the Context API. The way that this is achieved is by extracting the state into a separate file that holds the state in context. Then, any file that needs it simply imports it and uses it. Great job. You should now have a great understanding of managing state in React. During this course, you've probably learned a few approaches for managing state between a parent component and a child component. But have you wondered how well these approaches still apply for more complex apps with multiple levels of components? Fortunately, there are tools available to help you do just that. By the end of this video, you will understand how Context API can be used to manage state more efficiently across multiple levels of components. You'll also be able to perform basic state management using the useContext and user-reducer hooks found in Context API. By this point, you're probably familiar with the practice of passing state from one component to another by using props. While passing props helps to manage state, it is like taking a bus and going through each stop before you get off at the end. In comparison, using the Context API is like teleporting to your destination instantly. It's a way to bypass the redundant passing of data through multiple levels of components. Remember that API stands for Application Programming Interface. An API provides a predefined set of ways you can interact with some code. The Context API thus provides a streamlined way to work with context in React. To set it up, you need to add a piece of code that will be your context provider and is also where the state will be stored. When a component needs to use the state, it becomes a context consumer. Now let's examine a simple app that utilizes the Context API to control state. In my app.js file, I'll use some code for a starter setup, and you can also find this file in the additional resources if you'd like to use it to practice working with Context API. In the app component, I have import statements for meals provider and meals list. The meals provider provides context state data and gives it to all the components it wraps inside the app component. Currently, it wraps two components, the meals list component and the counter component, which are between the div tags of the return statement. The meals provider component holds all the state, which is organized with the help of the Context API. First, I set the meals context variable using the react.createContext function. Next, I declare the today's meals array, which contains several food items saved as strings. I then code the meals provider as an ES6 function that accepts the children value. This value holds everything that will be wrapped into the meals provider component when it gets rendered inside the app component. The children value is just returned from the meals provider, wrapped into the meals context.provider JSX element. The meals context.provider JSX element comes with the value attribute, and this value attribute gets assigned the meals object, which is the value I set to the useState variable earlier. Before exporting the meals provider component at the bottom of the file, I'm also setting the useMealsListContext variable to the react.useContext call and passing it to the meals context as its single argument. This makes it easier for me to destructure the meals object from the useMealsList context variable. Finally, in the meals list component, I'm accessing the context state by importing the useMealsList context from the meals provider file. Let's break down how this component works in more detail. First, I'm destructuring the meals property from the objects returned from the useMealsList context call. The original object has a single property named meals, which holds an array of 3 meal strings. Once I destructure the meals property from that object, all I have left is the array of 3 strings saved in the meals variable, which allows me to map over the meals value, where I'm rendering an h2 for each member of the meals array. This code is probably more complex than most of what you have encountered. Don't worry if it takes time for you to understand how it works. Just remember the important part, that this setup gives you a nice starting point for working with the context API. And lastly, let's examine the counter component. Note that it gets the context data in the same way that the meals list component does. This is the usefulness of having a centralized state store. It allows me to simply reach into the state provider directly from whatever component needs it, without having to do prop drilling or lifting up state. Next, let me show you how the useReducer hook works. Let's move on to the useReducer hook. You can think of it as a superpowered useState. While the useState hook starts with an initial state, the useReducer also gets a reducer function in addition to the initial state. Let me illustrate that with a code example. Let's say I have a rideshare app that represents the amount of money in my wallet. The initial state is a value of 100, and the action of picking up a customer increases the value, while the action of refueling my vehicle decreases it. I've applied a reducer function which takes in the state and the action. Instead of using setState like in the useState hook, I use the dispatch method of the useReducer hook, which accepts an object literal with a single property, type, set to a matching action.type, whose behavior is defined inside the reducer function. Now, when I interact with this app in the browser, I can increase the money value by clicking the A New Customer button, or decrease it by clicking the Refill the Tank button. In this video, you learned how the useContext and useReducer hooks can be used to manage state more efficiently across multiple levels of components. In life, there are rarely perfect solutions that suit every need. For instance, this concept applies when it comes to selecting a vehicle. A small car is usually more fuel efficient but has limited space. On the other hand, an SUV can handle many passengers but burns fuel quickly. Making the best choice starts with identifying your specific needs. This is no different when it comes to choosing stateful or stateless component in programming. By the end of this video, you'll be able to describe the differences between types of state and choose the best type to suit a given need, and explain how the dynamic nature of React causes structure decisions to influence complexity. The distinction between stateful and stateless components is that a stateful component holds state as internal data, and its state changes based on the way that the app is built, often as a result of user actions. A stateless component, however, doesn't store state, and any changes must be inherited through props. When deciding if a component should be stateless or stateful, you can refer to the following rules. Use stateless components when your component doesn't need to maintain its own state in order to work. Use stateful components when your component does need to maintain its own state in order to work. This might sound like an oversimplification, but let's explore why this general rule is enough. A common approach for organizing components in React is to have a stateful component as the parent, which then sends its state down to several stateless components that then receive the state and render it on the screen. The children components are stateless because they don't have their own state and only receive their parent state when passed down by using props. Keep in mind that you should never change the values of props in children components, as they are immutable. Now that you know the basic logic, let's break down a specific example of this approach in action, starting with two components, the app component and the child component, which returns a message. In the app component, the useState hook defines and keeps the states that will be passed to the child component as the props object. The app component renders the child component and passes the date to it in a string format as a prop named message. One thing to keep in mind, and something that is often overlooked by React beginners, is that a prop doesn't always have to pass state. In addition to state, JavaScript values and functions can also be passed to the child component. It's still data, but it's props data rather than state data. In the child component, there is an h1 element. The content of this element will be the message prop that is passed into the component. Note that props are not changed or updated in the component as they are immutable, meaning they can't be changed. Since the child component doesn't store any state, it is a stateless component. All of its data comes from the props passed into the component. The app component stores the state which can be changed through events and functions and is therefore a stateful component. In this video, you learned why and when to utilize stateful or stateless components in your React apps based on your specific needs. You also observed that although a stateless component can't directly pass state, it can still trigger actions that will update the state of other components. You've reached the end of this module, which explored the concepts of data and state in React. It's now time to recap the key knowledge and skills you've gained. Module 2 gave you an overview of the concept and practical use of state and stage management. In the process, you gained knowledge on how to handle events, and you learned how to dynamically change content on a web page. The first lesson was about dynamic events and how to handle them in React Native. You now know that every time you click or tap a button or scroll down a page, it produces events in the browser. And events are the process by which JavaScript interacts with HTML. You learned how to identify types of events and how to handle them using components. React can work with most of the same events found in HTML, but React handles them differently. This means that you may encounter unfamiliar errors when you run your event-driven React code. Thus, you learned about common errors associated with events and how you can deal with them. You also learned about the syntax differences for using event handlers in HTML and React, so that you can write event handling code using different types of syntax. Another important topic you covered are the different ways to embed expressions in event handlers in React. These methods include using an inline anonymous ES5 function, using an inline anonymous ES6 function, using a separate function declaration, and using a separate function expression. Then you moved on to learning how all the event handling concepts work together with state, styling, and the use of ternary expressions. To test your skills at dealing with dynamic events, you completed an ungraded lab where you practiced event handling by building a simple number guessing game. And that was the end of lesson 1. The second lesson was about data and events. In this part of the module, you learned about the React data flow hierarchy, like how data flows from a parent to a child component. In React, data flow is a one-way street. It starts at the root and can flow to multiple levels of nesting, from the root component to the subcomponent, and then the sub-subcomponent, and further down the hierarchy. This type of data flow ensures that the data is moving from top to bottom through the component hierarchy. It also ensures that changes are transmitted through the system. Next, you learned about state and how it relates to component behavior. All data in React can be divided into props data and state data. Props data is data outside the component that it receives and works with, but cannot mutate. State data is data inside the component that it controls and can mutate. Keeping track of state across components can be difficult, and this is where React hooks come in. Hooks are functions. One key benefit of hooks is that they solve the problem of unnecessary code reuse across components. For example, you can use the useState hook to track any type of data. It could be strings, numbers, arrays, booleans, and objects. The biggest benefit of hooks is the readability and simplicity that they provide to the code. You also learned about some common approaches for state management. For example, how Context API can be used to manage state more efficiently across multiple levels of components. You learned how to perform basic state management using the useContext and user-reducer hooks found in Context API. After this, you were introduced to stateful and stateless components, and you learned how to choose the best type to suit a given need. For example, a stateful component holds state as internal data, and its state changes based on the way that the app is built, often as a result of user actions. A stateless component, however, doesn't store state, and any changes must be inherited through props. You learned some rules to follow to decide if a component should be stateless or stateful. These are: use stateless components when your component doesn't need to maintain its own state in order to work. Use stateful components when your component does need to maintain its own state in order to work. And finally, you've completed an ungraded lab that tested your ability to manage state in React. After completing this module, you are now able to identify some common errors associated with events and use the syntax required to handle them. Use an event to dynamically change content on a web page. Explain the hierarchical flow of data in React. Recognize how data flows in both stateful and stateless components. Explain the concept and nature of state and state change. And use common methods to manage state in React. In the upcoming module, you'll learn about working with links and routing, as well as using assets in React. This should finalize your preparations for coding your own portfolio project in React. Excellent! You've made great progress in your journey toward becoming a React developer. In the early days of the web, there were no true standards for design, which meant that developers were often very experimental. There were various designs and experiments, but ultimately, the web development community settled on a few best practices, and today, the web is a mature medium. In this video, you'll learn about the basic types of navigation on websites and how the navigation process works in React. Now, if you think about the history of web layouts and web navigation, it's like the development of other great inventions throughout history. For example, after the Wright brothers flew the first plane in 1903 in Kitty Hawk, North Carolina, there was a period of a few decades where engineers were experimenting with different designs. Planes with 2 or 3 sets of wings were the order of the day. Finally, after this initial exploration stage, airplane design settled down and the rules and best practices of building airplanes were established. Like the development of rules of airplane construction, after the experimental years of the early web, the web design and development community settled on a few accepted and expected designs. The focus in modern website navigation user interfaces is on utility. Stephen Krug's famous book on user experience, Don't Make Me Think, sums up the rule that developers are following today. It's your duty as a web developer and designer to follow the best practices that have already been established. For example, a steering wheel does not belong on a washing machine, or an old-style phone dial does not belong in a car. In the same way, you wouldn't want to confuse your website visitors by giving them navigation that might look and feel smart, but that's completely different from what they're used to. So you might be wondering, what is accepted modern website navigation, and how does it work in React? Website navigation is the part of any website that allows you to browse through various pages or links on that website from a single component. There are several practical implementations of this user interface pattern. Let's explore each briefly now. The most common navigation components are a horizontal navigation bar, a vertical navigation menu, a menu hiding behind a button, and a footer navigation menu. The horizontal navigation bar is often referred to as a nav bar, and the vertical navigation bar is also known as a sidebar navigation. The menu hiding behind a button is usually represented by an icon that has 3 horizontal lines, and is thus referred to as the burger icon or the burger menu. An alternative to this is the drop-down navigation menu known as the mega menu. This menu is usually also hiding behind a button and is usually used as a sub or large menu on e-commerce sites and other sites that require many links. The footer navigation menu is usually displayed as several visual columns containing links. All these mentioned menu patterns can often be used simultaneously in different parts of the same page. Additionally, A more complex navigation UI can include multiple navigation approaches in a single component. You may, for example, have a horizontal navigation bar or navbar with drop-down menu items. If you're using a smaller resolution, the navigation bar displays as a burger menu icon. When you click on the burger menu icon, a mobile sidebar or a vertical menu appears. Okay, so now you're familiar with some of the navigation types that are available in your React apps. Let's explore how they are implemented to load different pages. If you compare the navigation of websites built with React against HTML and CSS, you'll likely find no visual difference. While visually everything looks the same, in the code, React deals with navigation between pages differently. This is because the entire app is loaded inside a single div, so you're not actually visiting different pages like you would with hyperlinks and HTML files. Instead, the content of that single div is controlled by React, and it's based on changes to the virtual DOM. It either updates the existing view or loads a completely new view, giving the user the impression of visiting a completely different URL. Recall that with HTML, developers can use a list to make a navigation menu. Each list item contains a hyperlink to an HTML file. Then, some CSS to style the menu, like the display inline property to make the list display horizontally. To help illustrate how navigation between pages works with React, think about how the buttons on the inside of an elevator work. Pressing the button will take you to the selected floor. Similarly, each link on a website takes you to a different page if you click on it. If, however, you're in a React elevator, it's as if the elevator never moves. Instead, when you press a button in this React elevator, the entire construction of that given floor is injected into a single floor of this impossible building. That means that React by itself only takes care of the visuals of a single page, but has no notion about navigation between pages. However, this functionality is not available to developers from the React library itself. In order to achieve this illusion of a multi-page website, you need to add the React Router library to your React projects. Once again, you add this using the import statement, and you'll learn more about how to do this soon. Well done! In this video, you learned about the basic types of navigation on websites and how the navigation process works in React.
By the end of this video, you'll know how to install the React Router library on your machine, which gives you more tools for setting up navigation in your apps. You also practice using this library to create a basic navigation for a web page. Let's examine a starter app that I've already prepared. It has two components, which are named Homepage and About Me. Currently, Homepage is written to display the header text, "Welcome to my site," on the page. The About Me component displays the header text, "About Me." Both components are children of the app component. Notice that Homepage and About Me are both imported into the app component and referenced using anchor tags. However, with the default React library, these anchor tags won't work as expected. This is because React can't imitate multi-page websites. However, I can make this possible with the help of another library known as React Router. As you may have guessed from the name, React Router gives you more control over the routing of components. I'll install it using the npm command npm I react-router-dom @6. To confirm that it's available, I inspect package.json and find the new entry in the dependencies, which is React Router DOM 6.3.0. Now that React Router is installed, I'm ready to make my broken links work. First, I'll access the index.js file and enter a statement to import browser router from React Router DOM. Once I've imported it, I need to wrap the app JSX element inside browser router by placing it between the browser router tags. With that done, let's return to app.js. Here I need to import routes and route from React Router DOM. I also need to replace the child JSX elements with some different code. Homepage becomes route path equals and then / between double quotes. This is followed by element equals and then the homepage JSX element inside of curly braces. Note that the route tag is self-closing and has no children inside. For about me, I add a similar line, but I'll add about-me after the /. These lines will also be encased between route tags. If I go to my browser and type the exact link on one of the routes, for example, /aboutme, I'll get only the About Me component showing under the navigation. However, if I remove the About Me from the URL, in other words, if I open the root route that is represented with a /, then it'll show the text from the homepage component under the navigation bar. Notice that I'm grouping all the routes by wrapping them inside the routes JSX element. Also, note that the nav tags are outside of the routes tag, meaning that navigation is outside the routes. Finally, I need to replace the anchor tags with React router links. This allows the correct component to be loaded when the link is clicked, rather than simply refreshing the page. So in the app component, the anchor tag for homepage becomes link to equals and then / between double quotes. This is followed by class name equals and then nav-item in double quotes. For About Me, the change is similar, except that About-me appears after the /. I also need to import link from React Router DOM and save my changes. Now when I click on either of the navbar links, the correct content loads in the browser. In this video, you learned how to install the React Router library and utilize some of the key functionalities to create a navbar. Now you're ready to learn about more efficient ways for users to navigate your apps.
By now, you should be familiar with the concept that React dynamically changes web page content. For example, you discover that when a React website changes from homepage text to About Me text, it isn't going to a new page, it's rendering one component instead of another. While this is useful, you need to give React very specific instructions about what and what not to render. And when you have components that are responsive to events such as clicks, this can add another layer of complexity. Fortunately, there are several approaches for writing the logic to ensure that this process goes smoothly and requires less work from you. By the end of this video, you'll have a high-level understanding of conditional rendering and know how to set it up using ternary operators. Recall that state is a component's internal data, which that component can control or change, as opposed to props, which the component receives but cannot alter. In an app, you can render components conditionally based on whether a specific state data has specific values. In other words, when you write the rendering logic in the main app component, you'll need to reference the state of the other components. For example, suppose you have a component that contains code for a button that shows a sidebar. The button controls the state of the toggle sidebar variable, which is set to false. When the button is clicked, the state of the toggle sidebar variable is updated to true, and the sidebar component is displayed. To make this possible, React works with conditional concepts and syntax that are already available in JavaScript. For example, recall the conditional if-else statement in JavaScript. Developers use it to run code conditionally based on whether something is either true or false. To illustrate conditional rendering in action, let's first consider an example productivity app. Based on the device's date at the time of access, the app displays one of two messages. For workdays, the message is "Get it done." For weekends, it displays "Get some rest." As a developer, there are a few ways you can achieve this functionality in React. But in this video, you'll focus on using the ternary operator to write simplified if-else conditions. You start by creating a component called currentMessage. This component uses the built-in date function in JavaScript along with the getDay method to store the day of the week as a number, where 0 represents Sunday and 6 the following Saturday. Next, you create the two components that each hold one of the messages to be displayed. Let's name these components workdays and weekends. The currentMessage component needs to render the appropriate component based on the value returned from the getDay function call. Let's set up the conditions to make that happen. Recall that the ternary operator takes 3 commands. First is the condition, which in this example uses the logical AND operator. The condition checks if the value stored in the day variable is greater than or equal to 1 and less than or equal to 5. Then the question mark symbol, followed by the expression to execute if the condition evaluates as true. In this example, the component workdays is rendered. Next is the colon symbol, which represents the code to be executed if the condition evaluates as false. And if this happens, the component weekends is rendered. Using the logical AND operator in the condition means that both expressions have to return true in order to render the workdays component. Otherwise, the weekends component will be rendered. While using the ternary operator is a common pattern that you'll see in React code, if you are new to React, it may be difficult to understand what's happening. So let's refer to a simpler version that uses Boolean values. In this example component, is it summer yet? The variable summer is set to a value of true. A ternary operator returns the expression after the question mark if the condition before the question mark is true. Otherwise, it returns the expression after the colon symbol. So since the variable summer evaluates to true, rendering this component will return the string "let's go to the beach." In this video, you learned about conditional rendering and how to implement it within dynamic apps by using ternary operators.
By the end of this video, you'll be able to describe the various approaches to conditional rendering in React, and you'll be able to use the if-else statements and ternary operators to render components conditionally. I used the Create React app to build a starter React app. I'll go through the code in this customized starter app to demonstrate some conditional rendering in practice. The goal of my app is to use the local computer's time and based on the returned values, output various messages inside the same return statement, all wrapped in a single div element. Specifically, I want to code a small app that displays a message for a given workday, and if it's morning time, ask the user if they've had their breakfast yet. I start my app component code by declaring a time variable and assigning the call to the date constructor to it. I then set the day variable, and I use the built-in toLocale string function that exists on the date object to specify the locale as English US. I also specify the weekday value as long, which displays the days as full words such as Monday, Tuesday, Wednesday, and so on. Next, I declare a morning variable that stores a Boolean value based on whether the current time is greater than or equal to 6 and less than or equal to 12. Finally, I declare a day message variable, but I'm not assigning any value to it yet. To generate a dynamic message, I use an if-else statement passing it the value of the day variable. I also make all the characters in the day variable string lowercase with the help of the built-in toLowercase function. Based on the value stored in the day variable, I then assign a specific string to the day message variable. For example, if it's a Monday, the day message variable stores a string that reads Happy Monday. If it's a Tuesday, the string reads Tuesday, 4 days to go. After I've covered all the possibilities from Monday to Friday, I add the else statement with a string value for all the other possibilities. The string reads, stay calm and keep having fun. This brings me to the return statement. In the return statement, I have a single heading, h1, and inside of it, I'm accessing the string value stored inside the day message variable. Additionally, I use a ternary operator to conditionally evaluate the morning variable. If true, I output a string that reads, have you had breakfast yet? This string is placed inside a heading 2 element. If false, an empty string will be displayed. Notice the output of this code, Happy Monday. If I change the get hours value from 12 to 19 and save my code, notice that a new message is displayed underneath the heading that reads, have you had breakfast yet? That's all it takes to build quite a dynamic component that conditionally renders various kinds of strings in its return statement. In this video, you learned about the various approaches to conditional rendering in React using the if-else statement and ternary operators to render components conditionally.
By now, you should be familiar with creating React components and adding text to them. But text will only go so far in an app, and users expect things like images, video, or audio for a more complete experience. Fortunately, you're here to learn about assets and how to use them to liven up your app. By the end of this video, you'll know what assets are and how developers keep them organized in React. You'll also learn some of the common ways to import asset files to be used in your React apps. Let's begin by making sure you fully understand what developers mean when they mention the term assets. In React, assets can be things like images, style sheets, fonts, media files, or basically any file that's needed by your app at runtime. In other words, assets are all the files that your React app needs to have access to in order to work as intended. For example, you might code your app to display specific images or use certain fonts. But if you run your app without these being available, it might exhibit unexpected behavior, such as displaying a placeholder or using a default font. That's why it's important to keep assets easily and readily available to your components. A common way to do this is to add an assets folder inside of the source folder and keep all your app's assets there. Some assets can also be placed inside the public folder. For example, in the default React installation, you'll find that some images such as favicon and logo 512 are stored there by default. The general rule for asset storage is that if your app can compile without it, you can keep it in the public folder. For instance, favicon is in the public folder because no component depends on it. In other words, React doesn't need to use the favicon file to compile all the components into an app that will get served in your local browser while you're building your app. However, suppose you have an image that needs to be imported into one of the app components, then it's best stored in the assets folder. Now you're familiar with the concept of assets in React, let's explore how to use assets. Suppose you're a developer working on an app that helps people adopt animals in their local area. You have built most of the app's components, but you are waiting on the adoption center to send you pictures of the animals that are looking for a new home. In preparation for this, you create the assets folder in the React application. The pictures arrive and you place them inside the assets folder so they can be added to your components. To add an asset file to a component, you first need to import it. This can be done with an import statement. For example, suppose this component will display a picture of a cat. You type the keyword import followed by the name you want to give your asset. You can call this almost anything you like, but it's best to stick to something descriptive that describes your asset. For example, cat. Then you type the keyword from, followed by the path to your assets. In this case, it's a file named cat.jpg, located in the assets folder. The next step is to create the function and write a return statement. Inside the return statement, you use the image tag and then set the source attribute to reference the asset name, which is cat in curly braces. Alternatively, instead of the asset name, you can reference the path to the assets folder relative to the component. You can do this with the require keyword, as well as curly braces that encase the JSX expression and act as delimiters. It's important to know that with this method, you no longer need the import statement. This is because you're using the required syntax right inside the JSX expression that's assigned to the src JSX attribute. In this video, you've learned what assets are in React and the best practices for storing them in your project folders. You've also learned some of the most common ways of importing and using image assets in your React apps.
In this video, I'll demonstrate various ways of displaying images. You'll learn 3 different ways to display an image in React app, specifically by using the import statement, using the require function to set the file path, or by providing an image URL. To demonstrate how you can work with embedded assets, I've created a basic app called Embedded Assets. In my app's source folder, I added the assets folder, which also contains an image folder. Notice I've added one JPEG image to the images folder named Central Park. To view the code of the app component, I click on the app.js file. Notice that the starting code of my app component just renders some text that describes the task at hand, which is to display 3 images with some styling. For this, I'm going to demonstrate the 3 distinct ways to import images in React. The first way is to use the import method, and I want to demonstrate how you set a name for your imported image. To import the image file Central Park, I type import rooftops and then // to provide a relative path to the file enclosed in double quotes. In this example, my file is in the images folder inside the assets folder. Next, I'll render this image as an image tag. In my code, I use the height attribute to limit the size of the image by making its height exactly 200 pixels. I'm setting the source attribute to the value of rooftops, which contains the path to the image file. Finally, for best practice, I add an alt attribute with a basic description of the image. I save my file and notice that my image now displays in the browser. Okay, so that's one way to import an image using the import statement. The second way to import an image is by using the require keyword. To do this, I create this image with an image tag like I did before. Again, I limit the size of the image by making its height exactly 200 pixels, but this time I set the source attribute to require. I pass in the relative path of the image to the require function. The path is passed in as a string data type, so that's why the path is enclosed in double quotes. Once again, to finish my image code, I add a description of the image to the alt attribute. I save my code, and the second image now appears. Notice that with this approach, I don't have to import the image. I just require it and provide the string with the relative path to the image. Now I'll demonstrate the third way to import an image asset by loading an image file hosted on the internet. Instead of a local file, this time I want to display a random image URL from a photo hosting website. To do this, I create a variable by typing const, then the variable name random image URL, then I use the equals operator followed by the URL for the random image. I can now add my third image element inside the return statement. To do this, I add random image URL to the source attribute. So there you have it, the 3 different ways to use image assets in a React component.
Since the introduction of the smartphone and high-speed Wi-Fi, we now enjoy creating, consuming, and sharing video and audio content daily on our devices. By the end of this video, you'll learn how React developers use audio and video assets within an app. You'll also explore how to find suitable React packages to use when working with audio and video files. Let's begin by exploring a method to load a local video asset into your React app using just HTML. You can use the readily available HTML5 video tag to load a local video asset to your React app. Like loading an image or any other kind of asset file, you can just declare a variable somewhere above a component's return statement and then add it as a JSX expression to the src attribute. However, this approach might not work as easily with some major providers of video content, such as one of the several social media and social video sharing platforms. In that case, you have the option of rolling out your own solutions. This may be a bit more involved than just adding a video tag to an app. It might depend on the specific instructions on how a given social media platform recommends that you embed their video and audio assets into websites. Very often, you'd get a code snippet that you can copy and paste. However, a specific implementation might be slightly different because you would, for example, like to add it as a separate React component. You might be wondering, why do you want to prepare it as a separate component? One of the reasons is that you'd be able to easily switch one video with another by passing the unique ID of a given video as a prop. You can then control the video output that way. So far, you've learned about 2 ways of adding videos to your apps. The first method involves just serving a local video using the video element, and the second method is using embedded third-party videos. There's another approach you may consider, namely using a third-party NPM package to streamline the process of adding videos to your app. The NPM package ecosystem is huge. If you visit the npmjs.org website, you'll find millions of various packages. To make it easier on yourself, Type React Video in the search bar of the npmjs.org website to find some of the frequently downloaded npm packages. To choose the right one, you might want to check the frequency of updates. A package that's frequently maintained and has many contributors is usually a sign of a solid package to use. Additionally, make sure to check the package's GitHub page. Finally, you can also perform an internet search for the package name. These actions will help you make an informed decision on which package to choose. An example of a package that fits all these criteria is the React Player package. Visit the package's GitHub URL at github.com/cookpete/react-player. You'll find that the React Player package has over 6,000 stars, about 115 contributors, and that it's regularly maintained. So, what is the meaning of the stars? When a developer visits any repository on GitHub, they can show their appreciation of the project by clicking the star button. This is known as starring a repo. This can be done for various reasons, but if a project has been starred many times, that's usually an indication of its popularity. These are all good signs, so if you want a custom open source solution for your video needs in React, you can choose this package or a similar one. Great job! You now have a general idea of how to use audio and video assets in a React app, and how to find packages using npmjs.org and github.com.
By the end of this video, you will know how to install the React Player package and then use it to render a media player in React apps. You'll also know how to apply several common settings in React Player, such as automatic playback and the starting volume. Let's examine another app that I've created using Create React App. Currently, it's pretty basic and only renders an H1 heading that reads React Player Example. Let's make that heading true by adding in a video player. The first step of this process is to install the React Player module, and the second step is to import it into my app component. To install the module, I'll run the command npm install react player. Once it has finished installing, the module becomes available to any component in my project, but only if I import it. So I'll use the command import react player from followed by react player in double quotes. Now I'm ready to add the imported React Player package as a component and render it from the app component. I also want to preset a few settings for the player, specifically to ensure that the video doesn't play automatically when the page loads and to have the starting volume at 50% of the maximum. To do that, I add some attributes to the React Player tag, playing equals and then false in curly braces, and volume equals followed by 0.5 in curly braces. For a complete list of settings, you can refer to the React Player's GitHub documentation. You may have noticed that the React component also contains the line URL equals vid_URL. This refers to the web link for the video, which hasn't been set up yet. So let's add that link to the vid_URL variable. Now that everything is set up, I'll click File and Save, and then verify that everything works as expected in the browser. I can play the video, use the built-in controls, and the video starts at half the volume, so it seems that everything is correct. Finally, you can find the project's GitHub URL at github.com/cookpete with a capital C and a capital P /react-player. This page contains an About section on the right in which you'll find a link to the live demo. On the linked page, you can select from several video sources and change the video settings such as playback speed, light mode, loop, and more. If you would like to know more about the React Player, I recommend experimenting with these settings and consulting the project's GitHub documentation. In this video, you learn how to install and use the React Player package and change common settings for the React Player.
You've reached the end of this module on setting up navigation, updating and using assets in React.js. It's now time to recap the key lessons you learned and the skills that you gained. In the module, you explored the basics of single and multi-page navigation, as well as the conditional rendering or changing of content in response to user status or choice. The first lesson covered linking and routing of components in React for navigation. Website navigation is the part of any website that allows you to browse through various pages or links on that website from a single component. And in modern website navigation, the user interface is all about functionality. You learned about the most common navigation components like the horizontal navigation bar or navbar. But of course, most websites have more complex navigation UI that include multiple navigation approaches in a single component, like combining a horizontal navbar with drop-down menu items. You learn that there's a key difference between the navigation of websites built with React versus those built with HTML and CSS. With React-powered web pages, called single-page applications or SPAs, the entire app is loaded inside a single div, so you're not actually visiting different pages like you would with hyperlinks in HTML files. That's because a single-page application, or SPA, comes with its own special implementation of anchor tags and links that give the illusion of loading different pages. To achieve this illusion of a multi-page website, you learn that you need to add the React Router library to your React projects, and you practice using it to create and implement a basic navigation route for a web page. In this lesson's ungraded lab, you used code from the lesson item titled the navbar, and you had to add another link to the existing code. After this, you learned about conditional rendering, which is necessary for React to be able to dynamically change web page content. As part of this section, you learned how to set up conditional rendering using ternary operators to write simplified if-else conditions. The second lesson focused on using assets in React. Here, you learned that assets are files that your app needs at runtime, like images, style sheets, fonts, video, or audio. You learned how developers keep assets organized in React, and about some common ways to import asset files. A common way to organize assets is to add an assets folder inside of the source folder and keep all your app's assets there. Some assets can also be placed inside the public folder. The general rule for asset storage is that if your app can compile without it, you can keep it in the public folder. In this part of the module, you learned how to use embedded assets and about the advantages and disadvantages of embedding assets, as well as about the trade-offs inherent in using asset-heavy apps. And in the first ungraded lab of this lesson, you learned how to add an image from the assets folder that had already been added to the src folder. What's more, you also learned more about using audio and video assets in an app. Here you learned how to find suitable React packages to use when working with audio and video files. And you learned about 3 ways of adding videos to your apps: by serving a local video using the video element, using embedded third-party videos, or using a third-party npm package to streamline the process of adding videos to your app. Additionally, you learned what you can do to help you decide what package to use. You should check the frequency of updates, check the package's GitHub page, and perform an internet search for the package name. To help you become familiar with using such packages, you learned how to install a React Player package and use it to render a media player in a React app. And you learned how to apply common settings like automatic playback and starting volume. Your final ungraded lab of the module was to finish an already built app with the user interface that allows visitors to play bird sounds by pressing buttons. Now that you've completed the module, you should be able to describe navigation design in React with a focus on single and multi-page navigation. Create and implement a route in the form of a navbar. Demonstrate the conditional implementation and rendering of multiple components. Explain the folder structure of a React project in terms of embedded or referenced assets. Demonstrate how to manipulate image assets using reference paths. And use media assets such as audio and video with React. Congratulations, you've now covered most of the basic concepts in React, and you're ready to complete this module's quiz and review the additional resources for this module. There's just one more module left before you complete this course. In the next module, you'll apply your knowledge by completing a mini project in React by building a calculator app. In this course, you learned about the basics of working with React. Let's take a few moments to recap the key topics that you learned about. In the opening lesson, you received an introduction to React. During this introduction, you learned about React, became familiar with how React is used in the real world, and you learned how to make the most of the content in this course to ensure that you succeed in your goals. You then moved on to the next lesson, in which you learned about React components. In this lesson, you learned how to explain components, their architecture, and how they are rendered. Create components and update them using JSX. Describe how folders are structured in a React project and how this benefits development. And you then demonstrated your knowledge of how to import components. In the next lesson, you explored how to use components in greater detail. This means that you can now declare functional components with props and pass them to another component. Use JSX to add styling to components. Save styles so that they can be reused later, and embed JavaScript expressions in attributes. Next, you began the second module, which was focused on the roles of data and state in React. In the first lesson of this module, you learned about dynamic events and how to handle them. You can now identify the most common types of events. Use some common event handlers in your code. Use different types of syntax to write event handlers. And you demonstrated understanding of the concept of user-triggered events. You then learned about the relationship between data and events. As a result, you can now describe how data flows between parent and child components and explain the concept of state in React and how it is managed. You were also introduced to hooks and know that you can use them to extend the functionality of state. And you are able to identify some common use cases for stateful and stateless components. In the third module, you were introduced to navigation, updating, and assets in React. By completing the first lesson, you can now identify the basic types of navigation on websites, create a basic navigation route with a React router library, explain how components can be rendered conditionally, use several different approaches to set up conditional rendering logic. In the final lesson of this module, you explored assets in React and how to use them. You can now explain what assets are and the best ways to store them. Use assets that are embedded in data files and use audio and video assets in your components. You've reached the end of this course recap. It's now time to try out what you've learned in the graded assessment. Good luck. I'll now demonstrate how you can use React to build a simple calculator app that is able to perform addition, subtraction, multiplication, and division operations. I have some code for this app already written. However, because it's incomplete, it encounters problems when it compiles. The first problem is that useRef is not defined, so I'll import useRef to fix that issue and then press Ctrl S to recompile. The second problem is that the useState hook is not defined, so let's import that as well. And when I recompile once more, the problems should be resolved. So the structure of the app is there, but currently it can only perform addition, so I need to add the other functionalities. Let's start by examining what I have for the plus function. It runs the prevent default function on the receive event object, and then it invokes a function for updating the state variable. I can use this as a template for the other functions I will write, so I will copy and paste this code into the functions I've started. In the minus function, I update result plus number to result minus number, so that it subtracts whatever is in the input. In the times function, I update the same snippet to result asterisk number. And finally, for the divide function, I use the divide operator or / to make it result / number. Now I also have two functions called reset input, which sets the input value to 0, and reset result, which sets the result value to 0 as well. Reset input needs to run prevent default, and I follow this with input_ref.current.value equals 0. For reset result, I use a different approach. I have it run prevent default, but then instead of setting the value to 0 directly, I have it multiply the previous value by 0. I type this as set result followed by an arrow function that directs prevval to return prevval times 0. Now if I go to the return statement of the app component, I find that I need to add the value of the current total as a JSX expression. So I type result. I can condense this code to a single line, so I'll do that. Next, I have to add buttons to trigger the functions that I've written. I paste in 5 button components that I've written previously, each of which is bound to an on-click event. This component is written for the plus function, so that is already taken care of. I'll update the other button components by changing the function that is called for each one, as well as the text displayed on the button. So the second button calls the minus function. The third button calls times. The fourth calls divide. The fifth one calls reset input. And the final button calls reset result. Now I press Ctrl S to save my changes. I'm ready to test out my app, so I type 2 in the input field and then click on the Add button. The result changes from 0 to 2, and then adding 2 again updates it to 4. Next, if I type 1 and then click on Subtract, the result becomes 3. If I enter 10 in the input field and click on Multiply, I end up with 30 as the new result. And now if I type 6 and click on Divide, I get a value of 5. Finally, I can click Reset Input to set the value in the input field to 0, as well as click Reset Results to clear the result and bring it back to 0. And that's it. My code is complete and my app works as per the requirements. You've reached the end of this React Basics course. You've worked hard to get here and developed a lot of new skills along the way. You're making great progress on your React journey. You were able to demonstrate some of this learning along with your practical React Basics skill set in the lab project. Following your completion of this course in React Basics, you should now be able to create a simple calculator app. Your calculator should be able to perform the 4 basic mathematical operations: addition, subtraction, multiplication, and division. The lab not only gave you the practical experience you needed, but it also has another important benefit. You now have a fully operational calculator built in React that you can reference within your portfolio. This serves to demonstrate your skills to potential employers. And not only does it show employers that you are self-driven and innovative, but it also speaks volumes about you as an individual, as well as your newly obtained knowledge. So, what are the next steps? In this course, you were introduced to several key topics that can help you on your learning journey. You probably realize that there's still more for you to learn. As you continue through the program, you will develop your skill set. So, if you found this course helpful and want to discover more, then why not register for the next course? And once you've successfully completed all the courses in this program, you'll receive a certificate that you can use to validate your achievements. The certification can also be used as a progression to other Meta role-based certifications. Depending on your goals, you may choose to go deep with advanced role-based certifications or take other fundamental courses once you earn this certification. Meta certifications provide globally recognized and industry-endorsed evidence of your technical skills. Thank you. It's been a pleasure to embark on this journey of discovery with you. Best of luck in the future.
So you're ready to start programming with JavaScript. But before you can begin developing projects with JavaScript, you need to set up software called VS, or Visual Studio Code. VS Code is a code editor that developers use to write their JavaScript code. By the end of this video, you'll be able to install VS Code, Node.js, and the Code Runner extension on your Windows operating system. Start a new JavaScript file in VS Code and run the file using Code Runner extension, and explain what console.log does in JavaScript. Let's begin by exploring the VS Code download and installation process. First, I open a search engine in my browser and search for the term VS Code, or Visual Studio Code. I click on the first link, which directs me to the official website at code.visualstudio.com. This link redirects me to the site's homepage, On this homepage, I select the Download for Windows button. A message appears on the VS Code website which states, "Thanks for downloading VS Code for Windows." I can then track my download progress in my browser. Once the file is downloaded, I click the file to begin the installation process. The license agreement appears. I read through the agreement and select Next. I then accept the default installation destination and the Start menu folder. I also select the following additional tasks: create a desktop icon, add Open with Code action to Windows Explorer file context menu, add Open with Code action to Windows Explorer directory context menu. Once I've selected these additional tasks, I click Next. Now that I have configured these tasks, I select the Install button. Once installed, I then check Launch Visual Studio Code and select Finish. My Visual Studio Code program then appears in a new window on the Get Started page. From here, I click the bottommost icon on the very left of the VS Code window to open the Extensions panel. Once in the panel, I type Code Runner to search for the Code Runner extension. I then select and install this extension from the search results. While the extension installs, I return to my browser and search for node.js. I access the file from the official site at nodejs.org and click on the direct download link, making sure to install the Windows version. A pop-up appears on screen to track progress of the download. Once the file has downloaded, I select Open File to open the node.js setup wizard. I then select Next and accept the license agreement. I then click Install to begin the installation process. Once the installation process has completed, I click the Finish button to close the setup wizard. I then return to VS Code, where the Code Runner installation process is complete. To confirm that Code Runner is installed, I can check for the following message on screen, which states, "This extension is enabled globally." Just to the right of the Code Runner tab is a stripe for the files. I double-click this to open a new file. I then click Select Language and choose JavaScript from the list of languages. I can also type JS in the search bar to narrow my results. Next, I close the Code Runner tab and click on the Extensions icon to toggle off the extension sidebar. I then click on the View tab and select the Terminal option to open the terminal that I closed earlier. I need to clear the terminal. I can do this by typing Clear and pressing the Enter key. Next, I hover over the terminal's Output tab. I then click, hold and drag it to the right in order to dock it on the right-hand side of the VS Code window. Now, I close the terminal again. The output should remain on the right-hand side of the screen. I can also adjust the width of the output by dragging the split to the left or right. Finally, I type some code into the tab Untitled 1 as follows: console.log, followed by a pair of parentheses in which I type Hello World in single quotes. To run this code, I click the play icon. I can also use the shortcut keys Ctrl-Alt-N. The words Hello World appear in my output. Other information also appears, but Hello World is all I need to focus on for now. And that's it. I've successfully set up VS Code with Code Runner. You now know how to install Visual Studio or VS Code, Node.js, and the Code Runner extension on your Windows operating system. You can also start a new JavaScript file in VS Code and run the file using Code Runner extension. And you can explain what console.log does in JavaScript. Great work.
Hello, and welcome to this advanced React course that continues from the React Basics course in this specialization. Throughout this course, you'll learn more advanced React concepts. Let's take a moment to review some of the key concepts and skills that you'll learn. In the first module, you'll start by learning how to render and transform lists in React and work with forms. In this process, you will be introduced to the map method to perform transformation operations and render lists of components. Then, you'll learn about identifiers called keys, which are an integral component in list transformation in React. You'll dive into controlled components with a focus on creating a controlled form component in React and implementing your own feedback form. And you will revise what you know about props and state, exploring React context as a viable alternative to local state in certain situations. You can also look forward to working with practical examples using the Context Application Programming Interface, or API, to manage global state in your React apps. In Module 2, you'll gain an in-depth understanding of hooks. This includes learning the use and purpose of React hooks, the rules for using hooks in React, and how to build custom hooks in React. For example, you will learn about the purpose of the use state, use effect, and use reducer hooks and how to use them. In the third module, you will be introduced to a variety of more advanced concepts related to JSX, as used in React, such as components and elements. You'll explore the types of children within JSX, discovering the importance of component composition and the children prop, how to manipulate children in JSX, and the spread operator in React. You will also be introduced to the process and purpose of creating higher-order components and render props, starting with an introduction to cross-cutting concerns. Another important topic that will be covered is performance in your React apps, as well as testing and debugging your application. Plus, you'll learn about writing integration tests using the React testing library with a focus on testing the behavior of forms and exploring practical applications of tests. During these modules, you'll work through practical examples of theoretical concepts based on a restaurant called Little Lemon and encounter activities to test your knowledge and skills. And in the last module, you'll have the opportunity to demonstrate some of your learning and your practical advanced React skill set in a lab project where you'll code your own portfolio app. You'll also demonstrate your knowledge of these topics in a graded assessment. Well, I hope you're as excited as I am to work through this React Advanced course. Let's get started.
The keyword React is more popular than words like orange juice and renewable energy. And so it has been a framework that is very widely popular, and it's something that a lot of jobs now require when they're hiring new engineers. My name is Murtada. I'm a software engineer at Meta based in the Seattle office. So just about everything I've built in my career at Meta has been built in React. So, if you're using any of the Meta products, whether you're using Facebook or Instagram, most likely the buttons and the menus and the clicks that you're making are all events and components handled by a React framework. And that has been my career at Meta, has been developing these kinds of components. So whether you're using it on a web, if you're going and posting a photo, or if you're making a comment, all of those interactions are powered by React components behind the scene. Well, I think personally, when I first discovered React, I was like, oh my God, this is so cool. And it just made building web applications so much easier. So it really simplified my job as an engineer to write using this framework. And it's very intuitive. It's much less error prone. So if we look at the trends we see in 2018, React actually rose up and exceeded what previously was the most popular web framework, which was known as jQuery, and React became the most searched keyword. So it makes sense for it to replace some of these older frameworks that are not keeping up with the speed of the industry. So the main language that's used to create React components is JavaScript, and there are actually different flavors of JavaScript that can be used with React. So at Meta, we use a Flow flavor of JavaScript, and that allows us to ensure type safety throughout the use of developing React components. But there are other ways that React components can be built. Perhaps a popular way that is common in the industry is using TypeScript. And besides these different ways to use React components on web, you can actually use React to develop mobile components on like Android and iOS. And most recently, React is releasing a way for developing VR components like virtual reality, where people can use these same frameworks consistently that are used in web and mobile to develop virtual reality applications. The idea is to simplify it and allow developers to create complex virtual reality applications, but leverage the simplicity and friendliness of React. And that's what has given the motivation to create these different frameworks of React across different segments of the industry. At this point, it's an integral skill that just about every job and every application you build will probably require. So having this knowledge will really help you throughout your career, and it's going to also make your life easier to learn how to use such framework. So my advice to you as you venture into this world of React is to stay consistent. It may at first seem a little complicated or overwhelming, or some things may not make sense, but just power through it. It will make your life a lot easier to learn these principles. They'll make you much more attractive to employers in the future, and your ability to produce scalable web applications will be much better with the use of this framework. So keep going and don't let some of these confusing parts of React slow you down.
So you're ready to start programming with JavaScript. But before you can begin developing projects with JavaScript, you need to set up software called VS, or Visual Studio Code. VS Code is a code editor that developers use to write their JavaScript code. By the end of this video, you'll be able to install VS Code, Node.js, and the Code Runner extension on your Windows operating system. Start a new JavaScript file in VS Code and run the file using Code Runner extension, and explain what console.log does in JavaScript. Let's begin by exploring the VS Code download and installation process. First, I open a search engine in my browser and search for the term VS Code, or Visual Studio Code. I click on the first link, which directs me to the official website at code.visualstudio.com. This link redirects me to the site's homepage. On this homepage, I select the Download for Windows button. A message appears on the VS Code website which states, "Thanks for downloading VS Code for Windows." I can then track my download progress in my browser. Once the file is downloaded, I click the file to begin the installation process. The license agreement appears. I read through the agreement and select Next. I then accept the default installation destination and the Start menu folder. I also select the following additional tasks: create a desktop icon, add Open with Code action to Windows Explorer file context menu, add Open with Code action to Windows Explorer directory context menu. Once I've selected these additional tasks, I click Next. Now that I have configured these tasks, I select the Install button. Once installed, I then check Launch Visual Studio Code and select Finish. My Visual Studio Code program then appears in a new window on the Get Started page. From here, I click the bottommost icon on the very left of the VS Code window to open the Extensions panel. Once in the panel, I type Code Runner to search for the Code Runner extension. I then select and install this extension from the search results. While the extension installs, I return to my browser and search for node.js. I access the file from the official site at nodejs.org and click on the direct download link, making sure to install the Windows version. A pop-up appears on screen to track progress of the download. Once the file has downloaded, I select Open File to open the node.js setup wizard. I then select Next and accept the license agreement. I then click Install to begin the installation process. Once the installation process has completed, I click the Finish button to close the setup wizard. I then return to VS Code, where the Code Runner installation process is complete. To confirm that Code Runner is installed, I can check for the following message on screen, which states, "This extension is enabled globally." Just to the right of the Code Runner tab is a stripe for the files. I double-click this to open a new file. I then click Select Language and choose JavaScript from the list of languages. I can also type JS in the search bar to narrow my results. Next, I close the Code Runner tab and click on the Extensions icon to toggle off the extension sidebar. I then click on the View tab and select the Terminal option to open the terminal that I closed earlier. I need to clear the terminal. I can do this by typing Clear and pressing the Enter key. Next, I hover over the terminal's Output tab. I then click, hold and drag it to the right in order to dock it on the right-hand side of the VS Code window. Now, I close the terminal again. The output should remain on the right-hand side of the screen. I can also adjust the width of the output by dragging the split to the left or right. Finally, I type some code into the tab Untitled 1 as follows: console.log, followed by a pair of parentheses in which I type Hello World in single quotes. To run this code, I click the play icon. I can also use the shortcut keys Ctrl-Alt-N. The words Hello World appear in my output. Other information also appears, but Hello World is all I need to focus on for now. And that's it. I've successfully set up VS Code with Code Runner. You now know how to install Visual Studio or VS Code, Node.js, and the Code Runner extension on your Windows operating system. You can also start a new JavaScript file in VS Code and run the file using Code Runner extension. And you can explain what console.log does in JavaScript. Great work.
You need to lay things out, and it's very difficult if you don't have CSS grids. Take one and... Oh, I'm having fun now. I'm Benedict Hobart. I'm a front-end engineer at Meta. Bootstrap is a very popular CSS framework, CSS library used to help quickly build websites. It has a lot of primitives that you'll commonly need when styling buttons or styling rows or styling grids. And then there's grids, which is a CSS layout spec that allows you to lay items out in a grid, which was previously a very complicated task. I know it sounds simple, but you can say, I want this item to be at this part of the grid and in this row and in this row. And helps you make more responsive apps as well. I learned about it years ago, I think probably in 2017 or 2016, and there is a whole class of layouts that are much more easily solved by grids than by previous layout approaches. You need to do a lot of computation in JavaScript to know the widths and heights of images and where to put them and how to get them to lay out at the screen. But if you've got CSS grids, it's just one line of code to then get things to lay out in a performant way that's responsive and reliable. Generally, you put a bunch of different layouts together when you're building a website. So you might use a grid spec in one spot, say in a table-based layout that you want to be responsive. But then you might use another layout that contains a grid and wraps it. And it's important to learn how to lay out items so you can build an app and define its layout in a flexible way. So being able to say, I want this to appear at the bottom of the screen when it's a footer, or appear as a tab bar at the top of the screen. I think there's a number of reasons you want to learn how to do it. I think most websites could be reduced to a grid. Knowing one layout and how one layout works in detail allows you to take that knowledge to easily learn future layouts that you might want to build. Starting off with one and getting a good grasp of that is a really good foundation to let you learn other layout engines. And if you ever want to move beyond web into iOS and Android, they've probably got their own layout engines that they use. I hope you develop a good understanding of how to use grids in your app and how it can be useful. I hope you understand that it's just one thing in a broader set of layout specs that you can use in the browser. And I guess more importantly, I hope you develop a strong foundation here that you can take into your career and learn other layout specs and how to build the next generation of apps.
How many times have you found yourself browsing apps? Maybe you've used an app to order food, Scrolling through different menus, hoping to find what you'd like? Well, lists like this are common to almost every app, which is why it's important that you know how to manipulate them in JavaScript. Chances are you'll need to transform various elements before displaying the final list to your users. So in this video, you'll learn how to use the map method in JavaScript to transform lists of data. Let's imagine that a restaurant called Little Lemon would like to display a list of its popular desserts. Remember that a list is a simple collection of elements, which translated to JavaScript terms represents an array. These arrays can contain any type of data, but the most common type you'll encounter per element is an object. Now, say Little Lemon uses an external service to query a list of its most requested desserts by users. However, when fetching data from a third party like this, you are generally provided with more data than you need, and the data will be provided in a format or shape that is determined by the third party. This means that you may need to write more code to handle the data in order to retrieve just the information you need. That's where the map method comes in, as a way to ignore everything that you do not want displayed on screen and extract only the data that your users care about. So let's explore how to transform this list of dessert items using the map method in JavaScript. In JavaScript, when you deal with lists of items of any kind, you need to use the array type. JavaScript offers different methods that you can use with arrays to perform various operations. In order to perform a transformation operation, you must use the map method. Coming back to Little Lemon, imagine you have a list of its top requested desserts encompassed in a variable called data. Each dessert has the following properties: ID, title, image, description, and price. In this case, you would like to show a very simple list of desserts with a property called content, which you can create by merging together the title and description and the price of the delicious dish. First, I'm going to define a new variable, since the map method always returns a new array. Let's call this new array top desserts. Next, I'm going to apply the map method to the original data array. For now, I'll return the data as it is, so you can examine the basic structure of a map transformation. I would like the new items to have two properties. The first is content, which is going to be a combination of title and description. Let's use a dash character to separate the two. Secondly, there's the price, which I will pass as it is. Last, I will console log the result to demonstrate that the new list I have created contains the shape or format that I originally intended. And here's your transformed list. You just learned how to transform data in JavaScript with a map method. This is a simple yet powerful tool you will find yourself using quite often when dealing with data from an external provider. Your users will thank you when they experience how easy it is to navigate and consume information in your apps. Did you know that with React, you can transform any list of items into a collection of React components? So, drawing upon the previous example of Little Lemon's list of desserts, imagine the restaurant would like to go one step further by providing its online visitors with a sneak peek at the best desserts in a dedicated section to encourage them to order. Well, in this video, you will learn how to display a collection of elements like this with React by using the map function and JSX syntax. Recall that JSX is a special syntax extension to JavaScript that React uses to describe user interfaces, or UIs, and that a component is a function that returns JSX. Now, let's explore how to render a list of elements with React. In this demonstration, I will use the list of Little Lemon's best desserts again, each one having the following properties: ID, title, image, description, and price. The aim is to display a simpler version of this collection of top desserts by displaying just the title and the price. The first step is to create a new variable called list items to store the result of the transformation I am going to perform. For that, I am going to loop through the array of desserts using the JavaScript map function. You may be wondering what I should return inside the map function. Traditionally in JavaScript, you would return any data type. When you are working with lists in JSX, you can also return a React component as the transformation applied to each element. You will discover how that's useful later on, since you will be able to embed the result directly into the return JSX. Recall also that all HTML tags are components by default, so you can leverage all the semantic tags you already know from HTML. For list items, your best choice is the list item or LI semantic tag. I am going to return an empty list item for now. Because the goal is to display the title of the dessert and its price, I am first going to create a new variable for the text named item text. I will use a dash to separate title and price, as well as the dot notation to access the needed properties from the dessert object, which are title and price. Since this is a JSX transformation that will be part of the render method of this component, you have to use curly braces to wrap your data. In this case, the text for each list item, which is the value of our variable item text. The last step is to go to the render method and embed list items into the HTML list wrapper component, unordered list, or UL. And that's it. The desserts are displayed in a simple and concise way. This addition will certainly help Little Lemon Restaurants to increase its orders, so well done. You have learned how to transform collections of elements with React by using a combination of the map function and JSX curly braces. With lists being one of the core building blocks of app development, you're now one step further in your journey to creating great apps. One important advantage of using React is its ability to automatically optimize updates in your user interfaces or UIs. If React was a plane, it would use autopilot mode in most cases, letting you relax in the driver's seat. But even with autopilot, you'll need to take action sometimes, like for example, performing a specific maneuver to land the plane. The same is true for React, as there are scenarios where you, as the developer, will need to take extra steps to specify how React should behave when your UI changes. In this video, you will explore how to use keys as a way to do so when dealing with lists of elements. You will learn how to use keys to identify and distinguish elements in a list, how to determine the right key for your list items, as well as what using keys incorrectly means for your app's performance. Because React is fast by default and designed with out-of-the-box performance in mind, you usually don't have to think about updates in your UIs. When computing a change, React applies its diffing algorithm to calculate the minimum number of changes that are necessary to perform an update in your tree of components. Although this algorithm works perfectly most of the time, as mentioned earlier, there are some cases where React can't make important assumptions to find the most optimal path for an update, which means the developer will need to step in. Let's explore one such example. Imagine the drink section in the Little Lemon online menu, where restaurant managers can add new drinks depending on the season. When they add a new element at the end of the list, the diffing algorithm works well, since React will match the two beer trees, match the two wine trees, and then insert the cider tree. However, when inserting a new element at the beginning of the list, the algorithm offers worse performance because React will mutate every child instead of realizing it can keep the beer and wine subtrees intact. This inefficiency can be a problem. To solve this issue, React supports a key attribute. So, what are keys? Keys are identifiers that help React determine which items have changed, are added, or are removed. They also instruct how to treat a specific element when an update occurs and whether its internal state should be preserved or not. To illustrate, adding a key to the last example can make the tree conversion efficient. That's because React now knows that the element with the key cider is the new one, and the elements with the keys beer and wine have just moved. The general rule of thumb with keys is to use a stable identifier that is unique among its siblings. This allows React to reuse as many elements from the list as possible, avoiding unnecessary recreations especially when their content is exactly the same and the only thing that has changed is their position in the list. The key used most often is a unique ID that comes from your data. Those IDs typically mirror a database ID, which is an ID given to an item in a database that by nature is guaranteed to be unique. But what happens in cases where your data doesn't have any suitable ID, or you are rendering a list that is not dependent on any server data? In these scenarios, you may think that generating your own unique IDs is sufficient, whether you do so via an external library or with a randomizer function like the built-in math.random function. However, while that approach will indeed avoid any collisions in your keys, meaning that it will not produce two keys that are the same, it will not preserve the internal state of your list items. This is because when a re-rendering occurs, those keys will be different, resulting in React having to recreate your list from scratch. As a last resort, you may use the item index. Since it determines the position of each element in the list, it guarantees the absence of duplicates. But indexes are not recommended for keys if the order of items may change. For example, in cases where your list has sorting capabilities or users can either add or remove items. When used incorrectly, keys can negatively impact performance and may cause unexpected glitches in your UI when updating your lists. That's why it is very important to make a conscious decision about your keys implementation. You have now been introduced to keys in React and how to use them when dealing with lists of items, such as using keys to distinguish between list elements, choosing the right key, and the effects of incorrect usage of keys on app performance. A primary takeaway is to always use a key that is guaranteed to be unique among its siblings, so use unique IDs from your data when possible. You can use indexes as a last resort, but don't forget that this approach will not work when the order of your list items is prone to change. Next up, you'll have the opportunity to explore using keys within list components in practice. Bye for now.
In this video, you will learn how to use keys correctly within list components in React through a practical example. Imagine that Little Lemon restaurant managers would like a separate application that keeps record of the tasks they need to do. In order to do that, I have built a very simple to-do list app with two different editable to-dos that are represented via text inputs, as well as a button that will reverse the order of the to-dos. I will start by walking you through the code example I created previously with Create React App. The to-do component is basically a table row which has an ID, a text input to type a value, and a date of creation. Both ID and created at are passed as props, whereas the input value state lives in the DOM node. In other words, the text input is an uncontrolled component. The main app component encompasses the whole interface displayed on the screen. The to-dos data model is a piece of state which is essentially an array of objects where each object contains an ID and a date of creation. Then there is the reverse order function, which effectively changes the order of the to-dos. The reverse method from arrays is a mutative operation. That means that it modifies the original array rather than a copy. To avoid mutating the React state, which is something you should never do, it's important to make a copy of the array first, which I'm doing by using the ES6 spread operator. Finally, when it comes to the JSX for the user interface, there is a wrapping div, a button to reverse the order of the to-dos, and a table, where each table row is a to-do task. Each to-do instance receives an ID and created at as props, which we are passing from the data model. Now coming back to the app, the first thing I'm going to do is to open the browser console. A warning in red is displayed. When you're running your application in development mode, React does a great job of providing solutions to potential problems in your applications via contextual warnings as console errors. The warning clearly states that each child in a list should have a unique key prop and that I need to check the render method of the app component. The index position of the to-do item fulfills the requirement that the React warning is asking about, so I'm going to use that. Okay, now when I reload the application, the warning disappears. However, I haven't tested the application yet, so let's type some to-dos and explore what happens when I reverse the order. For the first one, I will type stock take, and for the second one, process payroll. Now I would like to reverse the order because the managers should do payroll first. Oh, that didn't work now, did it? The text inputs have not moved, but everything else has. Well, You have just discovered one of the main problems when using indexes as keys when the order of your list items is prone to change. So what exactly is happening? If I go back to the code and take a look at the JSX for each to-do, when I reverse the order of the to-dos, the ID and created@prop have changed, but the key is still the same because I'm using the index. Since it's the same, React is instructed to keep the internal state of that node. That's why the input state from the to-do is preserved. Now, how do you fix that? Coming back to the key requirement, it has to be something unique but that correctly identifies each to-do, no matter what its position is in the list. In this case, I can definitely use the ID property from the data model as my key. After all, that is guaranteed to be unique per to-do. So now I'm going to implement that change, and I will run the previous test again by clicking the button one more time. Great, this time it worked as intended. You have learned about choosing keys in your React code. You will come across collections of elements quite frequently, and with your knowledge of keys, allowing your users to do the tasks they want to complete first won't be a problem anymore.
When browsing the internet, there's a big chance that you'll land on a form, even without you realizing it. From simple email inputs and subscribing to newsletters to more complex forms, such as creating an account on your favorite social media platform, forms are everywhere. So you'll probably find yourself implementing them in your applications regularly. In this video, you'll learn the concept of controlled components in React and how they are used in form processes, the fundamental concepts of HTML forms, and how forms can be created as React components. When it comes to React applications, HTML forms work differently to other DOM elements. You may recall that the DOM is a logical tree-like structure representing the HTML document, and it uses nodes to describe the various parts of the document. Traditional HTML forms keep some internal state inside the DOM and have some default behavior when submitting them. That's normally done via the action attribute, which points to the endpoint that will handle the request. But what if you would like a more granular level of control? For example, customers of the Little Lemon restaurant can reserve a table on the website using a form. Imagine if there was a function that could handle the submission of the form and access the data that the user entered into it. That's where controlled components come in. Controlled components are a set of components that offer a declarative application programming interface, or API, to enable full control of the state of form elements at any point in time using React State. Rather than relying on the native state from DOM elements, the React state is made the single source of truth, controlling the displayed value of your form elements at all times. The way you perform this state delegation is via the value prop. Value is a special property that React added to most of the form elements to determine the input content at any point in time during the render lifecycle. So, in order to create a controlled component, you need to use a combination of local state and the value prop. Initially, you assign the local state to the value property. But how do you get updates from any new text character entered in the input? Well, for that, you need a second prop to complete the design of your controlled component, the onChange callback. The onChange callback receives an event parameter, which is an event object representing the action that just took place, similar to events on DOM elements. To get the new value from every keystroke, you need to access the target property from the event and grab the value from that object, which is a string. Finally, to have control over the form values whenever the form is submitted, you can use the onSubmit prop in the form HTML element. The onSubmit callback also receives a DOM-like event as a parameter. There, you can access your form values to perform any desired logic that must take place before submission. For example, validating your input values. Also, if you would like to prevent the default HTML form behavior, you need to call event.preventDefault inside your onSubmit callback. Well, there you have it. You have discovered a technique called controlled components that enables React to be the source of truth for the state of your form inputs. React offers controlled versions of the majority of input types and recommends using controlled components for the implementation of forms. However, keep in mind that there are still some form elements that remain uncontrolled, similar to their DOM counterparts. So as you move forward with your learning, you will gain more insight into both controlled and uncontrolled form elements. In this video, you have learned about the concept of controlled components in React and how they are used in form processes. You also explored the fundamental concepts of HTML forms and how forms can be created as React components. Forms may look simple, but there are many different features and functionality to forms, and for developers, there is an art to constructing forms. React makes constructing and customizing forms much easier for developers, and that's why it's such a popular choice. Would you like to master the art of building forms with React? Well, there are some key concepts and features that you will need to learn to truly unlock the versatility and effectiveness of controlled components and forms using React. The Little Lemon restaurant online webpage was created some time ago. While Little Lemon were happy with the results for some time, they started realizing their users were having issues with their old contact form. After receiving some advice, they concluded that it needs to be rebuilt, and they have chosen React as the most suitable framework for the task, due to the ability to easily apply the features, functionality, and control that they require from the form. In this video, you'll learn how to help Little Lemon by creating a controlled component in React, using local state and the onChange event to update form inputs, avoiding the default behavior of the form submit event, and disabling the submit button when the form is not valid. Recall that controlled components in React are those in which form data is handled by the component's state, whereas uncontrolled components are those in which the form data is handled by the DOM itself. To gain more insight into creating form components in React, you will now examine the code of a basic form example. I am going to demonstrate the creation of form components in React using an app I constructed previously. In this example, the project has been created with create React app. The return method of this functional component essentially has a form that contains two elements, a text input to type a username and a submit button. This form resembles a classic HTML version, so it'll work the same way whether you're using React or not. To test the application, I type John as the name and click on the submit button. By doing so, the default action of the form kicks in, which is a GET request to the root and a page refresh. In React, this current implementation is considered an uncontrolled form, having all the states living in the DOM. Let's work through the necessary steps to transform this form into a controlled version. First, I need to create some local state for the text input, which I'm going to call name. Secondly, I need to hook up that state to my text input via two props, the value prop to turn the input into a controlled one, and onChange to receive all the changes per keystroke and thus update the state of my input. Last, to control the submission of the form, I have to use the onSubmit prop in the form tag. For now, I'll log a basic message stating that the submission was successful to the console. Now, let's check if the form still works as before. I'll type a name and click Submit. And it's working. My message was logged to the console, and the default behavior of the form has continued on. Although this is great, I'd actually like to have more control on the submission of the form. In particular, I'm not interested in the default behavior of calling the root of the server and refreshing the page. You may be wondering how I can prevent that from happening. In traditional forms, you would do this by returning false from the onSubmit attribute. However, in React, the way to do it is by using the event property you get as a parameter in the onSubmit callback and calling prevent default on it. Now, when I submit my form again, no refresh happens and no server is hit with a request. Let's go one step further and clear out the input after submission. For that, I call the state setter with an empty string inside the onSubmit callback. Great! My form is taking shape. To demonstrate even more benefits of controlled components, let's perform an additional improvement by only allowing the user to submit the form when the text input is not empty. Disabling the button is as easy as using the disabled attribute. In this case, if name is an empty string, this expression would be evaluated as true and the button would be disabled. So in the app, I can't click on the button if there's no name provided. Finally, for best accessibility practices, let's connect the label with the input. I set an ID for my input called name, and now I will connect the label. In traditional HTML forms, you would have to use the for property, but in React, for is a reserved word, so you must use HTML for and pass the ID of the input. Now, if I click on the label, its corresponding input is focused. And that's it regarding the basics of controlled forms in React. You have learned how to transform an uncontrolled form into a controlled version using local state and the onChange event, as well as the onSubmit prop and some of the benefits of doing so. In terms of form submission, you also learned how to avoid default behavior and disable the submit button when the form is invalid. Well done. You're making great progress.
Have you recently bought a product through an e-commerce site, or maybe you booked a table at your favorite restaurant? Well, if so, you may have received a friendly email afterwards providing a link to a specific page to provide feedback about the experience. This is an example of a feedback form. Now that you're familiar with controlled components in React, I'm going to demonstrate how you can build this functionality yourself. You will also be using a range input and custom validation as part of building a feedback form. Imagine Little Lemon, one of the best restaurants in town, would like to send their customers a feedback form. So let's go ahead and implement a feedback form with React. Note that in this example, the project has been created with Create React App. I have also added some initial code that is a form with just a header and a submit button. The requirements for this example are an interface that allows users to provide a score from 0 to 10, and an additional comment to tell the chef how delicious the food they enjoyed a few days ago was. The first step is to implement a control for the score. There are different ways you can do this, but I'm going to go and choose a range input for this use case, as it provides the user with a simple slider. To do this, let's go ahead and create a new div to wrap the component. This will consist of a label that I will name score, as well as an input whose type is going to be range. Range inputs offer two props to define the range, min and max. For this example, I will set the minimum to 0 and the maximum to 10. The application is now displaying a user-friendly slider to provide the score. To wrap up the range component, I need to do two more things: turn the input into a controlled component, and visually show the numeric value that represents the slider selection. For that, I will define a new piece of state called score that I will initialize to 10, because I know the chef's recipe is usually unbeatable, enabling the user to reduce the score down from 10 when they interact with the slider if they want to. Now in the range input, I have to use the value prop to hook the state up and use onChange to receive the changes and update the state accordingly. Since I also want the numerical score to be displayed with the slider, I'm going to add that information to the score label, along with a star so the user interface, or UI, is clean and concise. Great, the feedback form is starting to take shape. Now let's implement the second element from the form, a widget to provide an additional comment. Although I could use a text input here, a comment could be very large, so a more suitable choice is a text area. For that, I will declare another state variable named comment that will be initialized to an empty string. For the UI, I will create a new div with a label and a text area component for any additional feedback. Now that that is rendered well, I need to hook up the state to the value prop and update the changes via onChange. And with that, the UI for the feedback form is finished. The last thing I'd like to implement is some validation to ensure a comment is required when the score is equal to or lower than 5, and that it should have at least 10 characters, so the chef receives honest feedback from users that can be used to improve his recipe. For that, I'm going to use the onSubmit callback on the form component. I will call preventDefault first to avoid the default HTML form behavior. Then I'm going to write an if statement to check if the score is equal to or less than 5 and the comment has less than 10 characters. If that's the case, I will show an alert to inform the user about the requirement and return from the function. Otherwise, the user is good to go and I will log a message to confirm the successful submission of the feedback. It's also a good practice to reset the form values after submission, so I'll set both pieces of state to their initial values. And there you go, everything is working well and the submission message is logged into the console. You have learned how to build a feedback form with React using controlled components and custom validation to make sure users have a seamless experience.
Imagine that Little Lemon has been such a success that the restaurant will be expanding to other locations. As a part of the construction project, the architects have created blueprints with the kitchen and dining areas set to be identical in size. Although the blueprints have been defined, it will still be up to each restaurant manager to decide various things, such as the size, shape, and number of tables, type of chairs, kitchen crockery and utensils, and wall colors. In this analogy, the blueprints for the new locations are React components, whereas the specific configurations for each location are what React props and state represent. So, what are props and state? Props and state are both plain JavaScript or JS objects that React uses to hold information. As you progress through this video, you will discover the differences and similarities between props and state in React. You'll also learn how to identify whether something falls into props or state and when state is needed, as well as how to differentiate between different React components based on props and state. While both props and state influence the render output, they are different in one important way. Props get passed to the component, like parameters in a function, whereas state is managed within the component, like variables declared within a function. So even though props and state are inherently different, there are areas where they overlap. Notably, when designing a component, its main responsibility is to translate raw data into rich HTML. In the React ecosystem, the props and the state together constitute the raw data that the HTML output derives from. Both props and states are plain JS objects and are deterministic. This means your component always generates the same output for the same combination of props and state. Another similarity is that props and state changes both trigger a render update. Now, how do you know if something goes inside props or state? The rule of thumb is that if a component needs to alter one of its attributes at some point in time, that attribute should be part of its state. Otherwise, it should just be a prop for that component. Let's explore this in greater detail. Props, which is a shorthand for properties, are a component's configuration. They are received from parents in the tree and are immutable as far as the component receiving them is concerned. A component cannot change its props, but it is responsible for putting together the props of its child components. In addition to prop, React components have another built-in object named state. This object is a way to allow React to determine when it should re-render a component. React is set up so that any change to the values served in the state object will trigger a re-render of a given component. State's lifecycle starts with a default value when a component mounts, and then modifications of that value happen over time, mostly generated from user events. So state is a serializable representation of one point in time, or, in other words, a snapshot. A component manages its own state internally. You could also say the state is private. Now, another question you may ask when designing a component is whether it should have any state at all. Well, the answer is that state is optional. Since state increases complexity and reduces predictability, a component without state is preferable. Although you can't avoid having some sort of state in an interactive app, you should avoid having too many components with state. Finally, let's examine one of the main ways of differentiating types of React components based on props and state. Components can be stateless or stateful. Stateless components have only props and no state. There's not much going on besides the render function, and all their logic revolves around the props they receive. This makes them very easy to follow and test. On the other hand, stateful components have both props and state. They're in charge of client-server communication, processing data, and responding to user events. These sorts of logistics should be encapsulated in a moderate number of stateful components, while all visualization and formatting logic should move downstream into as many stateless components as possible. Well done! You've completed this lesson on the two types of data React uses to build applications, props and state. Going forward, you'll be introduced to an additional approach to managing information called context. In a typical React app, data is passed from parents to children via props in a top-down fashion. However, there are certain types of data that may be needed by many components within an app. In these scenarios, using props, which is what React offers us to pass data down, is not always effective. So in this video, you'll be introduced to an alternative way of passing data called context. You will learn more about what it is and why it was introduced and explore it in action. Let's imagine Little Lemon's food ordering app offers a light or dark theme that changes the background and text colors of all elements, or some general preferences, like a specific locale, depending on the visitor's geolocation that multiple components should be aware of. And what do these pieces of data have in common? Well, they represent a global state for your entire application. Now, as your app grows in size, the same will happen with the tree of components your app is composed of. As mentioned earlier, props is what React offers you to pass data down, but in this scenario, they can be cumbersome since you will have to explicitly pass that data through every level of the tree, having intermediary components that don't really need the data and just act as a proxy. This issue is commonly referred to as the props drilling problem, and the name says everything you need to know about the problem. Parent components have to drill down props all the way to the children that need to consume them. The way React has solved this problem is by introducing the Context Application Programming Interface, or API. Context provides an alternative way to pass data through the component tree without having to pass props down manually at every level. It is the right tool when you need to share data that can be considered global for a tree of React components. Let's take some time to examine Context API in action. In this demonstration, I am going to use a simple app I created previously with Create React App. It represents a simple blogging platform that Little Lemon has to publish new, innovative recipes to its subscribers. It consists of a header that contains a title and the current user that is authenticated on the top right. The rest is rendered by the page component, which itself consists of the user blog entries, each one with a title, content, and author name. Note that there are two components that need to know the authenticated user: the logged-in user component inside the header and the page component. Because an authenticated user falls into the nature of global data that needs to be shared across several components, this is a clear example where context is the perfect tool for the job. So let's go ahead and create the needed context, which I'm going to call user context. Now, within the user context file, you must follow the next steps. First, you need to import create context from React. This is the function that gives you a new context object back. The function argument is the default value, which in this case I will declare as undefined since the app doesn't know beforehand who the logged-in user will be. Second, you need to create a provider component. To do so, I will call it userProvider and render the userContext.Provider component. The userContext.Provider component is what allows consuming components to subscribe to context changes. This component accepts a value prop, which is what will be passed to consuming components that are descendants of this provider. Now, for this application, the value prop should be the authenticated user, so I am going to define a new piece of state for it. Note that this is an oversimplification that already assumes a specific user, as in a real-world scenario, you will have to fetch the authenticated user first and then set it as state. You will learn about fetching data later in the course. All right, so now that the state is defined, I will hook it to the value prop. Next, it's necessary to provide a way for components to subscribe to the context. For that, I am going to create a custom hook that wraps the useContext hook, which is the way to consume a context value. This external function is created just for convenience, so there's no need to export the user context to external components. As a side note, don't worry if you're not very familiar with hooks yet. They will be covered in depth in future lessons. The user context is now defined, but the app is still not aware of it. For that, the provider component is needed, so I'll go ahead and wrap the whole app with it. The last step is to consume the user context in the places where the user name has to be displayed, which are in the logged in user component and the page component. I'll go ahead and use the custom hook defined earlier, use user, and destructure the authenticated user from there. Finally, that information can be embedded in both render methods. The app now successfully displays the name of the authenticated user. Great work. You've learned about context and why it's used, and worked through a practical example of how to use it. But keep in mind that although context is useful for global state, it's still recommended that you stick to props and state as much as possible. That way, your app data flow will be easier to follow. Well done! You've reached the end of this module on React components. Let's take a few minutes to review what you have learned so far. You began the module with a comprehensive lesson on how to render lists with React. You were introduced to the map method in JavaScript, which can be used with arrays to perform transformation operations and is a useful tool when dealing with data from an external provider that you'd like to display differently in your app. You also learned how to transform any list of items in JavaScript using the map method firsthand. Next, you discovered how to use that map method function along with JSX to render a list of components and transform a collection of elements with React. Finally, you gained an understanding of the concept of keys, followed by a practical set of guidelines that help you choose the right key depending on your use case. You learned that keys are identifiers that help React determine which items have changed, are added, or are removed, as well as instruct React how to treat a specific element when an update occurs and whether its internal state should be preserved or not. You also discovered that keys can be used when you need to provide explicit information that tells React how to behave when your UI changes when dealing with a list of items. You learned that the general rule with keys is to use a stable identifier that is unique among its siblings, which is why the key used most often is a unique ID from your data. You then learned that it is possible to use indexes as keys as a last resort, but that this can negatively impact performance if the order of your list items is likely to change. Next, you moved on to a lesson on forms and how React treats them differently compared to traditional HTML versions. You were first introduced to controlled components, which are a set of components that offer a declarative API to enable full control of the state of form elements at any point in time using React State. You learned how to convert any traditional HTML form into a React form using a set of controlled components. In other words, you learned how to transform an uncontrolled form into a controlled version using local state and the onChange event, as well as the onSubmit prop. You also discovered some of the advantages of controlled components compared to uncontrolled components. For example, it makes it possible for you to have more control over form submission, such as disabling the submit button when the form is invalid. Last, you were taught how to implement a feedback form, and in relation to this, how to perform any custom validation logic before the submission of the form occurs. The final lesson began with a recap of props and state. You learned to clearly differentiate between props and state and when to use one or another. Recall that although props and state have similarities, for example, they're both plain JavaScript objects that React uses to hold information, props get passed to the component, whereas state is managed within the component. Key takeaways included that if a component needs to alter one of its attributes at some point, then that attribute should be part of its state. Otherwise, it should just be a prop for that component, and that a component without state is preferable. You also learned about stateless components, which have props but no state, and stateful components, which have both. After that, you covered the problem of props drilling and how it affects your component's modularity, as parent components have to drill down props all the way to the children that need to consume them. You were introduced to Context API as a solution to this problem and discovered how to use it to encapsulate any piece of global state and avoid manually passing props down between components. the power of React context was illustrated as a viable alternative to local state. Well, I think that's a fantastic start on your journey to mastering React. Looking forward to working with you in the next module.
Meta built studios for productions and virtual reality in New York City. And take, or what do you say? Take, what do you say? Action. My name is Murtada. I'm a software engineer at Meta based in the Seattle office. So React hooks were first introduced at the React conference, and it was shared with the community. And this is, the community of React enthusiasts who are excited about the new things. And they're the people that we trust to give us the feedback and test out the things that we're thinking about. I had gone on vacation and came back, and my coworker had been saying like, oh, there's this new exciting thing, let's start using it. And I looked at it and I thought, this is so silly. Like, why do we need this thing? And he's like, no, trust me, this is going to be great. So I was like, okay, fine. And, I started learning them. I started using them. And now I can't imagine writing code without hooks. At first, it sometimes feels a little unintuitive, or there's like a lot of magic going on that doesn't make sense right away. But once you get the hang of it and you start using it and understanding it, it actually really makes life easier to use. Hooks can actually simplify your applications greatly and introduce performance gains. They can make your code more readable and easier to manage, as well as your code more shareable and reusable. Before the introduction of hooks, we were using class components, and they seemed like they were doing their job. But with time, these class components were becoming bigger. They were becoming quite complex. We couldn't really break certain components down into more modular components or pieces. We wanted to make code more usable. We wanted to make it simpler and remove this need for having these huge bloated components that were not able to be broken into smaller pieces. When we develop new technologies at Meta, we try to be the first users of those things to make sure they actually work, and we get to be watching the feedback as it comes directly from our engineers. So the same thing with hooks. We started actually using them internally a lot. And we saw that internal teams are also starting to really appreciate the improvements that Hook introduced. And so that really justified that hooks are making a big difference in the process of developing React applications, and it gave rise to rolling it out more widely. So when hooks were introduced, they were actually introduced in a non-breaking way, which meant that you don't have to use them. You could continue to use the old style of writing React components, and they didn't break anything that was previously written. And this is one of the approaches that we use when we roll out new things, is that we want to make sure this new thing doesn't break any of the old things that people were doing. And my advice for you as you're learning hooks and working with them for the first time is to stick it out. They may seem hard and confusing at first, but they actually will improve your code with time. And it may be tempting to use the old way of writing React code, but actually with hooks, you will find that once you learn them, code will make more sense with hooks, even if at first seemed a little confusing and intuitive. So take the time to learn them, make that investment up front, and you'll find that it's worth it in the long run.
Imagine that Little Lemon needs a way to track the restaurant's food inventory. In this video, you'll work through some practical examples using an app built for Little Lemon to revise the useState hook and explore how the useState hook is invoked. You'll examine the return values of the useState hook and how it's used to update state. You are probably already familiar with the useState hook, which is used to work with state in a React component, with state being all the data an app is working with at a given time. But before moving on to useState, let's revisit the concept of array destructuring. Recall that array destructuring is a way to get individual items from an array of items and save those individual items as separate components. Now, let's explore this concept with a practical example. Say you're coding an app that tracks current food reserves in Little Lemon's pantry. You're using a variable to keep all the veggies in an array. As you continue to code, you realize you need to get each item from the array into its own separate variable. For the first item in the array, you want to name the variable v1, as in veggie1. The second item, v2, and so on. With array destructuring, you can do this easily using a single line of code. For more information on array destructuring, you can refer to the additional resources at the end of this lesson. Note that with array destructuring, you're free to give any variable name to the items that you destructure from an array. However, when destructuring objects, you have to destructure a property of an object using that exact property's name as the name of the destructured variable. This makes objects a lot stricter in terms of what you can name your destructure variables. For that reason, React uses the array data structure for the useStateHook's return value. Now that you've had a sneak preview of the return value of the useStateHook, let's explore how it actually works. I will demonstrate how to update state in React apps by using the useStateHook to set the initial value of the restaurant name to lemon, and then using only the useStateUpdating function to update it to little lemon. The useStateHook allows you to work with state in components. Let's start discussing state by revising what happens when I call the useStateHook. I'm only returning null from here because I want to focus on the console for now. Inspecting the console, this is what gets logged. The console logged value is an array, with the state variable's value being the first item in the array. The second item in the returned array is the function that will be used to update the state. So the useStateHook invocation returns a two-member array. The convention is to name this state updating function using camel case. Another convention is to name it by prepending the word set to the variable name used for the destructured state variable. In other words, the correct way to work with state means that my starting code example should be improved to correctly destructure the array returned from the call to the useStateHook. Now, the destructured restaurant name variable holds the state, and the destructured set restaurant name variable holds the state updating function. This is an example of array destructuring using the useStateHook. You may be wondering how you can update state. Well, when first starting to use the useStateHook, some developers try to update the state variable in a variety of ways. But there is only one correct way to update state when using useState, and that's through the state updating function. In other words, the only way to update the state of the restaurant name variable is by invoking the setRestaurantName function. In a React app, state changes are usually triggered through the act of a user interacting with the app. This means that state changes are usually triggered by user-generated events. These events, such as mouse movements, button clicks, and key presses, happen all the time in an app. The role of a developer is to respond to specific kinds of events in a way that's meaningful to the app that's being coded. One common way users interact with web apps is through button clicks. So let's examine an example of changing state in response to these user-generated events, namely button clicks. In this example code, I'm adding a button which, when clicked, will execute a function. This function is updateRestaurantName, which is invoked wherever a user clicks on the button. Now, when I click the Update Restaurant Name button, that will change the H1 heading from lemon to little lemon, because the invocation of the Update Restaurant Name function triggered a call to the setRestaurantName state setting function. You should now be able to recall what the useStateHook is used for and how it works in practice. I hope that working with the useStateHook will be a fuss-free task for you going forward, especially when working with primitive data types to track state in a component. Imagine it's the very early days of Little Lemon, with the restaurant only existing on paper. The owner would like an app to track the development of their restaurant business and the achievement of all related goals. Let's explore how to build a goals app with the described requirements in React using the useStateHook in a component and updating the state. The completed app is now displayed on screen. When this code is compiled, I get a heading that reads My Little Lemon Goals, and then I have a simple form with two inputs, goal and buy. The first input field is there to let the owner type out their goal, and the second input field is there to let them type out the time frame within which they want to achieve a given goal. The code itself consists of three separate components, goal form, which captures a new goal using a form, list of goals, which loops over all the previously added goals and displays them as an unordered list of list items, and the app component, which puts those two components together and allows me to render them as well as pass the functions that they'll be working with through their props. Let's explore these. The first component, namely the goal form component, accepts the props objects. In the body of the goal form function, I start by declaring a state variable of form data, which is destructured from a call to the useState hook. I initialize this form data variable as an object with two properties, goal and by, both assign the values of empty strings. Next, I declare two functions, changeHandler and submitHandler. First is the changeHandler function, which accepts an E parameter. This E parameter is a readily available event object. In other words, I don't have to pass this object from my changeHandler. It's provided to me by a mechanism outside of React. Even in plain JavaScript, whenever an event is fired, this creates an event object with many different pieces of data related to the event. I can then use this event object by simply assigning it a custom name, such as E, EVT, or even event. I'm using the letter E here to keep my code concise. In the body of the changeHandler function, I update the state of my form data variable by invoking the previously destructured state setting variable of setFormData, which was destructured from a call to the useState hook. The setFormData function accepts a shallow clone of the previous value of the form data variable. That's the form data variable with the spread operator before it here. Remember that you should not work with the form data variable directly, which is why I'm making a copy. This is because of how React optimizes its virtual DOM. Keeping state immutable makes it possible to compare a previous version of the virtual DOM with the updated version more efficiently and cost-effectively. Next, I update this new copy of the form data object by adding this code. It reads the eTargetName using the brackets notation, then sets the value of this property to whatever is inside that e.target.value property of the instance of the event object, which was built when that specific event was fired. The reason why this works with the brackets notation is that it allows me to set the value of the eTargetName dynamically. In other words, it allows me to set it as goal if the user typed into the input with the name attribute set to goal, or to set it as by if the user typed into the input with the name attribute set to by. Second, I declare a submitHandler function, which also accepts the event attribute. The goal form component receives the prop named onAdd, and I'm giving the function addGoal to it as the prop's value. But it's not just any function. It's actually a function that's declared right here on line 43, inside the app component itself. This addGoal function accepts a goal entry and updates the value of addGoal's state variable that's kept inside the app function. It does this by adding this goal entry to the list of previous goals, saved and tracked inside the allGoals state variable of the app component. The update of any state variable must go through the previously destructured state updating function. In the case of the app component, this state updating function is the updateAllGoals function. That's why I'm invoking this state updating function inside the addGoal function. To make it all work, I also need to pass the addGoal function definition to the goal form JSX element in the app component's return statement. That's why the addGoal function is now available as a prop named onAdd inside the goal form function. And that's why I can now use it inside the submitHandler function starting up here on line 10. So I'm back in the goal form function declaration. Once the props.onAdd function is invoked here on line 12, it receives the form data variable, which triggers the update of the allGoals state variable in the app component as described previously. But now, I still have the form showing the values that the user entered. To deal with this, I need to reset the form data state variable to an empty string, both on the goal property of the form data state object and the by property of the form data state object. This now brings me to the return statement of the goal form function. Here, I want you to focus on the form element that has the onSubmit event handling attribute set to the submit handler function. The first and second inputs both follow the same structure of having the type, name, placeholder, value, and onChange attributes, which hook into the previously described functionality. Moving on to the list of goals component, this component receives the allGoals_state variable as a prop from its parent app component. The purpose of this is to map over the allGoals array of objects, where each object holds the two properties that describe a single goal, as explained earlier. By mapping over the allGoals array of objects, I now output this unordered list with a list item entry for each individual goal. Having now worked through coding a goals app in React, you should have greater insight into using the useState hook within a component, including how to declare, read, and update state. Before moving on to using another hook, known as the useEffect hook, let's take some time to consider its name. The name of the useEffect hook is closely related to the concept of an effect, or more precisely, a side effect. In this video, you will learn what side effects within a React component are, including what pure and impure functions are and their relation to side effects, as well as how useEffect is used to perform side effects within functional components. So what is a side effect? A side effect is something that makes a function impure. Did you know that functions can be classified as pure and impure? Simply put, pure functions don't have side effects and impure functions do. Let's unpack the concept of pure and impure functions in relation to side effects some more. A pure function, should it receive specific input, that is, a specific parameter, will always return the exact same output, no matter how many times it gets invoked. To illustrate, let's explore a function that uses the year Little Lemon was established. In this example, the established year component accepts a props object, that is, a props parameter. It also returns a value, that is, a heading that outputs the words established year, followed by a colon, space, and the value of the year prop. As long as the value of the year prop is 2003, regardless of how many times the established year function is invoked or it is rendered from the app component, the output will remain unchanged. This is an example of a pure function. The established year function has no side effects. By contrast, an impure function will perform a side effect. That means it will do things such as invoke console log, invoke fetch, or invoke browser's geolocation functionality. In this context, a side effect can be thought of as something external to or outside of a function. Consider the example of a shopping cart function built for the Little Lemon app. It is an impure function because of the line that reads console log total. The console log call makes the function impure as it's a call to a browser application programming interface, or API. The shopping cart function now depends on something outside of itself, and even outside of the React app to work properly. So how should you deal with the issue of impure functions in React? Well, it's all about containing the impure actions inside their own special areas. To do this in React, you need to use the useEffect hook. Let's update the shopping cart component with the useEffect hook to properly deal with the side effect caused by the console log. First, you need to import the useEffect hook from React. The useEffect hook works by accepting two parameters. The first is a callback function. The second parameter is an array. This array can be kept empty, which is perfectly valid. While the syntax is valid, it's common to use an arrow function as the first argument of the invocation of the useEffect hook. Note that the useEffect has been simplified to a single line of code. It usually spans several lines of code. That's because it typically needs to do something more meaningful than just console logging the value of a component's variable. In this video, you learned about pure and impure functions and their relation to side effects, exploring what side effects within a React component are, and briefly how useEffect is used to perform them. You can look forward to applying this knowledge by using the useEffect hook introduced in this video to perform side effects. To demonstrate how to use the useEffect hook within a component, let's continue working on the Little Lemon app. Say the owner of the restaurant wants to add a specific way for the user to interact with the app. On a button click, the owner wants a welcome message displayed, and on another button click, the owner wants the message hidden. Additionally, the owner wants this change to be reflected on the Browser tab where the app is served. Updating a Browser tab is an example of a side effect. In this video, I will demonstrate how to do this by using the useEffect hook to perform side effects in React, as well as how to control when the useEffect function is run using the dependencies array. I am going to use an app I built previously using Create React App to demonstrate how to use the useEffect hook. To describe what's happening, let's start with a return statement. I have a wrapping div, and inside of it an h1, a button, and a JSX expression that uses the logical AND operator to conditionally render an h2. The button has an onClick event handling attribute, and it triggers the click handler function, which I've declared as a function expression starting on line 7. On line 5, I've destructured the toggle variable from a call to the useState hook to track the state of the toggle variable and make the conditional rendering in the return statement possible. Now let's inspect my app in the browser as it's currently being served. Everything is working well. When I click the button, the sentence "Welcome to Little Lemon" appears under it if it wasn't shown previously, and vice versa. Although the app is working well, my app currently has no way of updating the text in the Browser tab like the restaurant owner wants it to do. This is an example of a side effect, which is why the correct way to add this functionality is to use the useEffect hook. So above the return statement, I'll add a call to the useEffect function as follows: react.useEffect. I need to pass a function to the useEffect call, so I'll add an arrow function without parameters, and in the body of the arrow function, I'll add this ternary here, which checks if the value of the toggle variable is true or false. If it's true, it should return the string that reads "Welcome to Little Lemon." Otherwise, it should return the string that reads "Using the useEffect hook." Whatever gets returned is the value I'm assigning to the title property of the document object. This property thus dynamically updates the text showing on the tab of the browser where this React app is served. Let's inspect the updated app in the browser. I can confirm that with every click of the button, the title on the tab is updating to one of the two specified strings. So imagine that the owner has changed his mind and he wants the title on the document to be set on the initial component render. After that, he doesn't want it updated. This is where the dependency array comes in. The dependency array determines when the useEffect hook will be invoked. For now, I'll update my code with an empty dependency array, meaning I'm not tracking the state of any state variables. In other words, regardless of what is happening in my app, I don't want the useEffect hook to be invoked. This means that it'll be invoked only once, and after that, no matter what happens in my app, the useEffect hook will no longer be run. Now that I've updated my app, let's save the changes and examine how this affects the behavior of my app in the browser. The useEffect hook runs only once, outputs the words using the useEffect hook, and after that, regardless of how many times I click on the toggle message button, there are no further updates to the tab title. The dependency array is there to watch for changes to a specific variable, and based on that, execute the function that's passed in as the first argument of the useEffect function call. This means that if I want to run the useEffect hook whenever there's an update to the value stored in the toggle variable, I need to add the toggle variable to the dependencies array. After this change, back in the browser, the useEffect hook will be run every time the toggle message button is clicked, because the click handler updates the value of the toggle state variable by invoking the setToggle function. This, in turn, triggers the useEffect invocation, since the dependencies array is set to watch for changes to the toggle variable's value. And there you go. I have a way to fulfill any of the restaurant owner's requests that might involve some side effects in my React apps. You should now have a better idea of how to use the useEffect function to handle side effects and of how to use the dependency array to determine when it will be invoked. By now, you should have a fairly good idea about the purpose and functionality of hooks in React, and you may have even started using hooks in some of your solutions. If so, you may have encountered some cases where hooks might have made your code invalid. Well, that's because there are a few basic rules to hooks that you need to be aware of and follow in your React apps. In this video, you will learn all about the rules of hooks in React and why they are so important, and why you would only call hooks at the top level and from React functions. The 4 main rules of hooks are as follows. First, you should only call hooks from a React component function. Second, you should only call hooks at the top level of a React component function. Third, you are allowed to call multiple state hooks or effect hooks inside a component. And finally, always make these multiple hook calls in the same sequence. Now, let's unpack each of these rules in a little more detail. The first rule means that you should not be calling hooks from regular JavaScript functions. Instead, you should only call them from inside a React component function. From a built-in hook call, for example, from the useEffect hook, or from a custom hook. In this example, the code describes a button that can be clicked to pick up a new name for a pet. The name looper function is used to limit the pet name choices to only Fluffy, Rexy, or Gizmo. Notice that the useState hook is accessed at the outermost scope of the app function. It has not been used anywhere other than this, for example, inside the name looper function scope. However, you may have observed that this rule does not prevent you from using the state setting function, which is named setPetName here. State setting calls can be used wherever required. The second rule means you must call your hooks before a return statement, outside of loops, conditions, or nested functions. If you use a hook in a condition, you're breaking rules. For example, here the useEffect hook has been used inside the if conditional statement. That makes the use of the hook in this code invalid. The third rule is straightforward. There can be multiple hook calls, as long as they are always in the same order. What that means is that you cannot place hook calls inside conditionals, because that might result in an invocation of a hook being skipped when compared with a previous render. In this example, with the same code that describes a button that can be clicked to pick up a new name for a pet, the useState hook has been used incorrectly. Rather than using the state setting function, setPetName, inside the name looper function, the useState hook has been used here instead. If you were to compile the code and run the app, you may find that the expected output is returned. For example, I'd like to name my pet Fluffy with a Pick a New Name button rendered beneath. However, as soon as you click the Pick a New Name button, you would receive an invalid hook call error. That would violate the fourth rule. In other words, it might disrupt the sequence of invocation from one render to the next. Such a violation would result in errors. If you want to call an effect conditionally, you can still do so, but make sure to place the condition inside the hook. Here, the useEffect hook is invoked initially, followed by the if conditional statement. So now you're not breaking the rules, and the code is valid. So let's recap on the 4 main rules of hooks. You should only call hooks from a React component function. You should only call hooks at the top level of a React component function. You are allowed to call multiple state hooks or effect hooks inside a component. And finally, always make these multiple hook calls in the same sequence. And that's it. In this video, you learned the main rules of using hooks in React and why you would only call hooks at the top level of and from React functions. As long as you stick to these few simple rules, you can enjoy using hooks in your React solution successfully. The fetch function is a very useful tool, but there are some important things that you need to understand before you start using them. Initially, it's good to get an overview of how JavaScript delegates duties so that you can gain insight into how the fetch function contributes to this process. In this video, you will learn how the fetch function works to retrieve data from the web, and how to provide an example in plain JavaScript of the process. Fetch is used to make a server request to retrieve some JSON data from it. Fetch API is a set of functionalities that we have at our disposal to use in JavaScript to make such a server request. It's a bit like a clerk at the post office. Say you're bringing a package to the post office and you are the first in the queue. The clerk on the other side of the service desk is JavaScript. Since they can only do one thing at a time, they go through the process of getting your details, measuring the weight of the package, pasting stamps onto the package, charging you for the service, and going to the back office and carrying the package there, then taking time to find the correct place for the package before it gets shipped. The problem with this approach is that the next step cannot start before the previous one is finished. That's what's known as single-threaded execution. Since JavaScript is not at all equipped to multitask, a way to go around this issue is as follows. First, JavaScript gets your details. At the same time, it calls a clerk to measure the weight of the package. Then, JavaScript calls yet another clerk to paste some stamps onto the package. JavaScript calls yet another clerk to charge you for the service, and yet another clerk is called to carry the package to the back office, allowing JavaScript to take care of the next customer. Essentially, this delegation of duties is what's referred to as asynchronous JavaScript. In this metaphor, you can think of the browser as the post office, JavaScript as one clerk in the post office, and all these other clerks can be referred to as browser APIs or web APIs. Now let's explore a practical example of how this delegation of duties works in JavaScript. So I have a local HTML file. The most important part of this file is the script tag, which is getting some JavaScript code from the file named script.js located in the same folder as this HTML file. I'm serving these files locally using the live server VS Code extension. So let me inspect this HTML file in the browser. Okay, so currently it only shows a H1 heading that reads fetching data. Now, let me take a step back and let's say that JavaScript, the post office worker, needs to get some user data from the computer database. Here is the JavaScript code inside the linked to script.js file. What do you expect the output of this code will be, since JavaScript can only do one single thing at any given time? Well, let's explore what the code is doing step by step. On line 1, it performs a console log for the words another customer approaching. Then it contacts the fetch API, which is a browser API that is external and separate from JavaScript. Rather than waiting for the fetch API to return the information, it keeps on executing the code that comes after it, outputting the text that begins our valued customer. In the meantime, the fetch API requests some user data from a third-party web-based API, available at the randomuser.me website. The fetch function is what's known as a facade function, meaning it's a function that looks like it's part of JavaScript, but actually it is just a way for me to call a browser API from JavaScript. In other words, it's a way for me to access a piece of browser functionality that's outside of JavaScript. You can think of it as the JavaScript post office clerk calling the records department of the post office to get some data about a customer. When the other clerk gets back with the information and hands it over to the post office clerk, then they will get a JSON representation and finally will log that data to the console. That means that the sequence of console logs from the code will be as follows. An initial console log that outputs another customer approaching. A second console log that outputs our valued customer. Please wait a moment while I get some information back from the records department. And a final console log that outputs the data. I'll now execute this code to confirm the described behavior. Everything is already saved, so all I need to have this code executed is to go back to the browser, right-click on the page, and press the reload command to refresh it. You can achieve the same result by pressing the F5 key on your keyboard. So now I first get another customer approaching, then the our valued customer, and finally the result of the call to the third-party API. This is how JavaScript, although being single-threaded, can perform asynchronous operations. In this video, you learned how the fetch function works to retrieve data from the web and how to provide an example in plain JavaScript of the process. You should be familiar with this concept before fetching data in React, which I'll explore soon.
The Little Lemon restaurant wants to run a competition for its customers, where a lucky customer will receive a free meal at the restaurant. all customers that are signed up to the Little Lemon app will be entered into the competition, and a random customer will be selected as the winner. In this video, I will show you how to get some random user data from a website. I will be using the random.me website to access random user data for this demonstration. I have prepared some code for this app to fetch the user data from the website. If I execute this code, it will initially output the data pending text in the h1 heading. At the same time, in the background, it will be carrying out the fetch data function to retrieve the user information from the random user website. Notice that I have the DevTools open and the Network tab active. I will click on the No Throttling dropdown to artificially slow down my connection. In the dropdown, I will choose the Slow 3G preset. This is so that I can observe the data pending text in the heading before the data gets fetched from the web. Once the data has been successfully fetched, it updates the view with the data returned h1 heading and the user information that has been retrieved. In this example, the data that was requested was the first name and the last name of this random user. Let's step through this code in more detail. So first, I have the app function, and inside of it, following the rules of hook, I'm invoking the useState hook at the top level of the component. The initial value of the state variable is an empty array. Next, I have defined the fetchData function, which is fetching data from the randomuser.me API. Then it retrieves a response from the API in JSON format. It then updates the state variable with this JSON data. You may notice that I'm not using a hook inside the fetchData function because that's against the rules of hooks. After that, I'm calling the useEffect hook, and from inside the useEffect hook, I'm calling the fetchData function, which I've defined previously. Finally, I'm using conditional logic to decide what to return. First, I'm using the object.keys code snippet to put all the keys of the user object into an array. Since object.keys returns an array, I can access the length property on this array and check if the length of this array is greater than 0. If it is, it means that the contents of the state array has changed, because, as you may remember, the state variable's array was empty. So, if the array is no longer empty, then the div section will be returned with the h1 tag and a couple of h2 tags. Otherwise, the h1 tag below is returned that reads data pending. Sometimes it can take a little bit of time for the fetchData function to retrieve the data requested. Therefore, the data pending message would be displayed initially after the code is executed. Once the data has arrived from the fetchData call, this change in state causes a re-render of my component. So the return statement's ternary operator is re-evaluated, and that returns all the data from my call to the fetch API. And this is essentially how you get data from the web using React. So, the Little Lemon restaurant would be able to apply the same logic to their customer list API to select a random winner for their competition. In this video, you have learned how to fetch data using the state and effect hook. Imagine opening up the landing page of Facebook or Instagram, and all you see is just emptiness, because the things that fills the data in there, the photos and the words and the likes and the comments, all of those things are coming through the API. So writing APIs with integrity, with efficiency, is an important part of the application development process, and without it, you basically don't have an application. My name is Murtada. I'm a software engineer at Meta working in the Seattle office. The design process at Meta for APIs usually involves multiple iterations, just in the same way that when we write code, we get our peers and colleagues to review it. We do the same with API. Somebody or a group of people would usually write a document that's a proposal for how the API would be and what the structure is, what the agreements that each part of the application will make with each other. And then that proposal is usually placed forward. Other engineers will review it. They'll leave comments. They'll say, this makes sense. This needs to be changed. This is not good. And then we iterate, we improve it. And then when the API is looking good, it's in the final stage, we then take it to the next step, which is building it. In the building process, the same thing happens. We're going to review the code that is implementing the design that was created. And there are comments and feedback and iterations. And once that's complete, then we have our API ready. Usually the process of developing an API involves engineers on all ends of the spectrum. So we would be talking to the front-end engineers and the back-end engineers and people working in the middle layer in between as well to make sure that the APIs are consistent and make sense across the entire stack. And basically, if you think about APIs, to just simplify it, it's a way to talk to different things. If you have your mobile phone, you have your application and that you're holding in your hand, it has to talk to the server. And so the way it talks to the server is through an API. So if you want to talk to something, you have to establish some kind of understanding. And that understanding is established between the developers in order for it to be built into the application and reflected in the way that the API is designed. There are a few things we look for and follow when we're designing APIs. One of them is ensuring type safety. So type safety is basically a way to ensure that when you're fetching something from the backend, you're going to get what you're expecting. So if you're requesting a photo, that you actually do get a photo, not a video or something else. So that's an important part of designing API to make sure things don't break. A lot of the application failures happen when there's a mismatch in the data where you fetch something, you expect a certain object, and you get something else. So that type safety ensures these kind of mistakes or problems are minimized, and it increases the stability of an application when you have that consistent type safety across the stack. One of the things that I usually struggle with when designing API is making it such that it'll work for the future. And there's a little bit of a sweet spot to aim for with this, that we can obsess about wanting to make our APIs very compatible with the future and trying to anticipate how the application will evolve and we're going to need this and that and let's make it in right away. But also sometimes that could be too much, and finding that balance where you think about the future but not so much such that you're holding yourself back from actually getting the work done. It's just like with everything in life, you try to anticipate, but also you try to also focus on the problem in front of you now and how you can address it effectively. I know APIs can be a little overwhelming at times, so wishing you the best of luck. Take your time to learn them and don't let that overwhelm you or intimidate you. It's okay that when you're looking at APIs, you're going to be venturing into the back end. And so just know that you are taking on more scope and more complexity, and that's going to be good for you because you will become more attractive to employers. You will expand your knowledge. So don't let that intimidate you or hold you back. It's going to be helpful to learn these skills and concepts. The advice that I want to give myself and everybody who's thinking about APIs is to keep it simple. Sometimes we tend to overthink too and try to cram too many things into APIs and try to make it very fancy and very using complicated and complex design patterns. But actually simplicity is really important in API design, and the readability of it is a big plus. So keep it simple and try to keep it stable and free of bugs.
By now, you should have a fairly good understanding of the useState hook and be able to practically apply it to your solutions. However, the useState hook does have its limitations. For example, the useState hook may become cumbersome if you have complex state logic that involves multiple sub-values or when the next state depends on the previous one. In these situations, the useReducer hook can provide a much better alternative. In this video, you'll learn more about useReducer and how it differs from useState. You can think of the useReducer as a superpowered useState. The useState hook starts with an initial state, but the useReducer hook gets a reducer function in addition to the initial state. This is beneficial because the reducer function's second argument is the action object. This object has multiple type values, and based on each of these types' values, you can invoke the dispatch function to perform a specific operation. Now, say the Little Lemon restaurant is growing in popularity and demand, and as a result, keeping track of expenses is becoming an issue. So far, they have been calculating the income and outgoings manually as they sell meals to their customers and buy ingredients to replenish the stock. Little Lemon is looking for a solution to this using React in order to keep track of expenses in their app and reduce the burden on their staff. Because using the useState hook would make the solution to this unnecessarily extensive, this is a perfect opportunity to implement the useReducer hook in order to simply keep track of the cost of buying ingredients and the income generated from selling the finished meals to the customers. Now, let's explore how to implement the useReducer hook in a code example to reinforce your understanding. Imagine I am coding the expenses tracking application for Little Lemon discussed earlier using React and useReducer. With this app, I can track two actions: the cost of buying ingredients to prepare the meals in the Little Lemon restaurant and the income from selling the finished meals to the customers in the restaurant. For the sake of simplicity, I've only added two actions: buy ingredients and sell meals. The reducer function takes in the previous state and an action and returns the new state. The action type determines the specific action of the reducer. Actions can have any form. By convention, it's common to pass objects with a type property identifying the action. It should include the minimal necessary information that the reducer needs to compute the next state. You can find out more about extracting state logic into a reducer in the additional readings at the end of this lesson. Instead of using setState like the useState hook, you use the dispatch method of the useReducer hook. This accepts an object literal with a single property called type, set to a matching action.type whose behavior is defined inside the reducer function. As I'm already serving this app in the browser, let me demonstrate how it works. When I press the Shopping for Veggies button, the amount in the wallet decreases by 10, and when I press the Serve a Meal to the customer, the amount in the wallet increases by 10. With useReducer, you can define more types, as many as you need. This way, you can easily work with more complex logic in your React apps, something that might be too difficult to rationalize when using useState. To explore this in practice, let's add another action type. I'll name it Celebrity Visit. This action should be triggered when a celebrity visits the restaurant, which brings in $5,000 to the restaurant when it happens. To make this work, I've added another action type to the reducer function, and then another button to trigger it. I'll save my changes and preview the updated app in the browser. There, it's all working as intended. Clicking the Celebrity Visit button increases the wallet amount by $5,000. And it's as simple as that. Now the Little Lemon restaurant will be able to keep track of their expenses so that they have a clear view of how much profit they're making from their business. In this video, you have learned about the useReducer hook, how it differs from the useState hook, and why it can be a beneficial and more efficient solution in certain circumstances.
Imagine the owner of Little Lemon would like a search inventory functionality that would focus the cursor into the search input field. In this video, I will demonstrate how to code this specific requirement in a separate app so that you can focus on this particular functionality. So here I have another example app built using Create React App, or CRA. Note that for the purpose of this demonstration, I have made some tweaks so that I can more easily showcase the useRef hook. So, my starting app is just a return statement with a fragment, and inside of it, an H1 that reads, using useRef to access the underlying DOM. As I'd like to demonstrate how the useRef hook is used to access the DOM, I will use it to focus the cursor into an input field. So let me start by adding the input field. I will also add a button. Now that I've added an onClick event handling attribute, I need to define the focus input function to handle the button clicks. For the sake of simplicity, my click handler only accesses the form input ref object, and then it accesses the focus method on the current property, which exists on the form input ref object. But what is this object and where does it come from? This object is the return value of invoking the useRef hook. So in this update to my function, I'm invoking the React useRef function and I'm saving a ref object, that is the value returned from that function invocation, to a variable named form input ref. I'm then setting the JSX expression of form input ref as the value of the ref attribute on the input element. React will create the input element's DOM node and render it on the screen. This DOM node is assigned as the value of the current property of the ref object. This makes it possible to access the input DOM node and all its properties and values using the syntax form_input_ref.current. Since I want to access the focus function on the input element's DOM node, I'm using the syntax form_input_ref.current.focus. This allows me to move the focus to the input field so that it is ready to be typed into without the user having to click, tap, or tab into it. This is now triggered on a button click. To confirm that this works, I will save all my changes, go to my app being served in the browser, click outside of the input box, and click the focus input button. Great, everything is working as expected. You have just learned about using the useRef hook to hook into the DOM and work with the properties of a specific DOM node that you choose based on the task at hand.
Well done. You've reached the end of this module on React hooks and custom hooks. Throughout this module, you've explored hooks in React in depth and covered many important concepts and practical applications that will benefit you as you progress through the course. It's now time to recap the key lessons you've learned and skills you've gained. Your first lesson focused on the useState hook, which is used to work with state in a React component. You explored how to perform array destructuring using the useState hook and update state when using useState through the state updating function, and even how to change state in response to user-generated events like button clicks. You then worked through a detailed demonstration, learning how to use the useState hook within a component, including how to declare, read, and update state. Next, you learned about side effects in relation to another important hook, the useEffect hook. You discovered that side effects make a function impure, with impure functions performing side effects such as invoking console log, fetch, or the browser's geolocation functionality. In addition to learning about the useEffect hook theoretically, you learned how to use the useEffect hook to perform side effects within functional components and to control when the useEffect function is run using the dependency array through a practical demonstration. Recall that the dependency array determines when the useEffect hook will be invoked. Following the completion of Lesson 1 of this module, you should now be better positioned to work with state in React and to handle side effects in your components. The second lesson of this module focused on the rules of hooks and fetching JSON data from the web. First, you were introduced to the rules of hooks in React and unpacked them. These rules are that you should only call hooks from a React component function and at the top level of a React component function, are allowed to call multiple state hooks or effect hooks inside a component, and should make multiple hook calls in the same sequence. Next, in relation to the fetch function, you learned about the delegation of duties in JavaScript referred to as asynchronous JavaScript. You also learned about the fetch function itself, which is a function that looks like it's part of JavaScript, but is actually a way to call a browser API from JavaScript. This led up to the lesson on fetching data using the state and effect hooks. You worked through a demonstration where a call to the fetch API was used to get data from the web using React. Now that you've completed this lesson, you should have greater insight into what happens if a developer doesn't follow the rules of hooks in React and be able to describe how data is fetched in both JavaScript and React. In the third lesson of this module, you learned about the useReducer hook and that it differs from the useState hook because it gets a reducer function in addition to the initial state. You learned that the useReducer hook could be used in cases where the useState hook would be inefficient, such as when you have complex state logic, and how to implement the useReducer hook in your code. You were also introduced to the concept of refs and how they can be used to go beyond the virtual DOM and access the underlying DOM elements, as well as other applications, and had the opportunity to explore coding your own custom hooks. By completing this lesson, you should be able to use the useReducer hook to track state as well as roll out your own hooks in your React apps. You're making excellent progress. Now that you have a solid grasp of working with hooks, it's time to take a deep dive into JSX, which I look forward to guiding you through in the next module. At this point, you may be wondering how to define what JSX actually is, and it may not be entirely clear how React works with JSX to describe a UI and produce a user-friendly and effective app. Well, let's explore these concepts in a bit more detail. In this video, you'll learn how React uses JSX to describe a UI, the differences between components and elements, and the general concepts behind the React declarative model. The Little Lemon restaurant owners have been happy with their original website for a long time, But as they have grown as a business, they now want to add more features, functionality, analytics, and user interactivity. They are noticing that their original website was built in a way that means there are many limitations when it comes to these types of enhancements. After seeking some advice, they have concluded that they should develop an app using JSX and React. They want to understand more about JSX and React so that they can build a rationale into their business plan. So let's get started with JSX. JSX is a syntax extension to JavaScript that React uses to describe what the UI should look like. However, even though JSX looks like HTML, it's essentially a more powerful abstraction that combines both markup and business logic into an entity called a component. So, what is really happening from the moment you write JSX in your render function until React creates the desired assets for your pages? To understand all the steps involved, you need to be introduced to the concept of elements in React. By now, you already have a good understanding of components and how your entire UI is represented by a tree of them. You also know that the final web pages that React produces are nothing more than pure HTML, CSS, and JavaScript. When React analyzes your rendering methods from all your components, it takes the whole JSX tree starting from the root and creates an intermediary representation. This representation is essentially another tree, similar to before, but where each node, instead of being JSX, is a plain object describing a component instance or DOM node and its desired properties. This plain object is what React defines as an element. An element is just a way to represent the final HTML output as a plain object. It consists primarily of two attributes, type and props. Type defines the type of node, such as a button, and props encompasses all the properties the component receives in a single object. Observe how the elements can be nested, as in the button example, via the children property. When React creates the entire element tree starting from the root element specifies all the child elements as the children prop, and each child element does the same thing until it reaches the end of the tree. What is important about this new structure is that both child and parent elements are just descriptions and not actual instances. In other words, they don't refer to anything on the screen when you create them. They're just objects after all. But these objects are easy to traverse and, of course, are simpler than the actual DOM elements. So far, you have been introduced to an example of a tree transformation with simple DOM nodes, like a button. In the element tree, this is specified as the type property. But the type of an element can also be a function corresponding to a React component. Imagine you have created a component to encapsulate the traditional HTML button named Submit button. In this case, the type property of the element will point to the name of the component. This is the fundamental idea of React. Both user-defined components and DOM nodes can be nested and mixed with each other in the element tree. For example, if you were creating a logout process for the Little Lemon restaurant app, you could do this with a logout component in JSX. In this logout component, the JSX would translate to the following tree of elements. That allows you to mix and match components and DOM elements as the type property without worrying about whether Submit button renders to a button, a div, or something else entirely. This keeps components decoupled from each other, expressing their relationships through composition. When React sees an element with a function type, like the Submit button, it will know to ask that component what element it renders to, with the given props. So React will ask Submit button, again, what it renders to, and it will transform that into an element. React will keep repeating this process until it knows the underlying DOM tag elements for every component on the page. Once React finishes the process of identifying all user-defined components from the tree of elements, it will convert them into DOM elements. The result is what is generally known as the virtual DOM, a JavaScript alternative representation of the real DOM. Now, what are the steps involved when there is a new change in your UI? First, React will take all your JSX and produce a new UI representation as a tree of elements. Second, it will compare it with a previous representation that is kept in memory. Third, it will calculate the difference in a tree. Recall that since each node in the tree is a JavaScript object, this diffing operation is very fast. And finally, based on that difference, it will apply the minimum number of changes to the underlying DOM nodes in order to process the update. And that's it. You are probably starting to appreciate the beauty of the React declarative programming model. In this video, you have learned how React uses JSX to describe a UI, the differences between components and elements, and the general concepts behind the React declarative model. You have also seen that React transforms your JSX into an internal tree of elements, which are just JavaScript objects. And it is that lightweight representation that lets React update your UI in a predictable way while being fast enough for high-performance applications.
So the interesting thing about performance, it's one of these things that you can make it or break it with just one line of change. I mean, of course, sometimes it's possible that in order to improve a performance, you have to rewrite an entire application and start over. But sometimes small changes make a big difference. My name is Murtada. I'm a software engineer at Meta based in the Seattle office. At Meta, we really try to think about the different diversity and the different backgrounds that users come from and what technologies they might be using to access our product. So thinking about performance can make a big difference between gaining a user or losing a user, because if the application is not performing, it's not responsive, it's not fast enough, then people will not use it. So it's a big deal for us to think about performance when we're developing these applications. You know, it's never that our applications are just performant out of the box, and we try to look for the things that can improve their performance. Performance is usually something that we build incrementally, and we get to it by making incremental changes, because we may think that this is not important and it's more exciting to build a new feature, it's more exciting to make something more colorful. And performance is this kind of invisible thing that you may not notice it right away, you may not be able to show it and brag about it, but it's actually really important, and it's an underlying part of the application that without it, you can't really have the applications. You know, one of the things that React does really well, and it's kind of what has made it excel and become so popular, is that it's very efficient in building and rendering a web application. What React does really well is that it localizes the change such that if you need to change a small text, you can only have the work for changing that small text instead of having to re-render the entire page, which could be very costly for a computer to execute. So we try to look for bottlenecks and then go dive deeper into these and see, why is this component so slow? Why is it taking so long? How can we refactor this component to make it faster? Maybe we can delegate some of the computation to the backend so that we're not incurring this cost on the user and the front end. So the engineers and the product managers and the designers, they all use the application while it's being developed as much as possible to be in the shoes of a user and really feel the experience that they're going through when they're using our applications. And then once there's enough confidence that this application is ready, after checking all the boxes in terms of its performance, its stability, its usability, and as well as completeness, then we release it in an alpha stage where there's a small number of users trying it out so we can get some feedback. And as we gain more and more confidence throughout the feedback cycle, then we crank it up to more users until it's completely released. It's a very important part of the requirements for an application to be performant and usable. And in order to achieve that, there are certain design patterns and well-established approaches that engineers have developed over time that have known to work really well and increase performance of applications. So like using memoization or delegating part of the processing to the backend. So I encourage you to look for those and find ways that you can introduce these design patterns in your application.
When designing React components, one of the most important properties developers tend to overlook is the children prop. The children prop, which is a special property all components have, is the foundation for the React powerful composition model. Say the Little Lemon restaurant wants to enable users to have accounts on their app. This would mean processes would need to be built to create, manage, and delete accounts in the app. These types of processes can be constructed simply and efficiently using component composition with children. In this video, you will learn why component composition is so important and how to effectively use and appreciate the children prop. You will also learn about 2 key features of composition, and you'll explore some practical examples that will help you understand how you can leverage it so your components are more robust and reusable. There are 2 main features that enable component composition: containment and specialization. Let's break down these 2 main features now, starting with containment. Containment refers to the fact that some components don't know their children ahead of time. This is especially common for components like a sidebar or a dialog, where they delimit a specific area in your UI to contain other elements. You can think of them also as generic boxes. In case you don't know, a dialog is a type of modal window where the rest of the UI is disabled until the modal is addressed and interacted with. For these component boxes, the recommended approach is to use the children prop to pass children elements directly as their content. Let's explore this with a dialog example. Here, you have a dialog component which acts as the box, taking care of styling the container to make it look like a modal window. By using the children prop, it has become a generic component to which we can provide any valid JSX as children. To illustrate that, the confirmation dialog component has been defined, which uses the dialog component and renders as children, a title and a description. This example also showcases the second feature of component composition: specialization. Specialization defines components as being special cases of other components. In this example, the confirmation dialog is a special case of dialog. Now that you are familiar with the basics of component composition, let's go ahead and code an application to demonstrate what you've learned. This application has been created with Create React App. Imagine Little Lemon would like to offer an easy way for their users to delete their accounts if they want to. The goal is to build a generic dialog component that will contain a title, a description, and a warning button to make sure users are aware of the action's consequences, all using component composition. I have already created 2 generic components, a button and an alert. The button uses the children prop to specify its text, and the alert is a generic box that renders an overlay in the background and a white modal in the center of the screen. The children prop determines the content of that modal. The first step is to create a warning button using the specialization feature of component composition. For that, I'll define a new component named Delete Button, where I'll render the button component and configure its properties to have a red color and the text Delete. Then I'll go ahead and render the alert component. As it stands, it's just a generic white box or container. This illustrates the second feature of component composition, which is containment. I can customize the content of the box in any way I would like by just providing JSX as its children. To fulfill the requirements of Little Lemon, I'll create a header titled Delete Account, as well as a paragraph to inform the user about the action. I want to state clearly that they will miss out on the chef's delicious recipes if they delete their account, so I'll reflect that in the description. Finally, the last piece is to render the delete button as defined previously. And that wraps it up. In this video, you have learned about a React technique called component composition and why it is so important. You also learned how to embrace the 2 key features of composition: containment and specialization. And you explored some practical examples that helped you to create components that are more robust and reusable using the special children prop. React Children is one of the special props all your components have implicitly. That, along with the React composition model, enables a new paradigm of component design. So far, you have discovered how to leverage this special prop in read mode only, meaning that your components consume it as it is provided. But what if I told you that you can go even further and transform your children's elements in any way, shape, or form? To illustrate, say the Little Lemon restaurant wants a way to visualize a summary of live orders as they come in from customers. What would be really useful for the chefs working in the kitchen is to display each customer order in its own separate row, with the name of the dishes, the amount of each dish, the total price, the time of submission, and the full name of the customer. Well, by using a set of new React APIs that will enhance your component design skills, you will be able to solve this problem for Little Lemon with a smart and efficient solution. Let's start by exploring two of these powerful React APIs, react.cloneElement and react.children. In this video, you'll learn how to use both of these React APIs and how they can be used to manipulate the render output dynamically. Let's explore the first of these APIs, react.cloneElement, in more detail. This is part of the React top-level API, and it's used to manipulate and transform elements. Top-level API refers to the way you would import those functions from the React package. You can either import React as a global object in the top of your file and access them as methods on that object, or alternatively as a named import. Recall that elements are just plain JavaScript objects that React uses internally to describe what you want to appear on the screen. React.cloneElement effectively clones and returns a new copy of a provided element. The first argument is the React element you would like to clone, and the second argument is the props that will be added and merged with the original props passed into the component. Remember that props in React are immutable objects, so you must create a copy of the element first and perform the transformation in the copy. That's exactly what React.cloneElement allows you to achieve. This API is useful to allow a parent to perform the following operations: modify children properties, add to children properties and extend the functionality of children components. For example, you could add another prop dynamically to the submit button element illustrated before. Another important top-level API useful for children manipulation is react.children, which provides utilities for dealing with the props.children data structure. The most important method is the map function. React.children.map is very similar to the map function from arrays and invokes a function in every child contained within its children prop, performing a transformation and returning a new element. Don't worry if those APIs still sound a bit confusing. Let's get into some code to give you a better picture. The Little Lemon restaurant is busy receiving live orders. To visualize a summary of those orders, I have been tasked to display each one of them in a row, having a fixed horizontal spacing between each piece of key information. In this application, there is an order that has been submitted for a client, requesting a pizza margherita. Each order contains the name of the dish, amount, total price, time of submission, and full name of the client. I have created a row component that will handle the separation per item. At the moment, it just returns the children as they are provided, so all the items on screen are cramped with no separation. Let's go ahead and use both react.cloneElement and react.children.map as the implementation to solve the separation problem. The first thing I'll do is use the children.map function to iterate through each child. So far, I am returning each child as it is, so still no changes on the screen. To implement even horizontal spacing, I am going to add some custom style that will set some left margin in each child except for the first one. In order to specify the amount of space, I will create a new prop called spacing that will be the number of pixels and will use string interpolation to set the margin style properly in pixels. Now that the style is defined, I need to attach it as the style prop in each element. So in the map function callback, I'll return a new copy of the element using react.cloneElement. The second argument is what lets you specify the new props. In this case, I'd like to add a new style prop that will merge the previous style. If the element is not the first child, then I'll also merge the child style object that contains the margin left statement. Great. The last step then is to use the spacing property in the row component. Let's set it to 32 pixels. And there you go. Each live order now presents all the information clearly so that chefs don't make any mistakes and cook the wrong pizza. In this video, you have learned about two new APIs, react.cloneElement, and react.children.map, providing you with a powerful toolset to manipulate children dynamically with ease. The spread operator is one of the coolest additions to the JavaScript language. Thanks to the spread operator, which is represented by 3 dots, common operations that previously required a bit more code, like cloning an object or array, are now so much simpler. So in this video, you will learn how to use the spread operator in objects, how to spread native properties to DOM components, how to design flexible components, and about the caveats when using the spread operator. Imagine that the Little Lemon restaurant wants to have a simple welcome screen where users can sign up or log in depending on whether they have an account or not. The sign up and login buttons are in nature very similar, with differences in the text and the action taken when they are clicked. To achieve this implementation, you could define a button component that encapsulates the native HTML button element and uses the same props as its native counterpart. However, a button presents dozens of different properties for customization. Instead of having to specify each of them manually, the spread operator can be used to forward all of them without typing each one manually. React embraces this operator at its core when it comes to props. But before digging deeper, let's refresh what this operator enables for objects in pure JavaScript. The spread operator can be applied to different data types in JavaScript, such as arrays, objects, and even strings. Since React props are just objects, this lesson is going to be focused strictly on the object type. Copying and merging objects are the 2 main operations you may perform with these operators. For a simple copy of an object, this is the syntax required: curly braces and the 3 dots preceding the object to copy. In this example, order amend represents a last-minute change to the type of pizza ordered by the customer. For merging, first you need to spread the properties from the original object and then provide the new properties to be added or to replace original properties. The property called item has been replaced with the new order information. Great. Now that the preliminaries are covered, let's explore how React uses the spread operator. This order list component example renders an order component. Each order component expects 4 props: an ID, username, item, and price. This first example shows how you might usually do it, passing all the props in the return statement explicitly. However, this can be simplified if you already have the props your order component needs in an object. Here, you can see that only the spread operator is required in the return statement, saving us time by just spreading all the props and avoiding having to type them manually. This pattern allows you to create flexible components, but there are also some caveats you need to keep in mind when using the syntax. Let's explore this in more detail with an example demonstration. In this application, I have created a simple welcome screen for Little Lemon Restaurant, where users are able to sign up or log in, depending on whether they have an account or not. At the top, I have defined a button component that wraps the native button from the DOM. This component expects the same props as its native counterpart, with the addition of the type prop, which is a custom prop that determines the background of the button based on the theme provided. Here is a clear example of using the spread operator to group all the props that belong to the native button and explicitly extract the custom props I have defined for this component and are React specific: type and children. This implementation is clean for developers, since they can provide all the props a native button would expect. The second example is a login button component that renders the custom button component I have created itself. This login button does some pre-configuration by fixating some of the props from the button component, in this case, type and onClick, while still passing the native button props down with the spread operator. Now, the app component renders the 2 buttons and uses the button component for the sign up and the login button component for login. The buttons are both configured here to send the user to the sign-up page, unless they have an account, in which case the login button component's original onClick function will send them to the login page. I have also provided both with an onClick handler to show an alert about the intended action when the button is pressed. However, Observe how I have mistakenly provided the same alert message that is used for sign up on the login button component, hence overriding the onClick handler that the login button already defines. Now, can you guess what the message of the alert will be when I click on it? I'll give you a few seconds to think about it. Well, if you guessed logging in, you guessed right. The reason is that even though I have overridden the onClick prop in the login button component, its implementation is done in a way that prevents that overriding from happening. Why is that? Because of the order of the spread operator. If I go ahead and spread the props at the end instead, right after onClick, the behavior is different and signing up is output instead. So what are the main takeaways from this lesson? The spread operator is a great tool that enables the creation of more flexible components, especially when forwarding props automatically to other components that expect them, as well as providing your consumers with a nice component API. However, keep in mind that depending on the order of the spread, the behavior may differ, so you need to be conscious about your decision when it comes to component design. In the example of the login button before, it may make sense to prevent the override of the onClick property, but it may not be the intended case for other props. Well done. I hope you're getting an idea of the multiple benefits that can be gained from using these React tools. When building React applications, you will find yourself creating some generic functionality that is not related to the application's business logic and that is needed in many places. For example, think about managing different permission roles, handling errors, or even logging. They are all required for any application, but are not necessary from the business point of view. This group of functionality is what falls into the category of cross-cutting concerns. In this video, you are going to learn about cross-cutting concerns and why components, despite being the primary unit of code reuse in React, aren't always a good choice for this kind of logic. You will also discover why new patterns were introduced to solve this problem. Excited to learn more? Well, let's get started. Imagine that you are tasked with building the logic to display a list of live orders for the Little Lemon restaurant app. Let's explore how this could be achieved. Here is a valid implementation for a live orders list, where local state is used for storing the current list of orders, and useEffect handles both the subscription and unsubscription to the live data, updating the order's value as soon as a new order arrives. Now, imagine that Little Lemon also needs a place in the application to keep track of the number of users subscribing to its newsletter in real time. This could be a valid implementation for such functionality. Can you identify any similarities between live orders list and newsletter list? They are definitely not identical, since they call different methods on data source and render a different output, but much of the implementation is the same. Upon examination, they both add a change listener to data source on mount, set new state whenever the data source changes, and remove the change listener on unmount. You can imagine that in a large app, the same pattern of subscribing to data source and setting local state with new data will occur over and over again. So far, you have seen that a custom hook to encapsulate that logic is one of the solutions at your disposal. However, that introduces the issue of having to alter the implementation of each component that needs that data, and thus making all of them stateful. So how could you define the subscription logic in a single place, share it across many components, and keep them unchanged and stateless? Well, this is where higher order components are a perfect solution. A higher order component, also known as a HOC, is an advanced pattern that emerges from React's compositional nature. Specifically, a higher order component is a function that takes a component and returns a new component. Whereas a component transforms props into UI, a higher order component transforms a component into another component. In other words, it enhances or extends the capabilities of the component provided. Let's go ahead and examine how the implementation of this reusable subscription logic would look with a higher order component. With subscription is the higher order component that takes the wrapped component you would like to enhance with subscription capabilities, as well as a select data function to determine the type of data you are getting from the data source, in this case, either orders or users. With subscription then returns a new component that renders the provided component and supplies a new prop to it called data that will contain the most recent list of items from the data source of interest. It also passes other props through to the wrapped component, which is a convention in HOCs. That's the implementation. But how about its usage? In this case, you would define two different components configured with custom parameters, one for live orders and another for newsletter subscribers, all without having to repeat the subscription implementation in either live orders and user list, making this a much more efficient solution. There is still one more pattern for cross-cutting concerns that you will learn about soon, called render props. Great! In this video, you have learned about cross-cutting concerns and why components are not always enough for reusing behavior. You also explored one alternative pattern to encapsulate common behavior in React applications, which are higher-order components.
The Little Lemon restaurant is receiving a spike in visits to their website during the last month due to customers loving some of the special pizzas the chef presented to the public. Despite the success, there are some pizzas that aren't receiving the same level of attention, so they have decided to implement some basic analytics to better understand which are the best sellers and which ones are not being ordered so regularly. For that, they would like to track the mouse position of the visitors when they are in the pizza section so that they know exactly which pictures are capturing people's attention and which ones are overlooked. In this video, I'm going to show you how to implement such functionality by using a higher order component, or HOC, which will be in charge of encapsulating the logic and state to track the cursor position of the visitors. Then I'll showcase two different presentational components that will consume that data and present it in different ways. Are you ready? Let's begin. The little application has been created with Create React App. So far, in the rendering part of the app component, there is a header displaying the title of the restaurant and two components, Panel Mouse Logger and Point Mouse Logger. They both expect a mouse position prop and will return null if that prop is not provided. That's why at the moment they don't render anything at all. You could implement the mouse tracking logic in each component, but recall that it would incur code repetition and duplication of the same logic in two different places. That's why the recommended approach is to use one of the techniques that React provides for encapsulating cross-cutting concerns. In this example, I will illustrate how to do this with an HOC. I will call this HOC with mouse position. The with part of the name is a general convention recommended by React since it expresses the enhancing nature of the technique, like providing a component with something else. Recall that an HOC is essentially a function that takes a component and returns a new component. Let's complete the initial scaffold and return a component that will render the wrapped component provided to the function without forgetting to spread the props it receives so that they're passed through. Great. Now to track the position of the cursor, I would need to define a new piece of local state, which I'll call mouse position for the data and set mouse position for the state setter. The initial state will be an object with two properties, x and y, to define the two-dimensional coordinates on the screen, and I will set both to 0. X equals 0 and y equals 0 represents the top left corner of the screen. Next, I would need to set a global listener in the window object for the mouse move event. Since this is a side effect, I need to perform the subscription and unsubscription logic inside useEffect. Let's go ahead and do that. I will add a new event listener for mouse movement to the window object. For the callback, I will name the function handle mouse position change. That for now doesn't do anything. It's important to remove any subscription when your component unmounts. The way to do that is by returning a function from useEffect and then performing any cleanup needed. In this case, I would have to use the window.remove event listener, passing as arguments the mouse move event and the same callback function as before. To complete the logic and set the state with current mouse position, I need to read that information from the browser event object, which is passed as an argument to the callback. That event object contains two properties that define the coordinates, client x and client y, so I will assign both of them to the corresponding dimension. And finally, the last step to complete the implementation is to set a new prop called mouse position in the wrapped component to pass that information down to all components that are interested in that data. Great, so now that the implementation of the HOC is finished, let's add the last few pieces to display the mouse position on the screen. To enhance the two components previously defined, panel mouse logger and point mouse logger, I will use the HOC to create two new component versions that will be aware of the mouse position data, and I'll call them panel mouse tracker and point mouse tracker respectively. Finally, I will use the enhanced versions in the rendering part of the app component. Amazing! The requirements are now finalized. If I move the cursor around the screen, you can see two different trackers that display the same information in different ways, one as a panel and the one below as a data point. Well, that's the end of this video. Little Lemon Restaurant now uses this solution to track their pizza-loving customers and have discovered that something was affecting the sales of their pizza Diavola. Guess what? After an employee investigated that particular pizza on the app, they noticed that one of the photos was a bit blurry. Thanks to this little tracking application, they have now taken action and uploaded new high-quality photos, so the next time a customer is exploring the menu, they won't miss the pizza Diavola.
So far, you have learned about a technique called higher order components that is used to encapsulate common functionality. But it's not the only one available to you. For example, you can choose between different eating utensils depending on the type of food you're eating. Some chopsticks for your favorite sushi dish, or a fork for a delicious carbonara. But there's nothing wrong with using a fork for eating sushi. After all, not everyone has learned how to use chopsticks, and it's the tool that makes the job easier that matters. Well, this is also the case when it comes to code reusability. There are several tools you can use to share code between React components, and in this video, you are going to be introduced to a new one, the render props pattern. Say the Little Lemon Restaurant is looking for a way to keep count of all the items it has on the menu. They would like to display this information in the application so they know when they need to replenish stock and to make it easier for customers to see what is or isn't available at any given time. That information is stored on a server, so we would have to be fetched first prior to displaying it. There are various ways to define the fetching logic, like a higher order component. However, render props is also a powerful technique you can leverage to reuse common code. The render props technique is so appropriately named that it's almost self-explanatory. It's about using a prop called render with a particular attribute that it has to be a function. To be more precise, a component with a render prop takes a function that returns a React element and calls that function inside its render logic. For example, a meal provider component could use this pattern. If you remember, a higher order component enhanced a component by providing new props into it. With render props, however, the new props are injected dynamically as the parameter of the function. You may already have recognized some similarities between the two. The end goal is the same, to enhance components without modifying their original implementation. The way in which they inject those new props or enhancements is what differs. To better illustrate this point, let's explore an application that showcases the implementation of a component that uses a render prop. In this example, the Little Lemon Restaurant would like to keep a count of all the desserts and drinks that it has in the menu. That information will need to be fetched from a server that they control and displayed in the application with a single piece of text. The logic for fetching data is one example of a cross-cutting concern. Multiple components may depend on data that lives somewhere else, but you don't want to implement the same fetching logic over and over in every component that needs it, right? This is a good place to use the render props pattern to abstract this functionality. To showcase how it works, I have created a component called DataFetcher, whose only purpose is to fetch data based on a URL. This is one of its props, but it's the second one that should catch your attention, and that's the render prop. I'm not fetching real data in this example, but I have created a mock if-else statement that will return either a list of all desserts or drinks available based on the URL path. As usual, this fetching logic is a side effect that should be placed inside useEffect. Finally, let's move to the return statement. This is the unusual part. The component is returning the result of calling the render function and has no other rendering business. This is what makes it very flexible. DataFetcher only has one purpose, fetching data. And the way they receive it is via the argument in the render function, which is the local state used to store the list of desserts or drinks. It's then up to the developers to decide how they would like to present that data on the screen. Finally, Let's explore the two presentational components I have defined to show the number of desserts and drinks available in the menu. The desserts count component uses a particular endpoint to fetch desserts and uses a paragraph element as the render prop, displaying the number of desserts as a single text. The same applies to the drinks count component, with the difference being that it utilizes another URL and instead shows a header element reflecting the number of drinks. Finally, the app component renders both of them, and the results are displayed on the screen. You have learned about another technique you can use in addition to higher order components, which is the render props pattern. Hopefully, now that Little Lemon keeps a live count of drinks, they can replenish their fridge with your favorite refreshments. As the developer for Little Lemon's restaurant application, how could you guarantee that the app you created works as intended? Well, you may choose to rely on your methodical ability to manually interact with all the different parts of the application yourself, ensuring the app is fully functional. However, manually testing every new incremental change you'd like to make is likely to be tedious, error-prone, and time-consuming, especially as your app grows in complexity. That's where automation tests come in. So in this video, you will learn how to write tests properly for your React components. You will achieve this by exploring why testing is important and best practices when creating tests, being introduced to the tools Jest and React testing library for structuring your tests, as well as working through a practical example of testing a component using these tools. Just like factories perform testing of the products they build to ensure that they work as expected, developers need to do the same with their code. A well-designed suite of automation tests is particularly effective in allowing you to discover defects or bugs before delivery to the client. In doing so, testing is important for guaranteeing the quality of the software you develop. Further, by catching bugs before they find their way into a live application, testing reduces the number of user complaints and can ultimately save an organization time and money. Now that you have an idea of why testing is important, what are the best practices you need to keep in mind when writing your tests? The first is that your tests need to avoid including implementation details of your components. React is just a tool, and your final users will have no notion that React exists at all. So rather than dealing with instances of rendered React components, your tests should work with actual DOM nodes. Secondly, the more your tests resemble the way your software is used, the more confidence they can give you. Finally, you also want your tests to be maintainable in the long run. So, as long as you're not changing functionality, any changes in the implementation of the component won't break your tests and slow you and your team down. Now, let's explore the two tools that React endorses to structure your tests, Jest and the React testing library. Jest is a JavaScript test runner that lets you access an artificial DOM called JS DOM. While JS DOM is only an approximation of how the browser works, it is often good enough for testing React components. Jest provides a good iteration speed combined with powerful features like mocking modules, so you can have more control over how the code executes. Recall that mocking refers to something made as an imitation and enables you to replace complex functions from your code with others that are simpler and simulate the same behavior. Mocking features can be used to make sure that your unit testing is standalone. If you'd like to revisit the concept of mocking in greater depth, you can check out the additional resources at the end of this lesson. The second tool is React Testing Library, which is a set of utilities that let you test React components without relying on their implementation details. React Testing Library has been designed to fulfill all the best practices highlighted before, so that you get a well-configured testing environment out of the box and are able to focus on the business logic your tests need to run assertions on. With the theory covered, let's go ahead and implement a test from scratch using Jest and React Testing Library. When you start a new project with Create React App, you already get both Jest and React Testing Library pre-installed by default. Plus, both tools are already pre-configured, and there is an example test file in your root folder called app.test.js. Imagine that Little Lemon has made an agreement with a popular restaurant aggregator to have its web page included as a new URL in its listing. In the app.js file, the app component renders a link in the page that points to Little Lemon's web page. Let's go through the test I created to automatically verify that the link is always present. The first thing I need to do is to import both render and screen from the React testing library. The render function is used to render the component you would like to test and perform assertions against. Because querying the entire document.body is very common, React Testing Library also exports a screen object, which is a reference to that object and has every query pre-bound to it, meaning that it will automatically ask the whole document when running a search. Now, to wrap the test scenario, Jest provides the global test function, which takes a text description as the first argument and a function to compose all the steps your test needs to go through as a second argument. This function does not need to be imported, since Jest injects it automatically in all your test files. The first step is to render the app component in the artificial DOM environment. Secondly, I use the screen object to create a query against the document.body. In this case, I am using the getByText utility to ask the body tag of the document if it can find an element inside with a string called Little Lemon Restaurant and store the result of that finding in the link element object. If the search is successful, getByText will return the found element. Otherwise, it will return null. Finally, to complete the test, I perform an assertion asking whether the link element from the query above is present in the document, meaning whether it's currently visible on the screen. For that, the global expect function is used. This is another utility that Jest incorporates globally without the need for an explicit import. The expect function receives the result of a query and appends a specific matcher. In this example, the matcher refers to an element visible in the whole document. If I run the test, it fails. Okay, let's check the output logs to try to understand what has gone wrong. It states that it was unable to find an element with the text Little Lemon Restaurant. Interesting. Let's go ahead and check the app.js component again. Aha! I had made a mistake and typed orange instead of lemon, something that the test was able to catch. That's exactly what you want to see when a failure occurs. Also, you might have noticed how straightforward it is to write your test assertions. Everything you see in code translates nicely to how a real user would interact with your app and responds with the behavior that you would expect. Let's run the test again now that the issue is fixed. Great! The test passes and Little Lemon's online exposure is about to grow even more. In addition to the importance of testing and testing best practices, you have now learned how to test your React components using Jest and the React Test library. Stay tuned, because soon you will discover how easy it is to write more complex tests.
Imagine that the Little Lemon restaurant started receiving a few bad reviews from its customers. The problem is that they could not figure out what was wrong and act accordingly, since users only provided a low numerical score, skipping the part of providing additional feedback and passing that information to the chefs. In order to solve that, they've decided to make the comment text box mandatory as long as the score provided by their users is lower than 5 in a scale to 10. Additionally, they would like to shield this new logic with automated tests, so whenever any changes are performed, the test suite would run and be able to catch any potential errors incurred by a faulty update. So the application consists of a feedback form that contains a range input for a numerical score ranging from 0 to 10 and a text box to incorporate additional comments. To satisfy the requirements desired by Little Lemon, the submit button will be disabled if the score is lower than 5, forcing users to add a comment of at least 10 characters. Now let's examine the code. The entry point is the app.js component, where I'm rendering a feedback form component. This component receives a prop on submit, which is a function that contains the values of the form as parameters, so that the parent app component can perform the submission. The feedback form represents an HTML form and includes two controlled components via local state, a range input and a text area. There are two pieces to highlight in this component. The first is the button disable logic. IsDisabled is the variable that controls that state and is set to true if the score is lower than 5 and the comment has less than 10 characters. The other important piece is the handle submit function, which is hooked into the form onSubmit attribute. When the submit button is clicked, the handle submit function will be called. This function itself calls the prop function provided by the parent with the corresponding form values. Well, it's clear that the feedback form component contains all the business logic of interest, so let's go ahead and write a test for the submission logic. The convention for tests is to create them inside a file that has the .test extension. That way, Jest, the test runner, is able to pick them up automatically when you run the test command in your terminal. As I have already written a test scenario, I will now walk you through each line of code so that you understand how the test is structured step by step. The test scenario is checking that users are prevented from submitting the form right away if the score is lower than 5 and there is either no additional feedback or it's too short. First, I create a new mock function with Jest. Recall that a mock function is a special function that allows you to track how a particular function is called by external code. When the feedback form calls the function you provide as the onSubmit prop, you will be able to explore the argument passed in the call. Then, I render the feedback form and pass the mock function as the onSubmit prop. The following steps are needed to locate the range input and fill it with a value. Notice that to find the input, I'm using the screen.getByLabel text and passing a regular expression to match against. Screen is a utility object from React testing library that represents the whole page, which basically translates to asking the root document to find a label tag whose text contains the word score, and then return the input element associated with that label. To fill the input with a value, you have to use the fire event utility from React testing library and call the change function. While React control components update their state via the onChange prop, React testing library follows a slightly different convention, removing the on part and having the update method as lowercase. To simulate the form submission, I have to locate the button element. Observe how I'm using a different query method, getByRole, which looks at elements with a specific role attribute. This will work well since the HTML button already has the button role internally set. To simulate the event, I need to provide two arguments. First, the input element in question, and second, the browser event object, which holds the new value as target.value. To perform a button click, I have to use fireEvent.click. It follows the same convention as before, removing the on side of the prop and having everything in lowercase. Great, the final two statements are the assertions of the test. The first one illustrates an example of an expect matcher that wants to check the opposite by prepending the not before calling the final matcher. What it's asserting is that the function that handles the submission of the form has not been called, which is what I'm expecting when an additional comment has been omitted. Furthermore, I have added a second assertion to make sure the submit button is indeed disabled by using the toHave attribute matcher. And that's it. Well done for reaching the end of this demonstration. In this video, you learned how you can shield your business logic with a few lines of powerful code thanks to the React testing library. And what's more important, it has enabled the chef at Little Lemon to finally receive the necessary feedback and make sure all the new pizzas have a bit more extra cheese on top. So I am passionate about style guides. I actually used to be really bad and really used to dislike them and think like they're not important. But now if I see something that's out of style, I like really notice it, and it's like to me it's very frustrating. So now I take them seriously. My name is Murtada. I'm a software engineer at Meta based in the Seattle office. So a lot of the times people think style guides are silly or useless, and they may not actually give them a lot of value. I see this with a lot of new developers when I'm reviewing their code. A lot of my comments are actually about styling, and it may seem like I'm being annoying or I'm being nitpicky about unimportant things, because following style doesn't functionally change the way code works. It just changes the way the code looks. And so people are like, well, why does it matter? This still does the same thing. But it matters because it makes code much easier to read. It makes code much easier to debug and work with. And this is a big deal because a lot of times when we're writing code, we're not just writing it for ourselves, we're writing it for other people. So paying it up front and taking the time to style your code correctly is really worth it. One of the things we look for in following style guides is to make sure that code is self-documenting. And that really helps so that developers are not taking the time to write comments and being elaborate in explaining things, where if you look at the code, you can understand it and read it, and it documents itself just by the way that variables are named or by the way functions are structured. And that's really important because it removes the burden from the developer to write documentation, and it also removes the burden from other developers to read the documentation. It also makes it easier to fix problems when somebody new is looking at the code. And a lot of times we write code and then we don't keep writing it or improving it or maintaining it. Somebody else comes. And so it's a service to the people that come after us that we write code in a clean, well-styled way so that when they look at it, they're actually able to understand it easily. At Meta, we have a team or a bunch of teams that are kind of the owners of setting the style guides to make sure the company is following similar or consistent guides across the different code bases. Because style guides are one of those things that could involve different opinions and tastes and different ways to achieve the same thing, we want to be consistent. Even if there's multiple ways to do the right thing, we want to choose one way and stay consistent across our code base, just so that developers are not confused when they look from one part of the code base to another. Everyone at Meta is using or following the style guides that are created and managed by the teams responsible for them. So I'm an engineer developer, and I'm daily following and using these style guides just like everybody else in the company who's writing code. Learning about coding and style guides, it may seem like, why do I need this? And it's actually not that complicated. You need it because it's like an investment. Following these style guides and adhering to them and learning the good style guides will make a big difference in the application, in its stability, usability, readability, as well as anything that you do in the future to improve it, whether you're adding new features or you're fixing a bug. So it may seem like it's the unimportant part of developing and writing software, but it actually makes a big difference if you're writing code for the long term.
Well done. You have reached the end of this module on React JSX, Advanced Patterns and Testing. Let's take a few minutes to review what you have learned so far. You began the module with an in-depth lesson on JSX. You were presented with a distinction between components and elements. You learned that components are functions that take data or props as an input and return a tree of elements as output. You also learned that elements are just plain JavaScript objects that offer a lightweight representation of the DOM and let React update your user interface in a fast and predictable way. Next, you discovered the importance of component composition and the use of the children prop. You were introduced to containment and specialization, the two main properties that component composition has. You learned that containment is a technique that is applicable to components that don't know their children ahead of time, like a dialog or a sidebar, and that it uses the special children prop to pass elements directly as their content. You were also introduced to specialization, a technique that allows you to define components as special cases of other components, like creating a confirmation dialog based on a dialog. Then you moved on to a lesson about manipulating children dynamically in JSX. Here, you were introduced to a couple of new React APIs, react.cloneElement and react.children. You learned that react.cloneElement clones and returns a new element, allowing you to manipulate and transform elements directly in your JSX. You also learned that react.children.map is useful for children manipulation, and that when used in conjunction with react.cloneElement enables a powerful composition model for creating flexible components. You worked through a practical example of those two APIs, where a row component was implemented to separate its children evenly. Finally, you were introduced to the spread operator in React. You learned that the spread operator enables two main operations in objects, copying and merging. You then saw how React uses that operator to spread all the props instead of having to type them manually one by one. Finally, you were presented some practical examples that illustrated how the spread operator allows the creation of flexible components. You then moved on to a lesson on advanced patterns to reusing common behavior. The lesson started with an overview of cross-cutting concerns in React. You learned that cross-cutting concerns refers to generic functionality that is not related to the application business logic and that is needed in many places, like handling errors, authentication, or fetching data. You understood why components, despite being the primary unit of code reuse in React, don't fit this type of logic. After that, you were presented with 2 techniques for cross-cutting concerns. The first technique you were introduced to was the higher-order component technique, which you learned enables a powerful abstraction for creating cross-cutting concerns. You were also presented with an example of how data fetching can be abstracted using this technique. As part of a practical lesson on higher-order components, you learned that a higher-order component is just a function that takes a component and returns a new one. You were presented with a required code structure to create a higher-order component and examined an application of a higher-order component that handled the position of the mouse pointer on the screen. Then, you learned about the second technique for cross-cutting concerns called render props, which is a special prop you add to your components with a particular attribute of being a function that returns a React element. You discovered that, as opposed to higher-order components, the new props are injected dynamically as the parameters of the function, and worked through a practical example where the render props technique was used to abstract the functionality of fetching data from a server. The module ended with a lesson on component testing using React Testing Library. The lesson began with a comprehensive explanation as to why React Testing Library is the recommended tool for your tests. You learned that to guarantee that your applications work as intended, a suite of automated tests is crucial. You were presented with best practices when it comes to testing, seeing how the React Testing Library has been designed with all of them in mind. Finally, you were introduced to a basic example of a test with Jest, the recommended test runner, and React Testing Library to illustrate the basic scaffolding of a test. The lesson on component testing concluded with a practical application of tests in a real-world example. With this, you learned how well-designed tests can catch errors in your code, providing you with the necessary context to fix them. You also discovered a more complex application that can be easily tested with a few lines of code. Then, you were presented with several APIs from React Testing Library, like screen to query on the global document, and different query types, like querying by text or querying by role. Lastly, you learned about different matchers for your expectations and assertions, like to have been called for mock functions and to have attribute for attributes in your elements. Fantastic work! Congrats for getting to this point in the course. It's time to use everything you have learned so far and build some amazing applications. In this course, you learned about advanced React. Let's take a few moments to recap the key topics that you learned about. In the opening module, you received an overview of components. During the first lesson, you received an introduction to the course. You discovered how to set up a project in VS Code, and you learned how to make the most of the content in this course to ensure that you succeed in your goals. You then moved on to the next lesson, in which you learned how to render lists in React. In this lesson, you learned how to transform and render list components, create a basic list component, and you learned about keys within list components in React. In the next lesson, you explored forms in React. First, you learned about the differences between controlled and uncontrolled components. Next, you discovered how to create a controlled form component in React, and then had a chance to test your skills by creating your own registration form. In the last lesson, you learned about React context. You explored props and state and how they relate to context. You also learned how re-rendering works with context, and you applied your knowledge to create a light, dark theme switcher. Next, you began the second module, which covered all the common hooks in React and how to build custom hooks. In the first lesson of this module, you got started with hooks. You learned how to implement the useState hook to work with complex data and apply this knowledge to manage state within a component. You also learned about side effects and the useEffect hook. In the next lesson, you moved on to the rules of hooks and fetching data with hooks. You discovered the essential rules of hooks and how to use them effectively in your solutions. You also gained an in-depth explanation on how to fetch data using hooks and tested your skills in fetching data in a practical exercise. In the final lesson of the module, you enhanced your knowledge and skills with advanced hooks. You learned about the benefits of the useReducer hook and how it differs from useState, and how to access the underlying DOM with useRef. You then built your own custom hook, usePrevious. In the third module, you explored JSX in more detail and how to test your solutions. In the first lesson, you took a deep dive into JSX. You gained a more detailed overview of JSX, components, and elements. Next, you explored component composition with children, with its two key features, containment and specialization, and how to dynamically manipulate children in JSX. You had the opportunity to apply your new skills when building a radio group component and were introduced to spread attributes in JSX. In the next lesson, you focused on reusing behavior. You learned about cross-cutting concerns in React and explored higher-order components and how they're used to great effect. You also learned about a specific HOC called render props and used render props to implement scroller position tracking in a solution. In the final lesson of this module, you were introduced to integration tests with React Testing Library. You discovered Jest and the React Testing Library. You wrote test scenarios for a form and were introduced to continuous integration. You've reached the end of this course recap. It's now time to try out what you've learned in the graded assessment. Good luck.
Let's now work through what I've produced, and please, if you find something that inspires you, don't hesitate to incorporate it into your own solution as well. Alright, let's get started. I'm using a UI library, Chakra UI, that offers a preset of styles for your React components. That allows me to avoid worrying too much about CSS and focus on the business logic for my portfolio page. Let's have a quick overview of the whole application. The layout consists of a header that contains links to all my relevant social media accounts and links to the different sections of the page. There are 3 full screen sections: a landing section with a profile picture and a quick description about myself, a project section with a list of all past projects I've worked on, and finally, a contact me section to allow visitors to contact me by filling out a simple form. Finally, there's a footer at the bottom. This application level layout is defined at the entry point, the app.js component. Besides the 2 providers at the top, everything inside the main tag translates to the different UI boxes that I described previously: header, landing section, project section, contact me section, footer, and alert. The alert component plays the role of a global dialog that I can trigger from anywhere in the application using React context. Let's go into each section, top to bottom, starting with the header component. Its rendering section begins to illustrate one of the compelling points from the Chakra UI library. First, Chakra provides you with generic boxes, like box, hstack for horizontal stacks or rows, and vstacks for vertical stacks or columns, that use the special children prop to place their content as you wish using properties such as padding, margin, or spacing. Secondly, Chakra uses props for all CSS styles as well as additional ones like spacing to evenly separate a group of children siblings, or in other words, add similar gaps between them. I'm rendering a list of social icons using the map function, picking as key their URL, which is unique per item. Now, if you examine this rendering, you will find 2 of the core React hooks, useRef and useEffect. Those 2 are used in conjunction to achieve this smooth animation of the header. You can find out more about the implementation details in a further reading. Okay, let's now check the next component, landing section. There's nothing particularly special about this component, it's just a presentational component that encompasses the whole screen height and lays an image and text in the center. Still, there's a great component I created that uses some of the techniques you have learned, the full screen section component. Here's a component that leverages both the children prop and the spread operator. Its goal is pretty simple, to create a full screen container box with 1280 pixels as width, with a specific background color and text color depending on whether the background is dark or light. The spread operator allows you to pass down other layout props to the vertical stack component in case you would need further customization. Next, there is project section. This is another presentational component that renders all my featured projects in a grid layout. And finally, I will move on to the star of the show, the Contact Me section component. This is probably the most interesting component of them all, since it implements a controlled form with validation and handles some aspects of internal state. To simplify the form business logic, I have decided to use another library that is well known within the React community, Formic. Formic is the most popular open source form library for React, and it stands out due to its declarative nature, allowing you to spend less time wiring up state and change handlers and more time focusing on your business logic. Looking at the application, I have added 4 inputs: one text input for the first name, another text input for the email, a select input to pick the type of inquiry, and finally a comment text area. To define the configuration of the form, you would have to use the useFormic hook. This hook takes a configuration object that is intuitive and easy to follow. Initial values defines the initial state of the form. OnSubmit is a function that will be executed once users click on the submit button, and validation schema specifies the validation rules for this form on the client side. Formic works very nicely in conjunction with Yup, a library that lets you define your validation in a declarative way using a chain of operators. The hook returns a Formic object that is what you have to use to wire up your inputs with the Formic internal state. Now let's explore the business of rendering. I have grouped each input into a form control component, which is imported from Chakra. For example, the first name has a label, the input itself, and a component to display any error messages occurring for that particular input. The isInvalidProp in the form control determines whether the error message is shown or not. For the first name, it would happen if there is an error according to its validation rules and it has been touched, meaning the user has already focused the input at least once. And the input component, I would have to hook the state and change handlers by using formic.getFieldProps with a value of first name as the parameter, which would have to match the property name used in initial values, and spreading the result, which is an object with all the props you need to connect from Formic. So if I go to the form, focus the first name input, and then blur it, an error message pops up on the bottom with the hint required. Nice, isn't it? The remaining inputs follow a similar pattern, so I won't focus too much on them. Finally, we have the form submission. Remember the onSubmit property from the useFormic hook configuration. That's the function that will be called when the form is submitted. In that function, an API call is performed to the endpoint to submit the form along with the form values. Finally, the useEffect hook listens to changes in the response value, and once the server responds, it will open an alert showing a dialog with a confirmation or an error message. This API call is just a simulation for the purpose of the exercise and is programmed in a way that has 50% chance of being successful. If the response is successful, the form is reset and cleared using the resetForm function from the Formic object. Well, let's explore the form in action. I will fill the form with values, click Submit, and voila! Here's the alert. We can try again to show the opposite state. So there you have it. This is one possible solution to the portfolio exercise. I'm really looking forward to seeing which approach you took to complete this challenge.
You've reached the end of this advanced React course. You've worked hard to get here and developed a lot of new skills along the way. You're making great progress on your front-end developer journey, and you should now understand how to use more advanced React features, test your React applications, and use JSX more proficiently. You were able to demonstrate some of this learning along with your practical React skill set in the lab project. Following your completion of this course in Advanced React, you should now be able to render list and form components efficiently in React, demonstrate how context provides a way to share global values between components with a defined API and potential applications, use all common hooks in React and put them to use within your application, and build your own custom hooks. The key skills measured in the graded assessment revealed your ability to understand JSX in depth, use advanced patterns to encapsulate common behavior via higher order components, and render props, write tests for your application, and build a portfolio using React. So, what are the next steps? This advanced React course has enhanced your knowledge and skills in several key areas. You probably realize that there's still more for you to learn. So, if you found this course helpful and want to discover more, then why not register for the next course? You'll continue to develop your skill set during each of the front-end development courses. In the final lab, you'll apply everything you've learned to build your own fully functional website using React. Whether you're just starting out as a technical professional, a student, or a business user, the course and projects prove your knowledge of the value and capabilities of front-end development. The lab consolidates your abilities with a practical application of your skills. But the lab also has an important benefit. It means that you'll have a fully operational website built using React that you can reference within your portfolio. This serves to demonstrate your skills to potential employers. And not only does it show employers that you are self-driven and innovative, but it also speaks volumes about you as an individual, as well as your newly obtained knowledge. And once you've completed all the courses, you'll receive a certificate in front-end development. The certificate can also be used as a progression to other role-based certifications at Meta. Depending on your goals, you may choose to go deep with advanced role-based certifications or take other fundamental courses. These certificates provide globally recognized and industry-endorsed evidence of your technical skills. Thank you. It's been a pleasure to embark on this journey of discovery with you. Best of luck in the future.